All right, people. I believe all of you are doing great, having a good time. So, today we have an important chapter that is what we call the kinematics, okay? And this is one of the most important chapters when it comes to the NEET physics. You can expect 2 to 3 questions from this particular chapter, and we will not finish only kinematics 1D, but we will finish both when it comes to kinematics. We say 1D and 2D. Okay. So projectile motion as well as motion along a straight line, both will be finishing in this marathon. I would want you guys to smash the like button and watch this till the end. I will be starting from the scratch, okay? And I'll take you from the basics. You don't have to worry about anything at all. So let's dive into this session. If you haven't studied this before, you would be able to understand each and every single thing. That is my guarantee. Okay. So my dear friends, let's get started with the kinematics 1D and 2D, both motion along a straight line and a projectile motion. I've shown you all types of graphs. Okay. I've shown all categories of problems in this one. So let's dive into this session. Okay. Without wasting any time. The first topic, now see. Let me just tell you over here, my dear friends, when it comes to the kinematics, understand very carefully. When it comes to the kinematics, we say, what is this kinematics all about? Okay, what is this kinematics all about? Guys, let's suppose I have got a car exactly over here. I would want you guys to understand each and every single thing very carefully. Just a second, I'll fix up the settings of the camera. Yeah, cool. Fine now. Yeah. So guys, when it comes to the kinematics, let's suppose I have got a car exactly over here. And this car is, let's suppose, in motion. It is in motion. Okay. Means this car is changing its position with time. As it is moving forward, the car is in motion. That's what I'm trying to say. And my dear friends, when the car is in motion, what do we actually talk about over here? We say, sir, how much is the displacement of the car? How much is the distance covered by the car? How much is the velocity of the car? How much is the speed of the car? So all of these things we talk about a car in motion, okay? So these are the terms related to the motion. So whenever we discuss about displacement, distance, velocity, so means we are talking about the kinematics. So in kinematics, we basically talk about motion. It is simply study of motion. It is study of motion without knowing the cause. Okay, cause means if the car is moving, sir, why is it moving? Is there any force which is acting on the car? So that we study in Newton's laws of motion. So simply remember, when it comes to the kinematics, we talk about motion. And what do we study in motion? We say, sir, displacement of the car. If the car is in motion, how much displacement it will cover? How much distance it will cover? We talk about the velocity, how fast the car is moving, how fast the velocity is changing. So all of these things we discuss in the kinematics. Guys, please tell me in the chats, is everything crystal and clear till over here? And I would want you guys to basically hit the like button, because liking this session is extremely mandatory. Okay, liking this session is extremely mandatory. Everyone means everyone. So now guys, understand very carefully what I'm going to discuss over here. The very first topic, we'll be finishing this chapter in only 3 parts. The very first topic that we need to understand over here is, see guys, The first thing we need to understand over here is that is frame of reference. Frame of a reference. Frame of reference. Guys, understand very carefully. Understand very carefully. Let's suppose I say, this is the car. This is the car over here. Guys, the first topic that we are understanding over here is frame of reference. Let's suppose we have got a car over here. I am saying from this point, this car is, we say, sir, 10 meters away. From this point A, we say, sir, this car is 10 meters away. Okay. I'm saying that, let's suppose we have got a point B over here. I'm saying that from the point B, this car is, let's suppose, 15 meters away. Sir, what is this point? We say, if we consider this as a frame of reference, then we say this car is, we say, 10 meters away. I hope you are getting me. And when we talk about this point, when we consider this as a frame of reference, so we say this car is 15 meters away. So frame of reference means with respect to what we are talking about. With respect to what we are talking about. It means with respect to what we are talking about. Okay. Like here, we say with respect to this point A, the car is at 10 meters. The displacement of the car is 10 meters. I say with respect to the point B, the displacement of the car is 15 meters. So here, this is frame of reference, and in this case, this is frame of reference. I hope this is clear. Guys, tell me, frame of reference can be anything. You can consider there is a tree. Sir, the distance between me and that tree is, we say, 10 meters. So in this case, that tree is frame of reference. Sir, can a frame of reference be a table? Yes. If I say the distance between me and that table is 15 meters, means that table will be in that case frame of reference. Guys, tell me in the chats, give me the signal. Is this crystalline clear? Is this crystalline clear? Everyone means everyone. And hit the like button if you have not liked the session, and I would want you guys to hit the like button as soon as possible. Is this clear till over here? Is this clear till over here? Okay. Now, next. What we need to understand is that is what we call observer. That is what we call observer. Sir, what is this observer all about? Guys, see. Observer means who is observing the situation. Who is observing the situation? See, guys, let's suppose I have got a car. This is a truck, exactly. Bus. Okay. And this bus is in motion. Understand very carefully, my dear friends. This bus is in motion. And in this bus, we have kept the person A, and there is one more person, it is B. In this bus, we have got two people. First one is A and another one is B. And there is another person which is exactly on the ground, which is at rest over here, and its name is C. Now, when I ask this person B, I ask the question to this person B, tell me, is A in motion or at rest? Guys, see, bus is in motion, so means A is in motion. So when I ask this person B, bro, tell me, is this A at rest or A is in motion? Person B is saying, I can speak to the person A. He is sitting beside me, okay, on my side. I can speak to him. I can talk to him. I can share everything I want with him. So he is completely at rest. According to the person B, A is at rest. because both are sitting in the same car. We say according to, I say according to B, we say A is at rest. A is at rest. And now, my dear friends, listen to me very carefully. When I ask the person C, could you please tell me, is this A person at rest or is he is in motion? Person C is saying car is in motion. So obviously the person sitting inside the car is also in motion. So we say, I'll write over here according to C, I say A is in motion. A is in motion. So means, my dear friends, here we say, when we consider this as a observer, when this is observing the situation, in that case we say A is in motion. And when B is observing the situation, in that case we say A is at rest. So it depends who you are considering as an observer. When B is observer, in that case A is at rest. When C is observer, we say in that case A is in motion. So A is at rest as well as in motion. It depends with respect to what you are talking about. If you are considering A as observer, B as observer, then rest, C as observer, then motion. Okay. Yes. Now guys, I hope this is clear till over here. Now guys, one more important point I just want to clear over here. I say sometimes the observer can be also the frame of reference. Sometimes the observer can also be the frame of reference. Like I say if there is a person over here, this is person A, and there is an object which is placed, I say this object is placed at, we say, sir, 10 meters. This object is placed at 10 meters. Right now, if A person is saying that, hey bro, this object, this box is at 10 meters from me. So in that case, we say here, A is observing the situation, and with respect to the A, the distance is 10 meters. So here we say A is the observer, A is the frame of reference. And let's suppose let's suppose here, if I say the same person A, and the object is, let's suppose, at 15 meters. The object is at 15 meters. And there is another person over here, C. This person C is saying that with respect to the A, we say object is at 15 meters. In this case, I say C is the observer. Why? Because C is observing the situation. And we say A is the frame of reference. A is the frame of a reference. A is the frame of reference. Here, C is the observer and A is the frame of reference. And in this case, we say when A is saying, with respect to me, object is at 10 meters, means here, A is the frame of reference as well as A is the observer. Guys, please tell me in the chats if this is clear. Please, guys. Everyone means everyone. Guys, I need the signal from every single student. Okay? I need the signal from every single student. Whosoever is watching, I need the signal that if this is crystal and clear. Let me know in the chats. Great. Great. Now guys, understand one more thing. Observer is done. Definition of kinematics is done. Frame of reference is done. Let's talk about now the types of motion. Types of motion. Let's talk about the types of motion. Okay. Let's now talk about the types of motion. Guys, see. I'll make you understand what are the different types of motion. The first one is, that's what we call the one-dimensional motion. The first one is what we call the one-dimensional motion. One-dimensional motion. Sir, what is one-dimensional motion? Understand very carefully. Understand very carefully. Let's suppose, my dear friends, I have got an object exactly over here. There is a car which I have in front of me. And this car is, let's suppose, moving in the forward direction. Something like this. Something like this. It is moving horizontally in a straight line. We say, let's suppose if I make the graph over here. This is, we say, y-axis, and this is, we say, x-axis. I'm saying that this car is basically moving in the horizontal direction, something like this. I am asking you, how many coordinates of the car are changing over here? Let's suppose when the car reaches this point, we say here, value of x is, let's suppose, 4. Here, value of x is, let's suppose, 1. When the car reaches over here, value of x is, let's suppose, 6. So, car is moving along x-axis only. Car is changing only its one coordinate, x is equal to 1, x is equal to 2, x is equal to 3. Sir, is the car going up also? No. We say y coordinate of the car is same. It is same. It is not changing. But here x coordinate of the car is changing. So means this is what we call the one-dimensional motion. That motion in which only one dimension of the car is changing is called one-dimensional motion. Sir, what about this? What about this? What about this? Let's suppose there is an object which falls something like this. An object, it falls on the ground, it's a free fall. Sir, is it one-dimensional or two-dimensional? We say it is one-dimensional. Why? Because here only one of the coordinates of the ball are changing. Here, let's suppose value of y is, we say, sir, y is equal to 5. Then y is equal to 2. Then y is equal to 3. Then y is equal to 1, and so on. So only y coordinate of the ball is changing, decreasing. Here, initially 5, 4, 3, 2, 1, something like that. Okay. And we say in this case only x coordinate is changing. So I can write over here, when only one of the coordinates of an object, when only one of the coordinates of an object are changing, it is called 1D motion. It is called 1D motion. Okay, so it is basically motion along a straight line. It is basically motion along a straight line. A car is moving in the horizontal direction, we say it is one-dimensional motion. A ball is falling vertically downwards, we say it is also one-dimensional motion. Here y coordinate is changing, we say here only x coordinate is changing. We say here only y coordinate is changing. Here only x is changing, here only y coordinate is changing. Okay, great. Next we have, my dear friends, that is what we call the two-dimensional motion. Two-dimensional motion. Next is what we call the two-dimensional motion. Guys, understand very carefully. Let's suppose you have basically, this is y-axis and this is x-axis. Let's suppose you have thrown an object something like this, like projectile motion. You take a stone and you throw it in the air, and it basically goes from ground and falls onto the ground. So we have, let's suppose, launched a stone from the ground and it falls onto the ground. So we say this is the two-dimensional motion. Why? Because here two of the coordinates of the body are changing. Like, let's suppose when the object was over here in the air, when the object is in the air, okay, and in this particular case we say, sir, in X, body has covered this much of displacement. This is the horizontal displacement of the object when the object is exactly over here, that is X. And how high it has gone, this is the vertical displacement, that is Y. Here object is moving forward as well as object is moving upward at the same time. So that's why we call it the two-dimensional motion. When two of the coordinates of the body are changing. When the object is over here, this is the height of the object and this is the horizontal distance of the object. And I can write in this particular case, when two of the coordinates are changing. When two of the coordinates are changing, it is called, we say, two-dimensional motion. We say it is called two-dimensional motion, as simple as that. Okay. Now guys, then we have three-dimensional motion. Three-dimensional motion. Then we have three-dimensional motion. What is a three-dimensional motion? Guys, understand very carefully. I would want you guys to understand. We say when three of the coordinates of the body are changing, in that particular case, that is what we call the three-dimensional motion. Like, this is the x-axis, this is the y-axis, and this is the z-axis. If an object is going something like this, it is moving forward in x, it is going up also, and it is coming out also at the same time. So we say it is moving in three coordinates. So we say this is what we call the three-dimensional motion. So I write over here, when all the three coordinates, when all the three coordinates, example of this is basically projectile motion. And also circular motion. So we say when all the three coordinates, this projectile motion is the example of, we say, two-dimensional motion. We say when all the three coordinates of an object are changing, it is called, we say, three-dimensional motion. Okay. Example. Motion of a butterfly in the garden. Okay, if you throw the stone in air, that is the two-dimensional motion. Motion of a butterfly in the garden. What is the motion of the butterfly? Something like this. It goes forward in x. It goes high also. It goes upwards also. It comes out also. It is moving in all the three coordinates, all the three axes. So we say example, motion of a butterfly. Motion of a butterfly in a garden. Guys, hit the like button if you have not liked the session yet. I would want you guys to hit the like button as soon as possible. That is mandatory. Everyone means everyone. Is this crystalline clear? Let me know in the chats. Is this crystalline clear? Let me know in the chats. Everybody out there. Is this crystalline clear? Great, 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 great. I hope you guys are loving the session, okay? I hope you guys are loving the session. I'll make you understand each and every single point. That is my responsibility. Okay? So you don't have to worry about anything. Okay? Great, great. Now, guys, let's move on to the next topic. That is what we call the position. That is what we call the position. Sir, what does position actually mean? Position simply means the location of an object. Position simply means the location of an object. Let's suppose I say there is a person over here. I say there is a person over here. This person is A. And I say from this person there is an object which is placed, or there is a car which is at, we say, sir, 10 meters from this person. Now, I can say in this particular case, position of the car is at, we say x is equal to 10 meters. Position of the car is at x is equal to 10 meters, and with respect to we say person A, with respect to person A, because mentioning the frame of reference is extremely mandatory. You cannot say the position of the car is 10 meters because that is invalid, that is wrong. With respect to what? With respect to that person, because from that person till me the distance is 100 meters. So that's why I say with respect to A, the position of the car is 10 meters. So what is position? So I can write simply position. It is the location. It is the location. It is the location of an object. It is the location of an object with respect to the frame of reference. With respect to the frame of reference. Okay, so it is the position of an object with respect to the frame of reference. Like position of this object is at x is equal to 10 meters with respect to the A. A will be over here, the frame of reference. Okay, yes. Now my dear friends, if I say over here, if the position of an object is not changing with respect to time. If the position of an object is not changing with respect to time, means initially the object was over here, finally the object is over here also, then we say object is said to be at rest. Then object is said to be at rest. Then in that case object is said to be at rest. And if the position of an object is changing with respect to time, in that case we say object is in motion. I hope both of these points are clear. Okay, let's move on to the next one. See guys, enough. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everyone means everyone. Okay. Now, let's talk about displacement
let's talk about displacement, and before that, let's talk about distance. Distance, and from the either side over here, I'll write that is displacement. Here I'll write displacement and here I'll write distance. Guys, see. Let's suppose you live at this particular point. This is what we call A. This is your house and you live at this particular point A. And I say this is your friend's house, that is we say sir B. This is we say sir B. Now you have to move from A to B. You have to go from your house to your friend's house. So basically this is the road that government has made, and you are basically traveling through this path and you reach the point B. Now, this path is basically bit longer. So since if you are moving from A to B, you are covering the distance. Sir, how much distance you have covered? We say this much distance you have covered. Okay. Now, my dear friends, understand very carefully what I'm trying to say in this particular case. If I say this path is, we say, sir, bit longer. When you reach the point B, you are saying to your friend, what if there was a road between A and B which was something like this, exactly something like this, a straight road, and this straight road will be, in that case, we say, sir, the shortest distance between A and B. Sir, this person has traveled along this path. But when they reached over here, he is discussing with his friend, what if there was one distance? What if there was one road between A and B, which was something like this, the shortest path between A and B. The shortest path between A and B. So we say, my dear friends, listen to me very carefully. This distance between A and B, which is having a proper direction, see, it is pointing towards B. It has a proper direction. This is what we call the displacement. This is what we call the displacement. So displacement is simply the shortest path between the initial point and the final point. And this was the path through which that boy actually traveled. This was the path through which that boy actually traveled. So can I say this is the actual path traveled? Guys, that boy traveled through this path and reached point B. Okay, what if I join this point A with point B with that straight line over here? This will be displacement, and this is what we call the distance. This is what we call the distance. So I can mention over here, when it comes to the distance, I say it is the actual path traveled. It is the actual path traveled. Since if you are moving from A to B, which was the actual path you traveled, sir? This one, upper one. And the shortest path between A and B is what we call the displacement. And displacement, I write over here, it is the shortest path between we say A and B. It is the shortest path between A and B, and that is what we call the displacement. Can I mention over here, when it comes to the distance, I say it does not have a proper direction. It does not have a proper direction. Why, sir? Because see, here direction of that boy was something like this. Here direction is downwards. Here direction is downwards. Here direction is upwards. So at different points, direction is different. But when it comes to the displacement, you see here direction is this same direction. So it is pointing towards B. So can I mention over here, when it comes to the displacement, it is that path which has a proper direction. We say it has a unique / proper direction. It has a unique / proper direction. Okay, okay, yes, yes, yes. Now, let's suppose, my dear friends, I say this is the point A, and you have traveled from point A, and you reach this point B. You reach this point B. And in this particular case, could you please tell me what is the actual path traveled? Sir, this much is the actual path traveled over here. And I say here, actual path traveled is, let's suppose, 100 meters. And my dear friends, if you join this A and B over here with a straight path, and we say, sir, this is 10 meters. And if somebody asks you what is the distance over here, you say, sir, this will be the distance, actual path traveled, that is 100 meters. And what is the displacement? Displacement is the shortest path between initial and final point, that is, we say, sir, 10. That is, we say, sir, 10. Okay, that is, we say, sir, 10. Now, guys, when it comes to the distance, we say it can never be 0. It can never be 0. Distance can never be 0. But when it comes to the displacement, we say displacement can be 0. Displacement can be 0. Sir, what is the logic over here? Guys, see, I'll tell you. Let's suppose there is a person, he left from point A. Okay, he is moving, and he reached the point A once again. So he started from point A and he reached the point A. Okay. In this case, if I say he has covered 100 meters, this distance is 100 meters. So we say here distance is 100 meters. But when it comes to the displacement, in this case, that is 0. Why? Because the initial point and the final point is same. Displacement is basically how much he has displaced. He hasn't displaced. Why? Because he reached the same point once again. That's why we say displacement in this case is 0, but distance is 100. Distance is the actual path covered. Displacement is how much he has displaced from the actual path, from the initial point. Sir, initial point and final point are same, so we say displacement in this case is 0. So that's why I mentioned displacement can be 0, but it can never be 0. Distance can never be 0. Okay. Yes. Now, when it comes to displacement, we say distance, it can never be negative. We said distance can never be negative. Distance can never be negative. But when it comes to the displacement, we say it can be negative also. It can be negative also. It can be positive also. It depends. Like my dear friends, let's suppose I say this is the origin. Okay, 0, 0. Okay, I hope you might have seen the graph, x-axis, y-axis. Okay, and if I say, sir, from here it is plus x, from here it is minus x. So this is basically the origin. If I consider the origin as frame of reference, let's suppose I'm considering the origin as frame of reference. Guys, see, here value, this is 1, this is 2, this is 3, and this is, let's suppose, 4. And from left side of the origin, we say, sir, this is minus 1, we say this is minus 2, we say this is minus 3, and we say this is minus 4. Guys, understand very carefully. If I say the person is at point here, the person is over here, this is the person. Can I say in that case, with respect to the origin, this much is the displacement? With respect to the origin, let's suppose the person has started his position from origin until over here. This is the displacement. We say, sir, x is equal to, we say, sir, plus 4 meters over here. And when it comes to, if the person has started its journey from origin to here, so can I say in this case, we say, sir, displacement is what? It is minus 4. It is minus 4 over here. Displacement is minus 4. Okay. So here, displacement is plus 4. Sir, how do we actually find the displacement? Guys, wait a second, I'll tell you. Wait a second, I'll tell you. Let's suppose this is the origin. Let's suppose this is the origin. And from here the person has traveled till this particular point. And we say here x is equal to 1, 2, 3, 4, and this is 5. And let's suppose if another car has basically traveled from origin, we say, sir, till over here, till over here. So we say this is -1, we say this is -2, we say this is -3, we say this is -4, and we say this is -5. We say this is -5. Guys, understand very carefully. If the car has traveled from origin to here, we have to find the displacement. Always remember, we said displacement is final position. Always remember this formula. Displacement is final position minus initial position. Displacement is final position minus initial position. Guys, what is the final position of the car? See, this is origin. So, finally it is at 5. We say, sir, car A. This is car B. Okay, this is car B. I say here. What is the final position? That is, sir, 5 minus. We can write it something like this. That is x final minus x initial. So, what is final position here? That is 5 minus. What is initial position? Initially, it was at origin. That is 0. So, in this case, displacement will be +5. Let's talk about the car B. Let's talk about the car B. We say, sir, for car B. We say here also displacement is final position minus, we say, initial position. Finally, the car is at B. So, finally, the car is over here. That is -5. We say, sir, minus. Initially, it was at 0. -5 minus 0 is, we say, sir, -5 over here. So, here displacement is negative. Here displacement is positive. So, that's what I mentioned exactly in this particular case. In this particular case, displacement can be, we say, positive as well as negative. But when it comes to the distance, we say, sir, distance is always positive. So, if the car has moved from this point to this point, how much distance it has covered? That is 5 meters. You do not say -5. It has covered 5 meters. How much car has traveled in this case? We say, sir, 5 meters. So, that's why we say distance is always positive. Is this clear? Is this clear? Tell me in the chats, guys. Is everything crystalline clear? Let me know in the chats. I would want everybody of you to tell me in the chats. Is this crystalline clear, guys? Great. Okay, and one more point you can mention over here. We say it is a scalar quantity. What is a scalar quantity? It is that quantity which has only magnitude. It does not have the direction, or which does not follow the vector laws. And we say it is a vector quantity. It is a vector quantity. Scalar quantity, and this one is a vector quantity. Okay. Yes. And if I say one more point over here, if a particle travels in a straight line, let me show you over here. If I say, let's suppose a particle basically started from this point and it reached basically this point from A to B. And we say in this particular case, this distance is, I say over here, let's suppose 10 meters. So we say if particle started from A to, we say, sir, B. In this particular case, we say, sir, displacement is equal to distance. Distance is the actual path covered. We say this is the actual path covered. Why? Because particle is moving along the straight line only. In this case, distance and displacement are exactly same. So we say both are over here 10 meters. Both are over here 10 meters. So you mention this point exactly over here. You mention this point exactly over here. We say if a particle moves along a straight line, moves along a straight line, if a particle moves along a straight line, then in that case, we say distance and displacement are equal. Distance and displacement are equal, because here the actual path covered is this, and here we say the shortest path between A and B is also this. We say, sir, if this is point A, and we say if this is point B. Okay? Yes. Okay, great. Now, let me give you a question over here. The question is something like this. Let's suppose a basic question. We'll start with a basic question. Let's suppose a car started from, we say, sir, A to B. And then car traveled from B to, we say, sir, C. This is, we say, sir, 4 meters. This is, we say, sir, 3 meters. Okay. Now, my dear friends, in this particular case, you guys are supposed to tell me, find the distance. The car has traveled from A to B, then it has moved from B to C. Find the distance and displacement covered. Find the distance and displacement covered by the car during the journey. So you guys are supposed to tell me what is the distance and displacement covered. Guys, when it comes to the distance, can we say, sir, distance is the actual path covered? Actually, it has first moved the 4 meters and then 3 meters. So when it comes to distance, we say distance in this case is simply, that is 4 meters, we say plus 3 meters, and that will be 7 meters. And when it comes to the displacement will be simply join initial and final point. That will give you the displacement. So I say, sir, displacement will be this. This is a right angular triangle and this is the hypotenuse. So can you tell me what is the value of this hypotenuse? Use PGT. Sir, that is base square plus perpendicular square. So that is under root of, that is 4 square plus, we say, sir, 3 square. So I say in this particular case, displacement will be simply under root of, we say that is 4 square plus, we say, sir, 3 square. 4 square is 16, 3 square is 9. So 16 plus 9 is 25. So it will be under root of 25 and that will be 5. Under root of 25 is 5 itself. Okay. Great. One more thing I just want to tell you over here. Let's suppose I give you the question something like this. See, guys. Let's suppose I give you the question something like this. The question is a car started its journey from the garage. A car started its journey from the garage. Okay, you are having a car, you are a big doctor, okay, you are a topmost doctor of the country, and you are having a car. So you started your journey in the morning, you took the car out from your garage and covered. A car started its journey from the garage and covered 6,000 kilometers. No, we do not say 6,000 kilometers. Start its journey from the garage and its meter reading, that speedometer, its meter reading was 6,000 kilometers. Its meter reading was 6,000 kilometers. And its meter reading was 6,000 kilometers. And when the car arrived back when the car arrived back and is parked in the same garage, and the car is parked in the same garage, the meter reading was we say 6,500 kilometers. The meter reading was 6,500 kilometers. And let me ask you the question over here. Find the distance and displacement covered by the car. You guys are supposed to tell me what is the distance and displacement covered by the car. Could you please tell me in the chats? What is the distance and displacement covered by the car? Everyone means everyone. Let me know in the chats, guys. What is the distance and displacement covered by the car? Tell me, guys. So a car started its journey from the garage and its meter reading was 6,000 kilometers. So when the car came out of the garage, so its reading at that point of time initially was, it was mentioned on that speedometer 6,000 kilometers. So then the car covered, okay, some distance for the entire day. And then the car came back to the same garage. It is parked in the evening in the same garage. Now that reading speedometer shows 6,500 kilometers. How much is the distance and displacement covered by the car? Guys, when it comes to understand one thing very carefully, when it comes to displacement, we said displacement will be 0. Why, sir? Because the car started its journey from the garage and the car is parked in the same garage. So we say because initial and final point is same. Initial and final point is same. Car starts its journey from the garage and it is parked in the same garage. So that's why we say displacement is 0. But when it comes to the distance, guys, initially the reading was 6,000 kilometers. Initially it was showing 6,000 kilometers. What does that mean? If it is mentioned on the speedometer of the car 6,000 kilometers, means it has previously, before this journey, it has covered 6,000 kilometers previously. So when we talk about this journey, particular journey, we are talking about this one. In this case, it has covered only 500 kilometers. That is 6,500 minus 6,000. Guys, 6,000 kilometers was the distance covered because of the previous journeys. Because of this journey, it has covered only 500. So 6,500 minus 6,000. So that will be 500 kilometers. Guys, is this clear? Please tell me in the chats. Please tell me in the chats, is this clear? Distance covered is only 500 and displacement covered is displacement traveled is, we say, sir, 0. Displacement is 0 and distance is, we say, 60. Displacement is 0 and distance is 500. Is this clear? Let's basically move on to the first question that we have got on the screen. Previously, when it comes to the distance and the displacement, I have clearly explained what is distance and I have clearly explained what is displacement. Okay. Now, in this particular question, we will have to solve some of the questions over here. Now, in this particular question, the question says that find the displacement between A and B. Guys, see. Over here, there was a particle which started its motion from A point. Okay. There was a particle which started its motion from A point and then it moved something like this, and finally reached point B. And in this particular case, you guys are supposed to find out what is the total distance covered by the particle in this particular case. Sir, when it comes to the total distance covered, listen to me very carefully. We say, sir, total distance covered. Sir, total distance or distance covered is basically the actual path traveled. Sir, how much path it has actually covered? Sir, this is 4 meters, this is 7 meters, and this is also 7 meters, and this is also 7 meters. So can I say this is 7 plus 7 is 14. 14 plus 4 plus 3, and it comes out to be, we say, sir, 21 meters. So the actual path covered by the particle is something like this. That is 4 plus 7 plus 7 plus 3. But when it comes to the displacement, my dear friends, can I say displacement is basically the distance between the initial point and the final point. How much particle has actually displaced? So that is this much only, because this is the initial point, this is the final point. Now guys, see, if we take a look, this is a square. If this side is 7, don't you think that this side over here, if we complete this side over here, sir, this side will be also 7 meters? And this is given as 4 over here. Can I say this will be, in that case, sir, 3 meters, this portion? Yes. Now, from the bottom also, we say, sir, this will be also, we say, sir, 7 over here in from the bottom. If this is 7, this distance will be also 7. This is given as 3. So obviously this will be given as 4 meters. Now guys, look at this particular triangle. You have to find this distance. Let me basically take out this triangle over here. I'll make it something like this. So guys, in this particular case, this is 3 meters and this is 4 meters. And we are supposed to find this hypotenuse of this particular triangle. Can I say, sir, when it comes to this hypotenuse, sir, hypotenuse will be equal to under root of, use PGT. That will be 3 square plus 4 square. That will be simply 3 square plus, we say, sir, 4 square. So can I say, sir, this hypotenuse in this case will come out to be 3 square is 9, 4 square is 16, 16 plus 9 is 25, that is under root 25, and that will come out to be 5. So means this distance is coming out to be 5 in this particular case. So can I say over here, we say displacement is simply, that is 5 meters. Guys, is this clear? Please tell me in the chats. Everyone means everyone. I just need the signal from every single student that if this is crystal and clear. If this is crystal and clear, let me know in the chats. Everybody out there, guys. Is this crystal and clear? Is this crystalline clear? Okay. Great, 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 great. Okay. So we say displacement in this cases, we say, sir, that is 5 meters. Now, guys, let's suppose if we have got a question something like this. If the position of an object is x is equal to t square plus 2t plus 4. Now, here, the position of an object is changing with respect to time. Let's suppose this is an object, it is moving. Okay. And its position is given as x is equal to, we say, sir, t square plus 2t plus 4. Sir, why isn't the position of the particle over here given as x is equal to 10 meters, 20 meters, something like that? We say it is changing with time. Like at t is equal to 1, put t is equal to 1 over here, position will be 1 plus 2 plus 4, that will be 7 meters. So at time t is equal to 2, you have to put the time t is equal to 2 over here. Now, it says that find the displacement in 4 seconds and find the displacement in 4th second. Guys, see, let's suppose we have got a particle over here and this particle is moving. And it has reached this particular position. So guys, understand one thing very carefully over here. I say, let's suppose at t is equal to 1 seconds, particle was here. At t is equal to 2 seconds, particle was here. At t is equal to 3 seconds, particle was here. At t is equal to 4 seconds, particle is exactly here. So we have to find this displacement in 4 seconds. Guys, see, how do we find the displacement? Understand one thing. Can we find, listen to me very carefully. If position time relation is given and you guys are supposed to find the displacement, see, first we'll find, we say position of a particle at t is equal to, we say, sir, 0 seconds. At t is equal to 0 seconds. That is what we call the initial position. If we get this position at t is equal to 0 seconds, and then if we get final position at t is equal to 4 seconds, we can find this displacement. I'll show you. Sir, at t is equal to 0 seconds where the particle is standing, so put t is equal to 0 over here. So we say x is equal to, so this will be 0 square plus 2 into 0 plus, we say, sir, 4. So x will come out to be over here, that is 4. So when time was 0, position of the particle in that case was, we say, 4 meters. Position in that case was 4 meters. Now guys, understand one thing. Let's suppose I say position, we say position of a particle, position of a particle at t is equal to 4 seconds. Guys, if you remember the last class, I have told you when it comes to the displacement is always equal to final position minus initial position. Initial position we got as 4 meters. Now we have to find the final position. See how I'll make you understand. So we say put t is equal to 4 over here. We say, sir, x is equal to. So this will be t square. That is 4 square is, we say, sir, 16 plus. Then 2 into 4. That is, we say, sir, 8. Then we say this plus 4. So we say 16 plus 8 is 24. 24 plus 4 is, we say, sir, 28. So x final in this case is coming out to be 28 meters. Guys. So means at t is equal to 0, the particle is here. At t is equal to 4 seconds, the particle is here. What is the position? 28 meters. Now, how much is this displacement? Guys, see, when it comes to the displacement, I'll write over here, displacement is, sir, final position. What is the final position? 28 meters. This is 28 minus. What is the initial position? That is 4 meters. You say, sir, 4. So this comes out to be 24 meters. So means the displacement of the particle in 4 seconds is, we say 24 meters. We say 24 meters. Is this crystalline clear? Please let me know in the chats. Please let me know in the chats. Guys, let me know in the chats if this is crystal and clear. If this is crystal and clear. Everyone means everyone. Guys, tell me in the chats if this is crystal and clear. I want everybody. Yes, great, 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 great. Okay, great. Now, what we are supposed to do is we have to find the displacement. We have to find the displacement in, we say, sir, 4th second. Guys, see. Let me make you understand. Let me make you understand over here. Let me make you understand over here. Let's suppose the car started from this point and it reached, we say, sir, this point. Guys, see. I say, at t is equal to 1 seconds, the car was here. At t is equal to 2 seconds, the car was here. At t is equal to 3 seconds, the car was here. At t is equal to 4 seconds, the car is here. Guys, see. Let me just tell you, sir, can I say this is the displacement of the car in first second? Yes, sir. Can I say this is the displacement of the car in second? Yes, sir. Can I say this is the displacement of the car in third second? Can I say this is the displacement of the car in fourth second? Yes, sir. So we have to find this displacement. We have to find this displacement over here. Guys, see. If we get the position of the particle over here, if we get the position of the particle at t is equal to 3 seconds, and if we get the position of the particle at t is equal to 4 seconds, so what we will do, sir, final position minus initial position, we will get this displacement. Guys, see. What I'll do is that, I say position of the particle, at t is equal to 3 seconds. What is the position of the particle at t is equal to 3 seconds? Guys, see, take this equation, put t is equal to 3 over here. So I'll say, sir, this will be x is equal to t square, plus 2t plus 4. We say plus 2t, we say plus 4. Now put t is equal to 3 seconds over here. So I say x will come out to be, that is 3 square is 9. So this is 9 plus 2 into 3 is 6 plus, we say, sir, 4. Now 9 plus 6 is 15. 15 plus 4 is 19. So we say x will come out to be, this is x initial. This will come out to be 19 meters. So now, guys, at t is equal to 3 seconds, particle is at what distance? Particle is at what distance? Guys, see, at t is equal to 3 seconds, particle is at what distance? We say, sir, this is over here 19 meters. And we already know that, at we say t is equal to 4 seconds. We say, sir, x final, that we already got in the last one, At t is equal to 4 seconds, we say position is 28 meters. That is 28 meters. So we say here, it is 28 meters position. This is the position, guys. Now, if you have to find this displacement, what will you do? 28 minus 19. So we say displacement in fourth second. So can I say that will be S is equal to, so that will be 28 minus, we say, 19, and that will come out to be 9 meters. Do you all agree with me? Is this crystalline clear? Please tell me in the chats. Is this crystalline clear, guys? So this was the displacement in the 4th second. And previous one was the displacement in 4 seconds. Previous one was the displacement in 4 seconds. Okay. Guys, give me the signal in the chats if everything is crystalline clear and sorted. Cool. Cool. Now, this is the question that we have exactly over here. And I would want you guys to solve this particular question from your end. I would want you guys to solve this particular question from your end only. From your end only. Okay. Okay. If the initial position of an object is 2, 6, 9, these are the coordinates of an object. Okay. And then the final position is 8, 12, minus 12, we say sir 19. Okay. Now, my dear friends, we say there is a particle over here. There is a particle exactly over here. Its coordinates are, this is the initial position. Its coordinates are 2, 6, and we say sir 19. And finally, let's suppose the particle reached over here. And we say its coordinates are, we say 8, we say sir minus 12, and we say sir 19. Can you tell me how much it has displaced? We say sir it has displaced, let's suppose, by this much amount. These are its initial coordinates. Sir, what does this mean? Means in x its value is 2. In y its value is 6. In z its value is 19. 8 minus 12 and 19. 8 minus 12 and 19. Now you guys are supposed to tell me this displacement and I have already taught you guys the vectors previously. Okay. So I am expecting that you guys will solve this question. So I'll keep this as homework. I'll keep this as homework. Okay. I will show you this question in the next class, but I would want you guys to give it a shot once from your end. And do let me know the answer in the comments. Do let me know the answer in the comments. Do let me know the answer of this question in the comments. Now guys, let's move on to basically the concept of speed. Let's move on to basically the concept of speed. What does the concept of speed actually say? What does it actually say? See guys, we say speed means how fast an object is covering the distance, or how fast an object is moving. How fast an object is moving. Guys, see. I say, let's suppose there is a car over here. Let's suppose I say there is a car over here. Let's suppose I say there is a car over here. Okay. And this car is moving, we say, with 20 km per hour. Sir, what does it mean? It means how fast the car is moving. Like every hour, we say this car is covering how much distance? We say 20 kilometers. So we say every hour, car is covering 20 kilometers. Like if I say over here, I have got one more car over here. Okay. And this car is moving with, we say, sir, 100 kilometer per hour. What does this mean? Means every hour, we say car is covering 100 kilometers. Can I say this is moving more fastly? Yes, sir. Can I say its speed is more? Yes, sir. So that's what it is mentioned over here. How fast an object is covering the distance. How fast an object is moving. It is covering the distance very fastly, because in 1 hour it is covering 100 kilometers. In 1 hour, it is covering only 20 kilometers. So this is what speed is all about. This is what speed is all about. Okay. So my dear friends, let me just tell you over here. Let me just tell you over here. When it comes to the speed, okay, we say speed is simply how fast an object is covering the distance. So we say distance upon, we say, sir, time. Distance upon time. This is, we say, sir, speed. This is, we say, sir, speed. Now, guys, listen to me very carefully. If this is the speed, that is distance divided by time. Now, my dear friends, we say this speed is a, we say, scalar quantity. Okay. And I say it does not have direction. It does not have direction. So this speed does not have direction. Speed does not tell you in which direction the car is moving. Speed only tells you how fast the car is moving. I say, let me mention this point also. We say speed does not tell us in which direction the car is moving. But it only tells us how fast the car is moving. It only tells us how fast the car is moving. That's why we say it's a scalar quantity, because it does not have the direction. Now guys, see. Now there are two types of speed. We say instantaneous speed, and then we have the next one as average speed. Okay. Guys, understand one thing very carefully. Let's suppose an object over here. An object is basically moving from this point to, we say, sir, this point. From point A to, we say, sir, point B. And in this particular case, I say it is covering this much of distance, and let's suppose this is delta D. D is what we call the distance over here. Sir, this is the total distance covered by the object. Okay. And let's suppose it is taking the time as delta T. It is the total time delta T. Okay. My dear friends, if I ask you the simple question over here, sir, what was the speed of the car from A to B? Let's suppose instead of delta D, I'll write over here, we say, sir, 100 kilometers. And from A to B, time is, let's suppose, 10 hours. Let's suppose I am asking you, what is the speed of the car from A to B? You say, sir, when it comes to the speed over here, you say total distance covered. How do we find distance by time? We say total distance covered. Okay. And divided by, we say total time taken. This is how we find the speed. Now, how much is the total distance covered? That is 100 kilometers. How much is the total time? That is 10. This and this will cancel. So this will come out to be 10 kilometer per hour. So this is the speed. And this speed is what we call the average speed. Means this is telling you how much is the speed of the car from A to B in general. This does not tell you that the speed of the car at every point is same. And this is what we call the average speed. And if we write this, we can also write this average speed as, guys, see. Average speed means total distance covered. We can write this total distance covered as delta D also. Total time taken, we can also write this as delta T also. This is how we define the average speed. Total distance covered divided by total time taken, delta D by delta T. Okay. And this is the average speed from A to B. Okay, in general, what is the speed from A to B? That is what we call the average speed. Now, my dear friends, since we have to discuss about the instantaneous speed, understand one thing very carefully. Understand one thing very carefully over here. Understand one thing very carefully over here. Let me change the topic over here and I'll call this as average speed. 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 Okay. So I'll mention over here that is average speed. Average speed. So what was the speed from A to B in general? Now, let's suppose, my dear friends, if I ask you the question, when the car is basically moving from point A to basically point B, from point A to point B, I am asking you, what was the speed of the car at this particular instant when the time was, let's suppose 10:30. I'm not asking you what was the speed of the car from A to B in general. No. What was the speed of the car at this particular instant? Now, I say the speed of the car, at any particular instant, is called, we say instantaneous, we say, sir, speed, instantaneous speed. Speed at any particular instant is called the instantaneous speed. Speed from A to B is what we call the average speed. And guys, see, if in case of average speed, you took the total distance as delta D, total time as delta T. So delta D is a bigger distance. Delta T is a bigger time. So can I say in this particular case, if you have to find the average speed, instantaneous speed, you take the distance covered in this instant. Will that be small or will that be large? So we say that is very small, and we say sir, DD, small distance. And here in how much time they have covered the small distance in very small time, that is DT. So can I say speed instantaneous? It is simply, I say small distance upon, we say, sir, small time. You can basically write it something like this, okay, in order to make you understand very carefully, very properly. So I can say this will be simply, that is DD divided by, we say, sir, DT. DD divided by, we say, sir, DT. This is basically the rate of change of distance with time at any particular instant. So this is what we call the instantaneous speed. Guys, tell me in the chats if this is crystalline clear to each and every single student. Tell me, guys. Everyone means everyone. I need the signal from every single student out there. Is this crystalline clear? Is this crystalline clear? Everyone means everyone, guys. Tell me, guys. Okay. Great, great. I hope instantaneous speed, instantaneous average speed is absolutely clear. Instantaneous speed and average speed is absolutely clear. So average speed is the speed in general from A point to B point. Instantaneous speed is the speed at any particular instant, at any particular instant. Next, average speed is done, total distance traveled. Next, we have got the velocity. Next, we have got the velocity. Velocity is important, guys. Velocity is important. See, when it comes to the velocity, we simply say velocity means it is how fast an object is moving and where. Guys, see. Let's suppose I give you the example over here. I have got a car. Okay. And this car is moving with a speed of, let's suppose it has got 20 meter per second. And I have got another car over here. Understand very carefully. This car is moving with a speed of, we say, sir, 20 meter per second. If I ask you over here, sir, this car A and this car B, what is similar in A and B? You'll say simply, sir, the speed of this car is equal to the speed of this car. We say speed of A is equal to, we say, sir, speed of B, because both are moving with 20 meter per second. So means they are moving with the same speed. But when it comes to the velocity, we say velocity of A is not equal to the velocity of B. Why, sir? Velocity means how fast the car is moving and towards where. This is moving towards left and this is moving towards right. So they have got the different direction. So that's the reason I am saying velocity of these two cars are not equal, because the direction is opposite. The direction is opposite. If I say this is car A, it is moving in the forward direction, and we say, sir, this is car B and it is also moving in the forward direction. This is moving with 20 meter per second. This is also moving with 20 meter per second. Now here I can say velocity of A is equal to velocity of B. Why? Because they have got the same direction. So I can say in this particular case, it is how fast an object is moving and towards where. Towards where, or along with the direction, or along with the direction. Okay, along with the direction. So we can also say it is called the speed with direction. So 20 meter per second towards north. Speed with direction is what we call the velocity. So whenever you say velocity, so along with velocity you have to mention the direction also. You have to mention the direction also. Now guys, tell me one thing. If I have to define the velocity, okay, so we say in case of speed, you took the total distance traveled upon total time taken, distance upon time. When velocity is a vector quantity, don't you think that we should take, sir, displacement divided by, we say, sir, time? Why? Because displacement is a vector quantity. Displacement has got a proper direction. So if displacement has got proper direction, means velocity will be having the proper direction. So that's why in case of velocity, you write displacement. In case of speed, you write distance upon time. Next. And when it comes to the SI unit, we say, sir, SI unit over here is, see guys, what is the SI unit of displacement? We say, sir, we measure it in meters and time in seconds. So that will be simply meter per second. Now guys, understand very carefully. What is instantaneous velocity? Like you are having instantaneous speed and instantaneous average speed, here you have got instantaneous velocity and average velocity. Guys, see, I say it is the velocity of an object at any particular instant. It is the velocity of an object at any particular instant. And when it comes to the instantaneous velocity, we write it something like this. That is, sir, simply that is ds divided by dt. ds divided by dt. That is small change in displacement upon small change in doubt. Small change in displacement upon small change in time. Small change in time. Is this clear, guys? Is this crystalline clear till over here? Is this crystalline clear till over here? Let me know. And what is this? This is also we called as differentiation of displacement with respect to time. This is also the differentiation of displacement with respect to the time. This is also the differentiation of displacement with respect to the time. Okay. Now guys, we have some questions. Like, guys, if previously I have told you what is this dy by dx? Dy by dx is small change in y upon small change in x. Or we say differentiation of y with respect to, we say, sir, x. So simply from now onwards, you'll remember that if displacement is given and they ask you to find the instantaneous velocity, what will you do? You will do differentiation. So if differentiation, if displacement of a car is given, to find its instantaneous velocity, we differentiate. So remember this, my dear friends. If from now onwards displacement of an object is given and you guys are supposed to find the instantaneous velocity, you do the differentiation. Now guys, let's talk about this particular question. We say over here, if the position of an object is given something like this, then find the instant. Okay, before this, let me show you the simple question over here. If the displacement of an object is s is equal to t square plus 2t plus 1, find the velocity at t is equal to, we say, sir, 4 seconds. We are supposed to find the velocity at t is equal to 4 seconds. Okay. Tell me, guys, see, in this particular question, we said displacement of an object is given and we are supposed to find the velocity. Now, can I say, as we know, we say, sir, velocity is simply, that is ds divided by dt. That is differentiation of displacement. Okay. So I can say v is equal to, that is d by ds of this, d by dt of this. That is d by dt of this s. Now, what is the differentiation of this? Sir, differentiation of t square will be simply, that is 2t. How, sir? Power down, power minus 1. So 2 down, 2 minus 1 is 1. then plus differentiation of 2t is, we say, sir, 2. Then plus differentiation of constant is 0. Now we say at t is equal to, we say, sir, 4 seconds. So I say velocity will be 2 into 4, we say, sir, plus 2. So now 2 into 4 in this particular cases, we say, sir, this will be 8 plus 2, and that is, we say, sir, 10 meter per second. Is this clear, guys? Is this clear? So this is how we find the velocity of an object if its displacement is given. Now guys, see, let's move on to the next question. The question says that if the position of an object is given something like this, then find the instant when velocity becomes 0. Okay. Let's first find till over here when velocity becomes 0. Guys, see. I will make you understand certain things over here. We say as x is given as x is equal to, we say, sir, t square minus 4t, we say, sir, plus 5. So position time relation is given, means a car is moving according to this relation. And we have to find, let's first find velocity. Velocity is simply, that is dx divided by dt. And that will be simply, we say, sir, for t square it is 2t. Then we say minus 4. 2t minus 4. This is, for 4t differentiation is 4. For 5 differentiation is 0. Now guys, it says that find the instant when velocity becomes 0. You have to find the time when velocity becomes 0. So I say put velocity is equal to 0 and get the time or find the time. So if I put velocity is equal to 0, that is 2t minus 4 is equal to 0. So can I say this 2t is equal to 4, 2 ones, 2 twos. Okay, so t will be equal to 2 seconds. So can I say now? We say at t is equal to 2 seconds, we say velocity of object is 0. Let me show you how. If we put t is equal to 2 over here, 2 into 2 is 4, 4 minus 4 is 0. So means this is the instant, this is the time when velocity of an object is 0, when velocity becomes 0, when object comes to rest. Now. Then further the question says that, and find the displacement when object comes to rest. Guys. Now, find displacement when velocity is equal to 0. Why? Because they are saying that find the displacement when we say object comes to rest. Find displacement when object comes to rest. Now guys, in this particular case, this is given as the position time relation. From this position time relation, you guys are supposed to find the displacement when object comes to rest. Guys, simple. Time t is given over here. I have shown you the similar type of question if you remember over here. Here, I'm not going to repeat the question once again. Here, this. Position time relation was given and you were supposed to find the displacement in 4 seconds and displacement in 4th second. Here in the question they are saying that you have to find the displacement when time t is equal to 2 seconds. So now find the displacement when velocity is 0, that is time t is equal to 2 seconds. So now you have to find the displacement in 2 seconds, displacement in 2 seconds. And this you guys are supposed to do by yourself only, because I have already shown you a question on this one. Guys, tell me, is this crystalline clear? Let me know in the chats if this is crystalline clear. Everyone means everyone out there. Is this crystalline clear? Everyone, guys. Is this clear? Is this clear? Great, great, great. Now you can do this by yourself only. This do by yourself only. Okay. Answer in this case is -4 meters. Answer in this case is -4. See, guys, you have to basically find the displacement when velocity is 0. Velocity is 0 at t is equal to 2 seconds. Understand very carefully. Guys, see. You have to basically find the displacement from 0 to 2 seconds. That is, find the displacement from 0 to 2 seconds. How can you find that? Sir, displacement is, we say, sir, x final minus x initial. X final is the position when time t is equal to 2. X initial is the position when time t is equal to 0. Okay, so we say at t is equal to 0 seconds. Can you tell me what is the position? Sir, we say x initial will come out to be simply, this is 0 minus 4 into 0, and it will come out to be, that is 5 meters. We say at t is equal to 2 seconds. You guys are supposed to tell me at t is equal to 2 seconds. You guys are supposed to tell me at t is equal to 2 seconds. You guys are supposed to tell me, we say, sir, final, x final. So that is 2 square. We say, sir, 2 square minus, we say 4 into 2. Then we say plus 5. Now this will be how much? 4 into 2 is 8. 2 square is 4, 5. So this will come out to be 9 minus 8 is equal to 1. Now tell me displacement. Sir, displacement in 2 seconds will be simply, that is final minus initial. Final is 1 minus 5. That will come out to be minus 4 meters. This is the displacement. Is this clear? Is this clear? Yes. Next, let's move on to this question. Position of an object is given as a function of time. X is equal to t square minus 2t plus 4. Find the velocity at t is equal to 2 seconds. Find the velocity at t is equal to 2 seconds. Okay. And find the time when object comes to rest. As in this particular case, we say x is equal to t square minus 2t, we say plus 4. X is equal to t square minus 2t plus 4. Now we have to find the velocity at t is equal to 2 seconds. So velocity will be simply, that is dx divided by dt. Now that is differentiation of velocity, this position. So that is, this will be 2t minus 2. Okay. Now at t is equal to 2 seconds, I can say at t is equal to 2 seconds, I can say velocity will be simply, that is dx divided by, that is simply, that is v is equal to 2 into, here we'll put 2 minus 2. So v will come out to be 2 into 2 is 4, 4 minus 2 is, which is a 2 meter per second. 2 meter per second. Next. So at t is equal to 2 seconds, velocity is 2 meter per second. Next. What is next over here? Guys, see. I say, sir, find the time when object comes to rest. Sir, when object comes to rest, don't you think that its velocity is 0? So we say, put velocity is equal to 0 and find the time. Find the time. So this is the value of velocity. V is equal to 2 into V is equal to, we say sir 2t minus 2 is equal to 0. So we say 2t is equal to 2. So t will be equal to 1 seconds. So at t is equal to 1 seconds, object will come to a rest. Okay. Okay. Is this clear? Is this clear? Please give me the signal in the chats. Everyone means everyone. Please give me the signal in the chats. Guys, let me know in the chats if this is crystalline clear to each and every single student. And guys, most importantly, if you have not liked the session yet, I would want you guys to hit the like button as soon as possible. Okay? Hit the like button as soon as possible. Next. X is equal to t square plus 4t plus 10. Find the time when object comes to rest. This is an interesting question. Guys, see here, x is equal to, we say t square plus 4t plus 10. Okay. And we have to find the time when object comes to rest. First, find the velocity. Velocity is, we say, sir, 2t. Velocity is, we say, sir, differentiation of this one, that is 2t plus, we say, sir, 4. 2t plus, we say, sir, 4. Now, I say put velocity is equal to 0. If you put velocity is equal to 0, don't you think that, sir, this will be 2t plus 4 is equal to 0? Sir, 2t is equal to minus 4, 2 1s, 2 2s. So t will come out to be minus 2. Guys, tell me one thing. Do you think that time can be negative? So we say time cannot be negative. Time cannot be negative. So object, so which means object will never come to rest. Which means object will never ever come to rest. So if value of time is coming out to be negative, that means object will keep on moving forever and it will never come to rest. Okay. One more thing I just want to mention over here, my dear friends. What is that? See. We say as velocity is ds divided by dt. Velocity is differentiation of displacement divided by time. Now, if we multiply this over here, we say, sir, ds will come out to be, that is v dt. Okay. Now I am saying that integrate both sides. Now I am saying that integrate both sides. If you do the integration on both sides, this will be integration of ds is equal to integration of v dt. Now what is this integration of ds? So integration of ds, it will give you the total displacement, that is s. This will be integration of v dt. I would want you guys to keep this in your box. So what does this equation actually say? This equation says that we say if velocity is given to find the displacement, to find the displacement, we integrate. If velocity is given, to find the displacement, what do we actually do? We do the integration. We integrate simply over here. Like, let me take out the question over here. Guys, if displacement is given and we are supposed to find the velocity, what do? We differentiate. And if velocity is given and if displacement is given to find velocity, we differentiate. If velocity is given to find the displacement, we integrate. Like. If an object is moving with a velocity, let's suppose we have got an object over here. This object is moving with v is equal to 3t square. Then find the displacement in 2 seconds. We are supposed to find the value of displacement in 2 seconds. Guys, see, as I can simply say in this particular case, velocity is given, we have to find the displacement. So can I say displacement will be simply integration of that is v dt? Yes. So we said displacement is integration of. What is the value of v? V is 3t square. So I'll put over here that is 3t square and this will be dt. Now you have to find the displacement from where to where. So that is from 0 to 2 seconds, because in 2 seconds we have to find it. So can I say this will be simply, now guys, take this 3 out, then integration of t square and then it will be dt. And we can say this is 3. Integration of t square will be simply that is t cube divided by 3. Why? Because if we say we have x, integration of x dx, we say integration of x will be simply x square by 2. Same is the case over here. This will be simply that is power, x raised power. What is the power of x? 1. So that is 1 plus 1 upon 1 plus 1. So that is x square divided by 2. Now same over here, 3 and 3 will cancel. So I can say displacement will be, and the limits are from 0 to 2. So that is simply, so we say this is t cube and this is from 0 to 2. Now guys, we put the upper limit, then we put the lower limit. So s is equal to, upper limit will be, sir, 2 cube minus lower limit. Now first you have to put 2 in t, then you have to put 0 in t. So 2 cube minus 0. So s will be 2 into 2 into 2. That is, we say, sir, 8. So displacement would be in this particular case 8. Guys, is this clear? Please tell me in the chats. We'll start with this particular topic, that is average velocity. Okay. Great. So time duration will be, most probably we'll finish this session in 1.5 hours. Okay. 1.5, that is 90 minutes or 90, between 90 minutes to, we say, 100 minutes. Now, my dear friends, listen to me very carefully. The first topic that we are starting with is, that is what we call the average velocity. Sir, what does average velocity actually mean? Let's suppose, my dear friends, we have got a car over here. We have got a car over here. Okay. And this car started from point A. Let's suppose this car started from point A and we say it reached over here point B. It reached over here point B. The car started from point A and it reached point B exactly over here. Let's suppose I'm saying it has covered the 100 kilometers from A to B. And let's suppose I'm saying it has taken the time of 10 hours. It has taken the time of 10 hours. My simple question to you is, could you please tell me, what is the speed or what is the velocity of the car during this journey from A point to B point? I am not asking you to tell me the velocity of the car at any specific point, at any particular point. No. I am asking you to tell me the velocity of the car from A point to B point in general. You say, sir, when it comes to velocity of the car from A point to B point in general, you say, sir, that is total displacement traveled. How much is the total displacement traveled? That is 100 kilometers. So I'll write over here, this is 100 kilometers upon. Sir, how much is the total time taken? Sir, I write over here, that is 10 hours. So I can say this will come out to be, that is 10 kilometer per hour. This 10 kilometer per hour is the average velocity from A point to B point. This is the average velocity from A point to B point. So that's the reason I have mentioned over here total displacement traveled upon total time taken. Sir, can we write it also something like this? See, mathematically we can write it, sir, total displacement traveled is, we say simply that is delta S, because we represent displacement with S. And then we can say over here that is delta T. Delta S divided by delta T. What is delta S? Total displacement traveled. What is delta T? Total time taken. Now, if I ask you what is the speed at this particular instant, what is the velocity at this particular instant, sir, that velocity is called the instantaneous velocity. We have already discussed that particular thing. Now guys, when it comes to the average velocity, I simply say it is delta S by delta T. Can I also write it something like this? That is S2 minus S1 upon, we say T2 minus T1. S2 minus S1 upon T2 minus T1. That is final minus initial upon final time minus initial time, or final displacement initial, final minus initial upon final minus initial. As simple as that. Guys, is this clear till over here? Let me know in the chats, everybody out there. Is this crystalline clear till over here? Is this crystalline clear till over here? Let me know in the chats if this is crystalline clear to each and every single student. Okay. Now, let's suppose we have got a question something like this. Okay. If the position time relation of a car is this, let's suppose a car is basically moving. This is a car, okay, it is moving, and its position time relation is t square plus t plus 1. Okay, its position time relation is given as this. Find the average velocity from 0 to 4 seconds. Guys, let's suppose the car has started from this point and it has basically reached this point. Okay, at t is equal to 0, the car is here. At t is equal to 4 seconds, we say the car is here. Now guys, you have to find the average velocity from, we say this point to this point. How do we find the average velocity? Sir, we can write it delta x, or you say delta s, it is one and the same thing. So we say delta x divided by delta t. Sir, what is that? That is final position minus initial position divided by, we say final time minus, we say initial time. We can write it something like this. It's one and the same thing. Now guys, let's suppose if I ask you what is this final, what is this xf? You say, sir, this is the final position. Final position means when time t is equal to 4 seconds, what is the position of the car? See guys, so we say xf is the final position at t is equal to 4 seconds. At t is equal to 4 seconds, what is the position of the car? That's I'm supposed to find out. So this is the position time relation. We say final will be, sir, this is t square plus t plus 1. Simply you put over here, instead of t, you put over here, that is 4. So I say that is 4 square plus. And in this t, you put also that is 4. Because we have to find the value of x at t is equal to 4. So then I can say, sir, it is 1. 4 square plus 4 plus 1. So this is how much? 4 square is 16 plus 4 is 20. And that is, we say, sir, 21. And if I ask you to tell me the initial position, we say initial position is xi is the initial position. initial position at t is equal to 0 seconds. At t is equal to 0 seconds, what is the position of the car? That's what we are supposed to find out. Can I say this initial position will be simply, in this equation you have to put t is equal to 0. So this is 0 square plus 0 plus 1. So it will come out to be 1. Now you got the value of final position, you got the value of initial position. So finally x is at 21 meters. Initially x is at 1 meters. So I can say average velocity in this particular question is final minus initial. How much is the final in this particular case? Sir, that is 21. Minus, how much is the initial in this case? That is 1. Okay, divided by final time minus initial time. How much is final time? That is 4. Minus, what is the initial time? That is 0. So this will come out to be, that is 20 divided by 4, that is 5 meter per second. So from A point to B point, we say average velocity of the car is 5 meter per second. Guys, tell me in the chats, is this clear? Please give me the signal in the chats with the fire emojis. Everyone means everyone. And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Everyone means everyone. Okay. Great. Now, there is one more important relation. There is one more important relation that I would like to tell you over here. Guys, see. Let's suppose if I give you the question something like this. If the velocity of a car is, let's suppose I say v is equal to we say 4t. This is the velocity of the car. Then find the average velocity. Then find the average velocity from, we say, 0 to 4 seconds. If the velocity of the car is 40, you guys are supposed to tell me what is the average velocity of the car from 0 to 4 seconds. Guys, see. Previously, I told you the displacement of the car is, let's suppose, t square plus 2t plus 1, something like this. And I asked you to find the instantaneous velocity. Which formula you used? Sir, that is dx by dt, simply. Even if I ask you to tell me the average velocity, which formula you used? Sir, average velocity is, that is delta x by delta t. Okay. But right now in the question, if you see, velocity of the car is given and they have asked the average velocity. Velocity is given and we have to find the velocity only, average. Now see, if you ever get this type of question, what you are supposed to do in this type of question, let me just tell you for once and all. My dear friends, see, whenever they ask you about the average velocity, you simply say average velocity is, that is total displacement traveled, and then we say upon total time taken. This is the general formula for average velocity. This can be used in any case, and we can write it something like this. That is delta S divided by, we say, sir, delta T. What is this delta S? Total displacement traveled upon total time taken. Now guys, tell me one thing. Let me tell you something which is very beautiful. I say, as we know. Sir, what do we know? We know one thing. Sir, velocity is equal to ds divided by dt. Yes. Now multiply this over here. So I can write ds is equal to v dt. Okay. Now integrate from both the sides. What is the integration of ds? So if you are integrating small displacements, you will get the total displacement. Sir, I can write this as delta S, or I can write this as S also, that is one and the same thing. Now it will be simply that is integration of V dt. Yes, yes. Now keep this in the box over here. Yes, sir. I kept this in a box. Next. My dear friends, if I ask you, sir, integration of dt, what is this integration of dt? Integration of dt means adding small time intervals. If you add small time intervals, don't you think that you will get the large time interval? So we will get the total time, that is what we call delta t. So integration of dt we can get, we say, sir, delta t. Now put this over here. Now can I write, sir, average velocity is equal to, sir, instead of delta S, can I write it will be simply that is integration of V dt upon, sir, integration of delta t, can I write it is integration of dt? Yes. And this is the golden formula which I would want you guys to exactly keep in your mind, because this will help us to solve the lot of problems out there. This will help us to solve a lot of problems out there. I would want you guys to keep this in your mind. Okay, that is integration of V dt and integration of dt. And my dear friends, I say, I'll write over here, use this equation when velocity is given, and we have to find V average, means we have to find average velocity. You will be using this particular equation only and only if velocity is given and you have to find the average velocity. Now let's find the value of this one. Guys, see, we say velocity is given as that is 4t. To find, we say AVG from we say 0 to 4 seconds. We have to find VAVG from 0 to 4 seconds. Now tell me, can I say, sir, VAVG is simply integration of VDT upon, we say, integration of DT. Now I can write over here VAVG is equal to integration of VDT. What is the value of V? That is, we say, sir, 4t, and then we say dt. Now we say from 0 to 4 seconds. Then we say divided by integration of dt. So we say this is integration of dt. From where to where? We say, sir, from 0 to 4 seconds. Now guys, if we do the integration over here, 4 is constant, take this 4 out. So I'll take this 4 out. Now what is the integration of t? Sir, integration of t is t square divided by 2. Everybody of you must be knowing this, okay? That is t square by 2. T raised power 1, t raised power 1 plus 1 upon 1 plus 1. Power plus 1 upon power plus 1. Okay, then hold, and then limits are from 0 to 4. 0 to 4. Whole divided by integration of dt is what? That is t. So this will be t, and the limits are from 0 to 4. Now let's solve it over here. So we say finally over here, let me just tell you, that is VAVG will come out to be. Now guys, 2 1s are and 2 2s are 4. So it will be 2, and then you have t square over here. First you will put the upper limit, that is 4. So this is 4 square. Because in this t we put first upper limit, then lower limit, minus lower limit, that is 0, upon. Then here you put upper limit in t, then you put lower limit, and that is 4 minus 0 over here. Now 4 square is 16. 16 into 2 is, we say, sir, that is 32 divided by 4, and that will come out to be 8 meter per second. So average velocity in this particular case from 0 to 4 seconds is how much? That is 8 meter per second. Please tell me in the chats how many of you understood this particular question over here. And guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Give me the signal in the chats, everybody guys. Is this clear? Is this clear? Is this clear? Okay. Now, we have got now, see guys, we have got some important formulas, and these are, I would say, very important. These are very important. These are very important right over here. Very important. Okay. Important formulas for average velocity, VAVG, for average velocity. Guys, listen to me very carefully. The first is, I'll mention this is a question. If a body covers its journey in equal parts, that is equal distances, then find its average velocity. Guys, see. This is a very interesting question. I would want you guys to exactly focus over here. I would want you guys to exactly focus over here. I would want you guys to focus exactly over here. Let's suppose, my dear friends, I have got a car over here. Okay, I have got a car over here. It started its journey from this point. It started its journey from this point, something like this. Something like this. Okay, something like this. Okay. Now, my dear friends, if it is covering its journey, something like this, okay, something like this. Let me just tell you, in this particular case, let's suppose it is covering this part of the distance. It is covering this part of the distance with a velocity v1. Okay, let me make you understand this one. If a body covers its journey in equal parts, means first, let's suppose this is 10 meters. It is covering the 10 meters with v1. And then next 10 meters, next d distance, it is covering with the velocity v2. And then we say next d distance, it is covering with the velocity v3. And then we say next d distance, it is covering with the velocity v4. And so on, Okay. And nth d, it is covering with vn. Okay. And in this particular case, this is what we call the body is covering equal distances with v1, v2, v3, v4. Equal distances with these velocities. Now, when it comes to, my dear friends, to find the average velocity in this case, see, we say average velocity here will be simply, what is the basic formula for average velocity? Sir, that is total displacement traveled upon, we say, total time taken. Okay. Now tell me one thing. Can I just write over here, sir, total displacement traveled? What is total displacement traveled over here? Guys, see. We said total displacement traveled is d plus d plus d plus d and so on up to n. We say, sir, it will be d plus d plus d plus so on up to n. And then we say upon total time taken. If I say, let's suppose in this journey it has covered the time t1. Guys, see. If I say in this journey it has covered the time t1, can you find the value of t1 over here? Sir, we know, guys, see. We say velocity is equal to displacement upon time. We say, sir, time is equal to displacement upon velocity. So this t1, that is the time in this duration, will be equal to what? That is d by v1. Sir, time in this duration will be equal to d by v2. time of this one is d by v3. So I'll write over here, this is d by v1. This is the time in this one, plus this time, plus this time, plus this time. So plus, then we say d by v2, then we say plus d by v3, then we say plus so on. Now guys, tell me one thing. If I add all of these d's, don't you think that it will become n times of d? Yes. And upon, if I add all of these, take this d common. So I'll take this d common. So it will be 1 upon v1 plus 1 upon v2 plus so on up to n. Now guys, can I say, sir, this and this we can cancel? So over here, what will be the value of average velocity? That is n upon 1 by v1 plus 1 by v2 plus 1 by v3 and so on 1 by vn up to 1 by vn. So this is how we can find the average velocity. In this particular case. Okay. Okay, so we say in this particular case, this will be the value of average velocity. Now, my dear friends, listen to me very carefully. So I can say, if a body is covering its journey in equal parts, and you guys are supposed to find the average velocity, that is n upon 1 by v1 plus 1 by v2, 1 by v3 up to 1 by vn. Now see, let me tell you something over here. What is that? Let's suppose, I'll give you the question on the same format. Let's suppose a body is covering this journey from A to B. Let's suppose A to B, okay? And it is covering this distance D, first half of the distance with V1, second half of the distance with, we say, sir, V2. It is covering this half with this distance with V1 and this distance with V2. And if they ask us to find the average velocity in this particular case, can you find the average velocity over here? Guys, give it a try. I can say, sir, you recently told us if the body is covering the journey in equal parts, in that case, we say how to find the average velocity, n upon 1 by v1 plus 1 by v2 plus 1 by v3, so on. So I can say here, as we can say when it comes to the average velocity, it is n upon 1 by v1 plus, we say, 1 by v2. Sir, only these two? Yes, because you have got the only two intervals over here, this one and this one. Now, what is the value of n in this particular case, sir? This is the first one and this is the second one, that is n is equal to 2, because this distance is divided into two parts, divided by, then we say 1 upon v1 plus 1 upon v2 is equal to, so I can write this is 2 upon, now do the cross multiply, this will be v1 plus v2 upon v1 into v2. Now take it in the numerator, so this will be 2 times v1 v2 upon v1 plus v2. So directly from now onwards, you will be remembering this also. If the body is covering its journey in equal intervals, okay, in equal parts, like here we have got the two parts, okay, and in that case we say average velocity will be twice v1 v2 upon v1 plus v2 upon v1 plus v2. Now, on the same concept, we have got an important question over here, and I would want you guys to solve this particular question in this particular case. Tell me, guys. Tell me, guys. He is teaching really good. Understand the concept well, huh? I guess you are the new student over here. Please go on to the comment section of all those marathons that we have taken on this particular channel, and you will get to understand the level of teaching we teach on this particular channel, be it all the teachers, be it Wasim sir, be it HSP sir, Ambika ma'am. Okay. Come on, guys. I would want you guys to answer this particular question. A car moves a distance of 200 meters. Okay. A car moves a distance of 200 meters. Let's suppose we have got a car over here. Okay. And it says that this car has moved a distance of 200 meters. Let's suppose this distance is 200 meters. Okay, the car has basically reached this particular position. The car has moved the distance of 200 meters. It covers the first half of the distance with speed 40 kilometer per hour. Okay. Okay. So we say, it says that it covers first half of the distance, that is this 100 meters, with the speed v1 is equal to 40 kilometer per hour. 40 kilometer per hour. Second half of the distance it covers with a velocity v, with the speed v. So we say this it covers with a velocity v. Okay. And in this particular case also V average is given as, we say, 48 kilometer per hour. 48 kilometer per hour. And we are supposed to find the value of V. What is the value of the velocity in the second interval, in this second part? So we are supposed to find the value of V. Guys, see, if a body covers its journey in equal parts and you have got the two intervals D and D, can I say in that particular case, this is the average velocity? Twice V1, V2 upon V1 plus V2. Here also, it is covering first half with V1, second half with V2. Can I say I'll use directly? We say use directly. Directly. V average is equal to 2 times of V1, V2 upon V1 plus V2, because we have already derived this. So can I say average is given as 48 kilometer per hour? 48 is equal to. Then we say twice V1, V2, 2 times of. What is the value of V1? That is 40. So I'll write over here that is 40. What is the value of V2? That is V. That is V upon. Then we say V1 plus V2. What is the value of V2? V1. That is 40 plus V. And if you solve this, V will come out to be, that is 60 kilometer per hour. So means in this interval, its velocity is, its speed is, we say 60 kilometer per hour. I hope this is clear. I hope this is clear, guys. Guys, I hope this is clear. And like this particular session if you have not liked the session yet. Everyone means everyone. Everyone means everyone. Now, let's take a look at this particular question. Let's take a look at this particular question. See. Let's take a look at this particular question. A car covers 2/5 of the total distance with V1. It says that we have got a car over here. Okay. And this car is basically covering. See, guys, I'll tell you. This car is basically covering. We say, let's suppose this much distance it is covering. Now it says that 2/5 of the total distance it is covering with, let's suppose from here to here, this is 2/5D. If I say total distance is D, 2/5D it is covering with the speed V1. Okay. And then 3/5 of the distance with V2. Then we say this part of the distance, that is 3/5D, it is covering with V2. Guys, see. Sir, in this particular case, the distance is not equally given. This is not the case of equal distances. No problem. No worries. I'll tell you the trick and that will help you to solve. See, here it says that 2/5 of the distance it is covering with the speed V1. And 3/5 of the distance it is covering with the speed V2. So means how much is the total distance? D. Okay, because if you add this plus this, we say 2/5D plus 3/5D is plus 3/5D is equal to how much? 3 plus 2 is, we say, sir, 5/5, and it will come out to be D. It will come out to be D. Okay. Now, How we are supposed to find the average velocity in this particular case? How we are supposed to find the average velocity in this particular case? I'll tell you. Guys, see. When it comes to the average velocity, we say it is simply total displacement traveled upon, we say, total time taken. Sir, this is the general formula. Yes. Now, tell me how much is the total displacement traveled? This displacement plus this displacement, and that is 2 by 5d plus, we say, 3 by 5d upon total time taken. How much is the time in this one? Time is, sir, whenever we find time, that is displacement upon velocity. What is displacement here? That is 2d by 5 and velocity is v1. Displacement is 2d by 5, velocity is v1. Then I can write over here. This will be simply, that is 3d by 5. This is v2. Okay, 3d by 5 v2. Now solve this and get the value, get the answer of this particular question. Okay, and if you solve this, it will come out to be 5 times of v1 v2 upon we say 2 times v2 plus 3 times v1. This will be the exact, if you solve this, you will get this answer finally. Because see. Guys, you can basically write it something like this. This is total d. This plus this is d. And it will be over here, that is 2d by 5v1 plus 3d by, we say, 5v2. Okay. Now, this d and d will get cancelled out. And here it will be 1 upon, and then it will be 2 by 5v1 plus, we say, 3 by 5v2. And then if you solve, it will come out to be the 5 times of v1 v2 upon, then we say 2 times of v2, and then we say 3 times of v1. 2 times of v2, 3 times of v1. Is this clear? I hope this question is also clear. Now, next case. This is the case in which it is given that if a body covers its journey in equal intervals, that is equal time, then find the average velocity. Then find the average velocity. It is like, let's suppose I have got a car over here. Okay. The car started the journey from this point. And this car is moving. And the car finally reached over here. Okay. Now, in this particular case, my dear friends, it is saying that if a car covers its journey in equal intervals, in equal time, means, let's suppose the car has traveled from this point to this point and it took the time t. T can be anything, 10 seconds, 15 seconds. So, for this 15 seconds, we say its velocity is v1. And then we say for the next 15 seconds, next t time, its velocity is v2. Then we say for the next, sir, t seconds, its velocity is v3, and so on. This is what we call, if an object covers its journey in equal time intervals. For the first time, it is having the velocity v1. Then in this one, it is having the velocity v2. Then in this one, it is having the velocity v3. And if we are supposed to find the average velocity, sir, what is the general formula to find the average velocity? Sir, the general formula is, that is total displacement traveled upon, we say, total time taken. As simple as that. Now the question here is, how much is the total displacement traveled? Guys, see. We say, sir, this displacement plus this. Tell me one thing. We say, as See guys, we say velocity is equal to displacement upon time. Can I say, sir, displacement is equal to multiply it over here, velocity into time? Yes, sir. Now, here, time is given. Velocity is given. Can you find this displacement? See, guys. This displacement will be this velocity into this time, v into t. So that is v1 into t. So this displacement. Then we say plus this displacement. We can write over here plus, that is v2 into t. v2 into t. Then we can write this displacement. So that will be v3 into t plus so on up to n. And then I can say over here whole divided by. Sir, this time plus this time plus this time. So I can write t plus t plus t and so on up to n. Now guys, in this particular case, can I say we can take this t common over here? Sir, we can take this t common and this will be v1 plus v2 plus v3 and we say so on. And then I can say divided by. So this t plus t plus t plus t and so on, and it will be n times of t. This and this will cancel out. So it will be v1 plus v2 plus v3 and so on upon we say, sir, n. Upon, and I'll write over here up to Vn, and this will be the value of average velocity in this case. This will be the value of average velocity in this case if a body is covering its journey in equal time intervals. Now, in this case also, let's suppose if I give you the example something like this. A car covers its journey from this point to this point. For the first time interval, it is having the velocity v1. For the second time interval, it is having the velocity v2. Can you tell me what is the average velocity? Sir, average velocity here is simply, that is v1 plus v2 upon up to n divided by n. So now, what is the value of n over here? N means the number of intervals. So this plus this. So we have got v1 plus v2 divided by 2. Because here number of intervals n is equal to 2. Guys, is this clear? Please give me the signal in the chats. Is this clear? Everyone means everyone. And if you have not liked the session yet, if you are not liked the session yet, I would want you guys to hit the like button as soon as possible. Guys, hit the like button as soon as possible. Okay, great. I hope you are loving the session. I hope you are loving the session. I hope I am making you understand each and every single point. Next, we have got the acceleration. Okay. What is acceleration? Acceleration is simply, we say change in velocity. Okay. If the velocity of a car is changing, means it is accelerating. Now, if the velocity of the car is increasing, it is also accelerated. It is also accelerating. And if the velocity of the car is decreasing, it is also accelerating. Okay. Retardation we'll see later on. As of now, we say whenever the velocity of the car changes, we say it is accelerating. So I can say, let me give you the example over here. Let's suppose, my dear friends, in this particular case, I have got a car over here. Initially over here, its velocity is 0. It is at rest. Now it started moving. In the forward direction. After 1 second, we saw its velocity became 10 meters per second. It started moving faster. After 3 seconds, we say its velocity is 18 meter per second. After 4 seconds, we saw its velocity became 24 meter per second. Now here in this journey, velocity of the car is changing, increasing. So means this car is accelerating. This car is accelerating. So whenever the velocity of the car changes, means the car is accelerating. So it is what we call the rate of change of velocity with respect to time. With respect to time. Okay. So we can simply say, sir, acceleration is, we can simply say acceleration is velocity upon time. Okay, acceleration is velocity upon time. How fast velocity is changing with time means that is accelerating. Means like it is like you are sitting in your car with your papa, okay, with your dad, and he is driving the car at certain speed, and you ask him, hey dad, you are moving very slowly, please move faster, I have to reach that particular place, I have to reach school very fast, I have to reach tuition very fast. So what does he do? He basically accelerates the car. Now the speed of the car is increasing, car is moving faster. At that point of time, we say car is accelerating. So my dear friends, we say when it comes to the velocity, what is the unit of velocity? We say, sir, meter per second. We measure the velocity in meter per second. And we say time over here is also second. So we can write SI unit of velocity is, we say this is meter, second into second is meter per second square. This is what we call the SI unit of velocity. Sorry, SI unit of acceleration, meter per second square. So we measure the acceleration in meter per second square. So we say 10 meter per second square, 20 meter per second square. Okay, cool. So from now onwards, you'll remember that whenever the car is changing its velocity means it is accelerating. It is accelerating. Now, let's talk about the positive acceleration. Let's talk about the positive acceleration. See guys, we say when the value of acceleration is positive, when the value of acceleration is positive, it is called positive acceleration. And positive acceleration means that also it means we say acceleration is forward. It means acceleration is forward, means it is in the forward direction. Sir, please clarify the confusion that we have. If acceleration is forward, means acceleration is in the forward direction. Sir, does that mean car is moving in the forward direction? No. If I say, guys, see. If I say, this is the car. This car is having the velocity of plus 5 meter per second. So if velocity is positive means velocity is forward. Positive means forward. So that means car is moving forward. Car is moving forward. Okay. And if I say this car has acceleration positive, does this also mean car is moving forward? No. It can be, it cannot be. Basically, what I'm trying to say, acceleration does not tell you the direction of motion. I'll write over here. We say acceleration does not tell us the direction of motion. Direction of motion. Acceleration does not tell us the direction of motion. What tells us the direction of motion? We say, sir, velocity. If I say this car is moving in the backward direction, guys, understand, we take its velocity as negative. So means car is moving backward. Car is moving backward. Okay. Its acceleration can be positive also. Its acceleration can be negative also. Depends upon the situation. So what I'm trying to say, if velocity is negative means car is moving backward. If velocity is positive, car is moving forward. If acceleration is positive, does that mean car is moving forward? It can be, it cannot be. Depends. Now, guys, listen to me very carefully. Listen to me very carefully. Sir, can you please give us the example of positive acceleration? Yes, very easily. See, guys, let's suppose here in this particular case, we have got a car which is moving with 10 meter per second. And we have got a car and this car is basically moving forward and it reached this point. And after some time, we say, sir, after what time? After 1 seconds, its velocity became, let's suppose, 20 meter per second. Its velocity became 20 meter per second. Always remember, guys, see, whenever you have to find the acceleration, see, I'll write, let's suppose we have to find the acceleration in this interval. We say acceleration is simply, that is change in velocity upon, we say change in time, because I told you acceleration is what? That is a rate of change of velocity with respect to time. So change in velocity upon change in time. And we can also write it something like this. Change, how do we find the change? We say, sir, final minus initial, final velocity minus initial velocity, upon, we say, final time minus initial time, Now, guys, come over here. If we have to find the acceleration in this particular case, we say, sir, acceleration here will be, just a second, I'll okay. So we say acceleration here will be change in velocity. That is final velocity minus initial. That will be 20 minus 10 upon change in time. Sir, final time is 1 second, initial time is 0, that is 1 second. So I can write 20 minus 10 is, we say, sir, plus 10 meter per second square. So we say here acceleration is positive. Means the direction of acceleration here is forward. Means here acceleration is positive. Means that is forward. Sir, but in this case the car is moving in the forward direction. Yes, I told you it can be, it cannot be. I'll give you one more example. So we say here velocity is also positive, that is forward. Sir, please give us the another example. Please clarify this doubt. Okay, no problem. See, guys, let's suppose one more example. Let's suppose we have got a car. Okay. And this car is, let's suppose, moving in the backward direction. Okay. And if this car is moving in the backward direction, my dear friends, listen to me very carefully. It is, let's suppose, moving with 20 meter per second. And then here its speed becomes, let's suppose, 10 meter per second. Okay. Now, let's suppose the time is 1 second. Means you are in the car and you are, let's suppose, moving now reverse, in the reverse gear. Okay. Initially you are moving faster and finally you are moving slower. Now, can we find the acceleration over here? Final velocity minus initial velocity. Guys, tell me, what is final velocity over here? Shall I take minus 10 or plus 10? Sir, if the car is moving in the left direction, we take the velocity as negative. So I'll write minus 10. Then minus final velocity minus initial velocity. Initial velocity is also minus 20. Okay. And in this particular case, we say time is 1 second. So can I write here acceleration is minus into minus is plus. So minus 10 plus 20 divided by 1. So acceleration here is plus 20 minus 10, that is 10 meter per second square, and it is plus 10 meter per second square. Now see, here, we say acceleration is positive. Guys, see, acceleration is positive means acceleration is forward. But the car is moving in the backward direction. Velocity is negative, so that is backward. That's what I told you. Acceleration can be positive. If acceleration is positive, car can be moving in the forward direction, car cannot be moving in the forward direction. This does not tell you the direction of the motion, but velocity tells you the direction of motion. Tell me guys in the chats, is this clear? Tell me guys in the chats, is this clear? Everyone means everyone. And like this session, make the like count to 100, everybody out there. Yes, the relation between the force and acceleration that we'll see in the laws of motion. Okay. As of now, whatever the information I am giving you, just take it. Okay. Then guys, let's move on to the next one, negative acceleration. Now, what does negative acceleration mean? We say when the value of acceleration is negative, it is called negative acceleration. Okay. So one more point I'll mention over here. Negative acceleration, if acceleration is negative, means acceleration is backward. Means acceleration is backward. Okay. Okay. Like, sir, can you give any example? Yes. Let's suppose I have got a car. Okay. This car is basically moving. This car is moving. Okay. And we say initially it is moving with a speed, we say 20 meter per second. And I'm saying that after 1 second, we say the same car is moving with, let's suppose, 10 meter per second, like it applied the brakes. So we say in this particular case, if we find the acceleration is final velocity minus initial velocity, that is 10 minus initial is, we say, 20 upon time is 1 second. Acceleration is simply 10 minus 20 is how much? Minus 10. So we say this is minus 10 meter per second square. So guys, see, in this particular case, acceleration is negative. Means acceleration is backward. Okay. And one more thing, acceleration is backward, but is the velocity positive over here or negative? We say velocity over here is positive, that is forward. So car is moving forward, but acceleration is backward. Okay, cool. Now we have the concept of retardation. Guys, see, listen to this very, very carefully. Sir, what does this retardation mean? This retardation simply means, we say this retardation simply means, it means, we say, slow down. It means simply slow down. Sir, what does slow down mean? Let's suppose if a car is moving and you applied the brakes. After applying the brakes, don't you think that the car will slow down and it will stop after covering some distance? Yes, sir. So that is what we call the slowing down. Slowing down means. So it means, we say, it means slow down. Slow down the object. If an object is slowing down its velocity, so means that acceleration is what we call the retardation. Sir, Is negative acceleration the retardation? We say no. Let me just mention over here. Negative acceleration does not mean retardation. Negative acceleration does not mean retardation. We say negative acceleration does not mean retardation. Okay? And retardation can be negative also, it can be positive also. Let me write this point also. We say retardation can be negative as well as positive also. Okay, okay. Let me give you the example. Let me give you the example over here. Let's suppose I take an example over here, guys. Let's suppose I have got a car. And this car is moving with, let's suppose, moving with 20 meter per second. Okay. Now this car applied the brakes. Okay. After applying the brakes, we say the speed of the car is, we say 10 meter per second. We say here it is moving with 20 meter per second and here it is moving with 10 meter per second. Let's suppose the time is 1 second. Can I say here the car is slowing down? Yes, I say here the car is slowing down. Here the car is slowing down. If the car is slowing down over here, can you tell me the value of acceleration, sir? Acceleration will be final velocity minus initial velocity. That is 10 minus 20 divided by 1. And that will come out to be minus 10 meter per second square. So this acceleration here is retardation. Sir, you said retardation no. I said retardation can be negative also, it can be positive also. And in this case, it came out to be negative. Why? Because here the speed is decreasing. So that is the reason we say acceleration here is retardation. Okay. Sir, can you give one more example? Okay. Can you give one more example in which retardation is positive? See. Let's suppose I say I have got one more example over here. Let's suppose I have got a car. And this car is moving in the backward direction. Let's suppose with 20 meter per second. And the car reached over here. Okay, here its speed is, we say, 10 meter per second. And time is, let's suppose, 1 second. If the car is moving in the backward direction, do we take velocity positive as or negative? We say negative. Yes. Now in this particular case, can I say, sir, acceleration is final velocity minus initial velocity? Final is minus 10 minus initial is minus 20, because backward velocity we take as negative, divided by, we say, what is the time? Time is, sir, 1 second. Now here, this is plus 20 minus 10. That will come out to be plus 10 meter per second square. Now here acceleration is positive, but here acceleration is called retardation. Why, sir? Because here car is slowing down. Here car is slowing down and the acceleration here is called the retardation. Guys, is this crystalline clear till over here? I hope every single thing is crystalline clear. Okay. I hope every single thing is crystalline clear. Okay. Now guys, let's talk about the instantaneous acceleration. Sir, what is instantaneous acceleration? It is like instantaneous velocity. See guys, we say it is the acceleration at any particular instant. At any particular instant. Okay. Now see, if I say, sir, from this point to this point, the value of acceleration is, let's suppose, 30 meter per second square. That is what we call the average acceleration. But what is the acceleration at any particular instant, at this instant? Okay. Or we say at any particular instant, how fast velocity is changing with time. So I can say, sir, AINS, instantaneous acceleration. So if average acceleration is delta V by delta t, don't you think that instantaneous acceleration should be, that is dv divided by dt? Small change in velocity upon small change in time. Okay. I can simply say it is the acceleration at any particular instant. If the car is moving from this point to this point and it is continuously changing the velocity at any particular instant, how much is the change in velocity with respect to time? That is the acceleration at that instant. And that is what we call the dv divided by dt. That is what we call the dv divided by dt. This is the instantaneous acceleration. Now guys, I just want to tell you simple things, okay? It is simply like, if let's suppose we have got a car over here, okay? This car has traveled from this point to this point, and it is continuously, so we say I have got a car over here and this car has reached from this point to this point and it is continuously changing the velocity. Here velocity is changing. If I tell you, sir, is the car is accelerating over here, we say velocity is changing. Okay. If I ask you, is the car accelerating over here, you say, sir, yes. If I ask you how much is the acceleration at this instant, acceleration at this instant will be, how much is the change in velocity over here, that is dv. How much is the change in time over here, that is dt. That is what we call the instantaneous acceleration. Acceleration at any particular instant. Okay. Now guys, I just want to tell you one thing. We say as. If I say, the question is, if the velocity, of the car is, if the velocity of the car is v is equal to t square plus 2t, then find its, we say, acceleration at t is equal to 2 seconds. We say velocity of the car is given and we are supposed to find the acceleration at t is equal to 2 seconds. Guys, see, we say simply acceleration is, that is dv divided by dt. At t is equal to 2 seconds means we have to find the instantaneous acceleration. So we can say, sir, acceleration is dv by dt. Can I say this is d by dt of, what is velocity? Velocity is, sir, that is t square plus 2t, means you have to differentiate this. So I can say acceleration here will be differentiation of t square is, we say, sir, 2t, plus differentiation of t is, we say, sir, 2. Now guys, we have to find the acceleration at t is equal to 2 seconds. So we say at t is equal to 2 seconds. So can I put the value of t is equal to over here? So that is t is equal to 2. Okay. Then we say plus 2. 2 into 2 is 4. 4 plus 2 is 6. So acceleration is 6 meter per second square. So I can simply say at t is equal to 2 seconds, we say acceleration of the car is 6 meter per second square. 6 meter per second square. So that's the reason I'm telling you, this is what we call the instantaneous acceleration. So can I say, if we have to find the instantaneous acceleration, we have to simply differentiate. Now tell me one thing. If I say acceleration is dv divided by dt, if I say acceleration is dv by dt, can I do one thing over here? Take this dt and multiply over here. We can write this dv will come out to be a dt. Yes. Now I say integrate both the sides. Integrate both sides. So I'll write this as integration of dv is equal to integration of a dt. Now what is the integration of dv? Sir, it is small change in velocity. dv is what? Small change in velocity. If you keep on adding the small change in velocities, don't you think that dv plus dv plus dv, it will give you delta v? Yes. So I can say this is integration of a dt. Now I would want you guys to basically put this expression in a box. Why, sir? Because we say this expression tells us if acceleration is given in the question and you are supposed to find change in velocity, you do the integration. So we say use this equation when acceleration is given, and we have to find change in velocity. We say in that case we do the integration. And if velocity is given and we have to find the acceleration, in that case we do the differentiation. I would want you guys to focus over here, everybody of you. See guys, let's suppose if I give you the example over here. We say if the acceleration of the car is, guys see very carefully, if the acceleration of the car is, we say 4t, we say a is equal to 4t. If the acceleration of the car is a is equal to 4t, and initial velocity of the car is 2 meter per second, then find the velocity at 4 seconds. This is a very good question. I would want you guys to exactly focus on whatever I say. See guys, acceleration of the car is given over here and we are supposed to find velocity. When acceleration is given and we have to find the velocity or change in velocity, we do the integration. We say, how do we solve this particular question? We say, sir, delta v is equal to integration of a dt, because acceleration is given. Now see guys, what do we write over here? Delta v is equal to integration of, instead of a, I'll write over here that is 4t, and we say, sir, dt. Now we have to do the integration from 0 to 4 seconds, because we have to find the velocity at 4 seconds. So it is from 0 to 4 seconds. So I'll write over here delta v is simply, so integration of 4t will be, take this 4 out, so integration of t will be, that is t square by 2, power plus 1 upon power plus 1, and the limits are from 0 to 4. Now this is 2 1s are 2 2s are, so delta v in this particular cases, so we say 2, and then we have got 2t square. First we will put the upper limit over here, that is 4 square, minus, then in this t we will put the lower limit, that is 0. So 4 square is 16, 16 into 2 is 32. We say delta v is equal to 32. Change in velocity came out to be 32. Now guys, can I write this change in velocity as, this is final velocity minus initial velocity. Change means final minus initial, and it is equal to, we say, sir, 32. So final, v final minus Guys, what is the initial velocity? If the initial velocity of the car is 2 meter per second is equal to, we say, sir, 32. So take it over there. So we say V final is equal to, I'll write 32 plus 2. So final velocity will come out to be 34 meter per second. I hope this is crystal and clear to each and every single student out there. I hope this is crystal and clear to each and every single student out there. Okay, if initial velocity is given, acceleration is given, and you guys are supposed to find the final velocity, in that case, what do? We do the integration. And in the previous question, if you see, if velocity is given and we are supposed to find the instantaneous acceleration, what do? We do the integration. Sorry, we do the differentiation. Guys, smash the like button if you have not liked the session yet. I would want everybody of you to like this session as soon as possible. Liking the session is extremely mandatory. Okay. Now, let's suppose we have got this particular question over here. See, object is moving with a velocity v is equal to 4t square plus 2t plus 4. So, velocity of an object is given as, find the velocity and acceleration at t is equal to 1 seconds. Okay. Velocity is given as 4t square plus 2t plus 4. We have to find the velocity at t is equal to 1 seconds. Now see, we say at t is equal to 1 seconds, what is the value of velocity? Guys, see. Don't you think that in this particular question, we'll put the value of t is 1. So we say, sir, v is equal to 4 into, we say, sir, 1 plus 2 into 1 plus, we say, 4. Because this is the velocity changing with time. And we have to find the value of velocity at t is equal to 1 second. So we'll put t is equal to 1 over here. So velocity will be 4 plus 2 is 6. 6 plus 4 is, we say, sir, 10 meter per second. Now, if we have to find the acceleration, we say, sir, acceleration is simply that is dv by dt. If velocity is given and we are supposed to find the value of acceleration, in that case, we differentiate. Now differentiate this particular equation. So we say acceleration will be differentiation of velocity. Now what is the differentiation of velocity? 4 into 2 is, we say, sir, 8t. Now plus, what is the differentiation of 2t? That is 2. What is the differentiation of constant 4? That is 0. This is the acceleration. Now I can say at t is equal to 1 seconds, acceleration will be simply 8 into, put t is equal to 1 plus 2. So 8 into 1 is 8, 8 plus 2 is, we say, sir, 10 meter per second square. This is the acceleration at t is equal to 1 seconds. Next, okay, one more thing I would like to tell you over here. What is that? See guys, we say acceleration is dv divided by dt. We said this is that formula of acceleration in which time is present. I would want you guys to basically, we say, multiply and divide with dx. Multiply and divide with dx. When you do that, you can say this acceleration will be, that is dv by dt into, we say, dx by dx. We say into that is dx by dx. If you again cancel these, it will again come out to be dv by dt. Now we say interchange the position of this and this. So I can write acceleration will be, that is dv divided by dx into, we say, sir, this is a dx by dt. Now guys, can you tell me, sir, what is the formula of velocity? We say, sir, velocity is simply dx by dt, or we say ds by dt. So instead of this dx by dt, can we write velocity? So we write acceleration is equal to, instead of this, I'll write velocity. And then we have got dv divided by dx. I would want you guys to put up this in a box. So we say this is the acceleration in terms of displacement or position. So this is the acceleration position relation. Now come over here. In this particular question, you have got a car is having a velocity. We say, sir, let's suppose if there is a car, okay, and this car has a velocity v is equal to k times of x, and we are supposed to find the acceleration at x is equal to 2 meters. Guys, see, sure, they are asking us the acceleration after 2 meters. We have two formulas of acceleration. A is equal to dv divided by dt. Another one is A is equal to v dv by dx. What do you think? Which formula should we use over here? First one or second one? Obviously, sir, second one. Why? Because here velocity and position is given, and we have to find acceleration after x is equal to. So we cannot use this particular equation because here time is involved. Here displacement is involved, position. Now see, we can say as we say acceleration is equal to v dv divided by dx. Okay. Yes. Now guys, I can write over here acceleration instead of v. What is the value of v? Sir, I'll write over here, that is k times of x. Then I can write d by dx of v. What is the value of v? I'll write over here, this is k times of x. Now guys, this k into k will be how much? We say acceleration will be k into k is over here, that is k square. K into k is how much? That is k square. And then you have got this x. Sir, why did you take this out? Because k is constant. Now we have over here dx divided by dx. Now dx by dx is 1. So I'll write acceleration came out to be k square into x. This is the acceleration. Now guys, if this is the value of acceleration, we have to find the acceleration at x is equal to 2. Can I say at x is equal to 2 meters? Can I say at x is equal to, we say, sir, 2 meters. What is the value of acceleration? We say acceleration is k square. Instead of x, I'll put over here 2. So acceleration will come out to be 2k square. Okay. Is this clear? Is this clear? Next. A very good question, a very important question that I'd like to show you over here. If the position of an object is given as x is equal to t square minus 4t plus 5. Let's suppose we have got a car. This car is moving according to this relation, x is equal to t square minus 4t plus 5. According to this relation, the car is moving. Okay. And then find the instant when velocity becomes 0. We have to find the value of time when velocity of the car becomes 0. Guys, see. If I say first find the velocity. Velocity is simply, that is differentiation of this position, that is dx by dt. Okay. So How much is that? So I can write over here. What is the differentiation of this? Sir, differentiation of t square is power down, power minus 1, that is 2t. Then differentiation of 4t is, we say, sir, 4. And differentiation of 5 is, we say, sir, 0. Okay, this is the velocity. Now we say we have to find that time when velocity is 0. Put the value of velocity is equal to 0. Sir, put velocity is equal to 0. So that means this is the velocity. So that means 2t minus 4 is equal to 0. Now take this over here. So 2t is equal to 4. 2 ones are, 2 twos are. So t is equal to 2 seconds. So I can say at t is equal to 2 seconds, velocity is equal to 0. So when time t is equal to 2 seconds, the car will come to rest, velocity becomes 0. Now even if you put over here, 2 into 2 is 4, 4 minus 4 is 0, velocity will come out to be 0. So at this time velocity is 0. Then it says that, and the displacement when object comes to rest, and you have to tell me what is the value of displacement when object comes to rest, and to find the displacement when velocity is equal to 0. And guys, this I'll give you as homework. Sir, why? Because almost 5 to 6 questions I have shown you on this particular format previously. That's why this I'm giving you as homework, and you will find out the displacement when velocity is 0. Time is already given. So from 0 to 2 seconds, you have to find the displacement. Done. Next. We have got velocity k root x. You have to tell me acceleration. Let's suppose we have got a car over here. Okay. This car has got a velocity of k under root of x. And if this is the velocity of the car, you guys are supposed to tell me the acceleration. Guys, here velocity and position relation is given. So x is over here. So we say use acceleration is equal to v dv by dx. We'll use this equation because x is over here. That's why we use this equation. We will not use dx by dt. If it was v is equal to k under root of t, in this particular case, we will be using v is equal to dx by acceleration a is equal to dv by dt. That equation in which time is involved. But here x is involved, that's why I'm using this particular equation over here. Now see guys. So can I say this acceleration will be, instead of velocity, so we'll put this is k under root of x. And then I can say d by dx of, instead of this velocity, I'll write over here k, and this is x raised power 1 by 2. Why? Either you write root x or you write x raised power 1 by 2, it's one and the same thing. Because the value of root is also 1 by 2. Now, I can say acceleration over here is, guys see, k is constant, take this k out. So it will be k square, and then it will be root x, and then it was d by dx of x raised power 1 by 2. Now do the differentiation of x raised power 1 by 2. I will tell you. Guys see, if I say x raised power 1 by 2, what is the differentiation? How to do the differentiation? Power down, power minus 1. So take this power over here, 1 by 2 x raised power minus 1, 1 by 2 minus 1. So it is 1 by 2 x raised power. 1 by 2 minus 1 is minus 1 by 2. Now, I can write it something like this, 1 upon. If I take x raised power minus 1 by 2 in the denominator, so it will become x raised power plus 1 by 2. So I can write it like this also, 1 upon 2 root x, because value of root is also 1 by 2. So directly I'll write over here, acceleration is, that is k square root x. Differentiation of x raised power 1 by 2 is 1 by 2 root x. So it is, I'll write over here 1 by 2 root x. Okay. Now this root x and this root x will cancel. So acceleration will come out to be, that is k square divided by 2. This is the value of acceleration in that particular case. This is the value of acceleration in that particular case. Okay. Next, average acceleration. Average acceleration. Guys, see, if I say the car is moving from A point to B point, a car is moving from A point to B point, okay, and it is changing the velocity from A point to B point. Now, if I say how much is the total change in velocity from A point to B point, you say, sir, delta V. Sir, how much is the total change in time from A point to B point? That is delta T. So I can write, sir, average velocity, average acceleration is simply, that is total change in velocity upon, we say, total change in time. So how to write this AAVG? Simply, that is delta V divided by delta T. Or you can also say that as V final minus V initial upon T final minus T initial. Guys, if I say from A point to B point, how much is the acceleration? That is average acceleration. If I say at any particular instant, how much is the acceleration? That is the instantaneous acceleration. This is the difference. This is the difference. So this is delta V by delta T. Instantaneous is dV by dt. Okay, that is in general from A to B, how much is the change in velocity with respect to the time? Okay. Okay, great. Next we have this question. A particle of unit mass undergoes one-dimensional motion. I hope this is visible to each and every single student. I hope this is visible to each and every single student out there. Yes, it is visible. It is visible. So the question says that a particle of unit mass undergoes one-dimensional motion such that its velocity varies according to the relation. Means it says that we have, let's suppose, got a particle over here, or you say car. It is going under one-dimensional motion, means it is moving along a straight line. And it has got a velocity v is equal to, that is beta x raised power minus 2n, where beta and n are constants. So this is the velocity of the car. The acceleration of the particle is, we are supposed to find the acceleration of the particle. Velocity is given in terms of position, and we have to find the acceleration of the particle. Sir, this is a very easy question. See guys, we say use acceleration is equal to v dv by dx. Sir, why? Because here velocity and position relation are given. Velocity versus time relation is not given. Velocity versus position relation is given. That's why I use this equation. So can I say this acceleration will be, what is the value of velocity? Sir, that is beta, and then we have x raised power minus 2n. Then I write d by dx of, sir, this velocity. So that is beta and x raised power minus 2n. X raised power minus 2n. Okay, yes. Now guys, see, we have to do the differentiation of this term. Take this beta out because beta is constant. Constant comes out of the differentiation. Beta into beta is beta square. So acceleration will be beta square. And then we have x raised power minus 2n. Now, what remains over here? X raised power minus 2n. So we say d by dx of x raised power minus 2n. So we have to do the differentiation of this term. How to do the differentiation? I'll write over here. So acceleration will be, so we write this is beta square and then write x raised power minus 2n. Now, how to do the differentiation? Sir, it is power down, power minus 1. So what is power down? So that is minus 2n, you take it down, and then x raised power, power minus 1, that is minus 2n minus 1. And I can write this acceleration is equal to beta square x raised power. And one thing, my dear friends, can you take this 2n also out? Yes. So it is, so take this minus 2n and then we have got beta square, and then you have got x raised power minus 2n, this, and then you have got x raised power minus 2n minus 1. Now see guys, x raised power minus 2n, x raised power minus 2n. Minus 2n becomes minus 4n. So it will be acceleration is minus 2n beta square, and this becomes x raised power minus 4n minus 1. Okay. So this is the final value of the acceleration. This is the answer. This is the answer. This is the answer in this particular case. Next, let's talk about the equations of motion. Let's talk about the equations of motion. Okay. See guys, I would want you guys to understand certain things over here. That is. See, let's suppose I have got a car over here. Understand very carefully. And this car is moving with a velocity u. Okay. We say after some time t, here t is equal to 0. After some time t, here its velocity is v. Let me see if this is visible. Let me see if this is visible. Yes, it is visible. See guys, I say I have got a car over here. Okay. Initially its velocity is u. And we say after some time its velocity is v. Here velocity is u. After some time its velocity becomes v. Okay. Now guys, this we don't know. It is not v, we have to find out. We say acceleration in this journey is constant. Okay. And I am saying that you guys are supposed to tell me what is its final velocity. Car is moving initially time t at t is equal to 0, velocity is u, and acceleration is constant. After time t, we have to find its velocity. Velocity after time t means if the car started from, let's suppose, this point, after some time it will gain some velocity. What will be the value of that velocity? Guys, see. We say as if we have to find the velocity, can we simply say, sir, acceleration is equal to, that is dv divided by dt. Acceleration is dv by dt. See guys, in this particular case, acceleration is given and we have to find velocity. We can simply use this equation. Take this over there. So I'll write over here dv is equal to a dt. Now I say integrate both the sides. So integration. Guys, see. What is initially the velocity, sir? U. So put the lower limit as u. What is finally the velocity? That is v. This is we have to find out, that is v. Okay. Let me erase it. I'll write over here. So we say, take multiply over here. This will be dv is equal to integration of a dt. Now guys, so we say integrate both the sides. Initially, the car started from this point, initial velocity is 0, acceleration is constant. After time t, how much is the velocity of the car? That we have to find out. We are using this equation. Multiply it over here and then do the integration. Now put the limits. Sir, at t is equal to 0, how much is the velocity, sir? At t is equal to 0, because with respect to time, we are putting limits. Velocity is u. Sir, after time t, we say velocity becomes v, and this we have to find out. Now see, sir, what is the integration of dv? This d and integral sign will cancel, it will be v. Okay, and it is from u to v. Limits are from u to v is equal to. Sir, is the acceleration constant in this journey? Yes. So take the acceleration out. So if we take acceleration out, so it will be, sir, this and this will cancel, it will be, sir, t. And this is from 0 to t. Now, if you put the upper limit over here, it will become v minus. Now, in this we put lower limit, that is u is equal to. Now, here a, in this t put the upper limit as t minus 0. So, it will become a into t. So, we say v is equal, take this u over here, u plus a into t. So, my dear friends, this is the velocity. This is the velocity of the car after time t. This is the velocity of the car after time t. This is the velocity of the car after time t. Guys, what I'm trying to say in this particular case is, if from now onwards in a question, initial velocity is given, acceleration is given, time is given, you can use this equation to find the final velocity. Now the question over here is, guys, see, if let's suppose I say acceleration was not constant over here. If acceleration is not constant, do you think that you can take this acceleration out of the integration, sir? No. Why? Because if acceleration is not constant, you cannot take out that out of the integral sign. Then we cannot reach out to this result. Yes, sir. So can I say, we say use this equation only when acceleration is constant. Otherwise, this is invalid. This is only useful when acceleration is constant, because with the proof itself, I am saying that take out the acceleration. We only take out the acceleration over here if it is constant. If it is not constant, we cannot take it out. So if we cannot take it out, we cannot reach this particular expression over here. How will you integrate then? How will you reach it over here? So that's why I use this equation when acceleration is constant. Sir, if acceleration is not constant, then which equation should I use to find the velocity? We say if acceleration is not constant, then use we say delta v is equal to integration of a dt. Use this equation to find the acceleration. Then you can use also v is equal to ds divided by dt. You can use this equation also to find the velocity if displacement is given. If acceleration is given, you can use this equation to find the velocity. So these are the equations of motion which can be used even if the acceleration is constant, or if the acceleration is not constant. We can use all of these equations anytime, anywhere. Okay. I hope this is getting crystalline clear. Just a second, I'll get some water. Okay, just a second, I'll get some water. Next, we will have to talk about, we said displacement after time t. That is displacement after time t. Guys, see, listen to me very carefully. We say, let's suppose there is a car which started from this point, okay? And its initial velocity is, let's suppose u. There is a car which started from this point and its initial velocity is u. We say after some time, let's suppose the car reached this particular position. I am asking you, we say this much is the displacement of the car covered in this duration, We say initially it is moving with velocity v, u, and initially let's suppose time is 0, and when the car reached over here, we say time is t. T is equal to t. And my dear friends, let me just tell you, we say if somebody asks you what is the value of this displacement, how much displacement the car has done in this time, if acceleration of the car is, we say, sir, constant, if it is moving with a constant acceleration, we are supposed to find the displacement. In the previous equation, we had to find the velocity. But right now, we are supposed to find the displacement. Okay. Yes. So guys, we say, I use the equation as we say v is equal to u plus a into t. We use this particular equation, v is equal to u plus a into t. Okay. Now guys, in this particular case, this is the velocity of the car after time t. Can I write this v as, I say this is ds divided by dt. I'll write this velocity as ds by dt. And I can say over here, this is u plus acceleration into time. I want you to multiply this over here. So we say this will be ds is equal to u plus a into t and u plus a into t, and we write over here this is dt. Now guys, in this particular case, I say integrate both the sides. Okay. Integrate both the sides. If you do the integration on both the sides, what will you write? You say, sir, it is integration of ds is equal to integration of u plus a into t, okay, and then you say dt. Now guys, you have to basically use the limits. We say, let's suppose initially here displacement was 0 and after time t displacement is s. So we say it is from 0 to s. And initially let's suppose time was 0 and we say finally time is t. Now what is this ds, integration of ds, it will give you the total displacement s is equal to, guys, see, now limits are from, we say, sir, 0 to s. Now what is this? Sir, what is the integration of u? We say this is integration of u dt. So take u is constant, take this u out. So we say it is integration of d dt. This and this will cancel, so it will come out to be ut. So integration of u is simply that is u into t. Okay. Then we say plus. What is the integration of at, my dear friends? Guys, see. Integration of a is, guys, I'll write over here, integration of a into t, and this is dt. Acceleration is constant. We know in this particular case, acceleration is constant. Take acceleration out. Then it is integration of t dt. Can I write it something like this? A, integration of t is t square divided by 2. So same I'll write over here a, and then we say t square divided by 2. And if we put the limits over here, limits are from 0 to t. And I can say over here, this is s is equal to, we say initial velocity into time plus, and this is 1 by 2, s is equal to ut plus 1 by 2 at square. So this is what we call the second equation of the motion. And this gives us, we say this equation gives us the displacement after time t. Displacement after time t. This gives us the displacement after time t. Okay. Tell me guys in the chats, is this crystalline clear till over here? Is this clear till over here? Is this clear till over here, guys? So this is the second equation of motion. This is the second equation of motion. Guys, if you have not liked this session yet, like it as soon as possible. Okay. So this is the displacement of the car after time t. Okay. Now, my dear friends, let's talk about the velocity after covering the displacement x. Guys, see. Let's suppose I have got a car over here. This is the car, okay? And this car is moving with a velocity u. And we say after some time, the car has, let's suppose, reached this particular point, okay? My dear friends, in this duration, let's suppose the car has covered the displacement, we say, let's suppose S. From here to here, the car has covered the displacement S. I am asking you, after covering the displacement S, what is the final velocity of the car? These are the two different questions. Guys, if I say after time t, what is the displacement of the car? That is question number 1. Next question is, after displacement S, what is the velocity of the car? And that is what we call the displacement. We say to find the velocity after displacement, we say, sir, S over here. Okay, guys, see, if I say this car started from this point, sir, after time t, the car reached over here. What is the velocity of the car after time t? That we already got. V is equal to u plus a into t. If I say this car started from this point, it has covered the displacement S. What is the displacement of the car what is the velocity of the car after displacement S? These are the two different questions, guys. See. In this particular case, I would want you guys to use, we say, use A is equal to V dV divided by ds. This is the equation that we have studied. This is the acceleration versus, we say, displacement relation, A and S relation. Guys, see, in this particular case, I want you to multiply this A over here. So this A into ds will give you, that is V into dV exactly over here. Now guys, in this particular case, I want you to integrate both the sides. Integrate, we say, both sides. If you integrate both the sides over here, what will you get? Guys, I'll write integration of, this is A ds, and then we say is equal to integration of V dV. Now the question in this particular case is, what is the initial velocity? Initially it is velocity is u. So when velocity is u, we say, what is the displacement at that point of time, sir? 0. Here displacement is 0. And here displacement is what? S. So car has covered the displacement S. What is the final velocity? That is V. What is the final displacement, sir? That is S. When initial velocity is u, displacement is 0. Here it is integration ADS. Here you have to put the limits in terms of displacement from 0 to S, from u to V. Now guys, take this A out. Why, sir? Because A is constant. This is the case when acceleration is constant. I can write over here, then it is acceleration, then it is A, we say ds, from 0 to S. And here I can write, sir, integration of V. So that I'll write directly over here. This is V square divided by 2. Because here integration of V with respect to dV, that is V square by 2 from, we say, u to V, from u to V. And here this and this will cancel, so it is A into S. So can I say in this particular case, this will be A into S here, and here it will be what? That is v square. See guys, this is v square by 2. First you put here in this v upper limit, then minus lower limit. So it will be v square minus u square divided by 2. Because we put first upper limit, then we put the lower limit. Okay. Now multiply over here. So this will be 2as is equal to v square minus u square. So I can write over here v square is equal to u square plus 2as. Now guys, this is the final velocity. This is the final velocity after displacement s. This is the final velocity of the car after covering the displacement s. This is the final velocity of the car after covering the displacement s. Okay. So we say this is the velocity of the car after displacement s. And we use this equation also only when acceleration is constant. When acceleration is constant. Next. Displacement in nth second. This is very important. Displacement in nth second. I want you guys to understand very carefully. See guys. Let's suppose I have got a car over here. Okay, I have got a car over here. Okay. And this car basically is moving something like this. This car is moving, let's suppose, something like this. Okay. My dear friends, listen to me very carefully. If I say after t is equal to n seconds, the car has reached this particular position. Sir, what is this n? N can be anything. 10, 15, 20. So we say after n seconds, the car is over here. Okay. Yes. Now guys, listen to me very carefully. Can I say, sir, if this is t is equal to n seconds, can I say, sir, this will be, if this is n seconds, before n seconds, what will be the time? N minus 1. If I say n is equal to 10 seconds, what is the second last second? You say, sir, 10 seconds, and before that will be 9 seconds. If it is n seconds, can I say it will be n minus 1 seconds? This will be n minus 1 seconds. T is equal to n minus 1 seconds. Yes. Now guys, in this particular case, I want you guys to understand one thing. What is that? You have to tell me this displacement in the nth second. This is displacement in the nth second. That is what is the equation. You guys are supposed to tell me what is the displacement in nth second. I am not telling you to tell me the displacement in the nth seconds. No. In nth second. See guys, it is like, let's suppose you started from this point and you reached this point. This is after 1 second you are here, after 2 seconds you are here, after 3 seconds you are here. I'm saying how much is the displacement in 3 seconds? You say, sir, this much is the displacement in 3 seconds. How much is the displacement in 2 seconds? This much is the displacement in 2 seconds. How much is the displacement in first second? You say, sir, this is the displacement in first second. This is the displacement in second, and this is the displacement in third second. So we say this is the displacement in S in third second, in the last second. Same over here. This is what we call the displacement in nth second. This is what we call the displacement in nth second. Okay. Yes. This is the displacement in nth second. We have to find this displacement in nth second. Guys, see, how do we find it? Let's do one thing. First, we will find the displacement in, we say n seconds. Let's first find the displacement in n seconds. Let's first find, guys, we say we'll first find the displacement from here to here. This is, sir, displacement in n seconds. Okay. How do we find it? Put the value of, with the help of this particular equation. with the help of this equation, S is equal to ut plus 1 by 2 at square. Here instead of t, we will put t is equal to n seconds and we'll get the displacement. Yes, we'll get the displacement. Same in this particular case, we'll get this. Then once we get it, then after this we'll find the displacement in n minus 1 seconds. Then we'll find the displacement in n minus 1 second. This is displacement in n minus 1 seconds. This is displacement in n minus 1 second. Now, once you get the whole displacement, then you will subtract this, you will get the value of this. Guys, if let's suppose this is 20 and this is let's suppose 18. So 18 minus 20, that will be 2. So you'll get this displacement, that is 2. So what we'll do in this particular case, we say displacement in nth second is equal to, I say displacement in, we say n seconds minus displacement in n minus 1 seconds. This is the logic that I'll use over here. Tell me, is this crystalline clear? Is this crystalline clear? Everybody out there, is this crystalline clear? Is this crystalline clear? Tell me, guys. In the chats, everyone means everyone. Okay. Now, guys, further we can write it something like this. See. Further we can write it something like this. Sir, S nth is equal to, guys, displacement in n seconds. Guys, see, displacement in n seconds. How can we write it? Sir, use ut plus 1 by 2 at square. Sir, u, instead of t, I'll write over here n. ut plus 1 by 2. Let's suppose acceleration is a. T square. So that is n square. Un plus 1 by 2 an square is the displacement in n seconds. Then we say minus displacement in n minus 1 seconds. You say, sir, ut. Here I say t. What is the value of t? That is n minus 1. Okay. Then we say plus 1 by 2 a t square. That is once again n minus 1 whole square. Okay. And once you solve it, open this a minus b whole square. Here also, once you solve this, final answer in this particular case will come out to be, that is u plus a by 2. Then we say 2n minus 1. 2n minus 1. I would want you guys to keep this in your mind. This one, u plus a by 2 into 2n minus 1. U is the initial velocity with which it left over here, okay, and then a is the acceleration over here, and acceleration in this particular journey is constant, okay. Then 2n minus 1, n is the nth second over here. Is this crystalline clear? Please tell me in the chats. Okay. So this is basically the displacement in nth second. Now let's talk about the average velocity. Average velocity when acceleration is constant. Guys, see, I would want you guys to focus exactly over here. See, average velocity when acceleration is constant. See, guys, when it comes to the average velocity, we say, sir, it is total displacement upon total time. Average velocity is total displacement upon total time. Can I just write over here, sir, this What is total displacement? Sir, S is equal to, we say ut plus 1 by 2, we say at square, and divided by, we say time t. Divided by, we say time t. Instead of displacement, I am writing this, time is t over here. We say this t and this square will get cancelled out. So we say average velocity in this case will be u plus 1 by 2 a into t. Now guys, tell me one thing. Have you ever heard about this? We say we say v is equal to u plus a into t. Okay, v is equal to u plus a into t. Now, can I just write over here v minus u is equal to a into t? Yes, v minus u is equal to a into t. Now, I want you, instead of this at, put this v minus u. You can write, sir, v average over here will be simply, that is u plus 1 by 2. Instead of at, I can write v minus u. V minus u. Now, guys, multiply this over here. So you can write this v average simply, that is, this is 2u, then we say plus v, then minus u, then we say divided by 2. Tell me one thing, 2u minus u will be how much? That is u. So v average in this particular case will be simply, that is u plus v divided by 2. So my dear friends, if acceleration is constant, always remember, if acceleration is constant, in that case, initial velocity is given, final velocity is given. You can find the average velocity directly. So we say use this only when acceleration is constant. When acceleration is constant. Even one more thing I would want you guys to focus over here. Sir, what is that? See. We say now, displacement. Can I write, sir, displacement is, we say average velocity into time. Yes. Displacement is average velocity into time. Now, average velocity we know. So I can write, sir, displacement will be, instead of average velocity, u plus v divided by 2 into, we say, sir, time t. Put this also in a box. Put this also in a box. Put this also in a box. So this is the displacement, that is u plus v divided by 2 into t, that is time. And on the same concept, let me show you the question over here. Now see, look at the question, guys. A particle moves in a straight line with a constant acceleration. There is a particle. It is moving in a straight line with a constant acceleration. Okay. So we say acceleration here is constant. It changes its velocity from 10 to 20 meter per second. So here its velocity is 10 meter per second. Okay. We say it changes its velocity from, we say, 10 to 20 meter per second. We say finally its velocity becomes 20 meter per second. Initially it is 10, finally it is 20. While passing a distance of 135 meters. So it has, we say, passed a distance of, we say, 135 meters. The value of t is, you guys are supposed to find the time in this particular case. Guys, tell me one thing. Look at this. Sir, displacement is equal to u plus v by 2 into t. Displacement is equal to u plus v by 2 into t. I'll take it over here. Now, I can write, sir, displacement is equal to u plus v by 2 into t. What is the value of displacement over here? That is 135. This is 135 is equal. What is the value of initial velocity? That is 10 plus. What is the value of final velocity? That is we say, sir, 20 divided by, we say 2, and then we say into, we say, sir, t over here. Okay. Now, my dear friends, so this will be, can I just write over here? This will be 1 135 is equal to 30 by 2. So this will come out to be 15t. Now this is 135 divided by, I say 15. So it will come out to be, we say t. Okay. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. I'll be taking the regular classes. That is not a problem. You guys tell me, is this clear? Is this clear? Please tell me in the chats. Everyone means everyone. Okay. Yeah. I'll be taking the regular classes. Not a problem. Chill. Okay. So time here will come out to be 15, 135. So it will come out to be 9 seconds. So time is 9 seconds over here. Great. Next, we have got this question over here. We have got this question over here. Guys, see. The initial velocity of a particle moving along x-axis is u, and its acceleration is given as ax. There is a particle which is moving. Let's suppose this is the particle which is moving along x-axis. Okay. And its acceleration is given as k times of x. Its acceleration is given as k times of x. Which of the following equation is correct between velocity and position? Which of the following equation is correct between velocity and position? Which of the following equation is correct between velocity and position? Now guys, see. We say, here, you can clearly say this acceleration is not constant. If acceleration is not constant, you cannot use the equation v is equal to u plus at, s is equal to ut plus 1 by 2 at square. Or we say v square minus u square is equal to as. You cannot use those equations. Those can be only used when acceleration is constant. So here acceleration is variable. Acceleration depends upon x. Now guys, see in this particular case, what will we do? We say as in this particular case, we say a is equal to v dv divided by dx. We'll use this equation. Okay. Now, multiply this over here. We say, sir, a dx is equal to v dv. Now integrate both the sides. We'll integrate. Hey, see. In this particular case, instead of this a, I'll put the value of acceleration, that is k times of x. So I'll write over here, this is k times of x and this is dx is equal to, we say, integration of, we say, v dv. Now, we say initially, displacement is 0. From 0 to x, I'll put the limits. And here, initial velocity is u, final velocity is v. So from u to v. So here I'll write from 0 to x, here I'll write from u to v. Now guys, understand one thing very carefully. What is that? See, I say, take this k out. If I take this, why? Because k is constant. So I say take this k out, then integration of x will be x square by 2. And then over here, what is integration of v with respect to dv? That is v square divided by 2. And it is from u to v. Okay. Now guys, understand one thing over here. This is kx square by 2. I'll write it over here. This is kx square divided by 2 is equal to. And we say this is, guys, first you put the upper limit, then you put the lower limit. So v square minus u square divided by 2. Then we'll write over here v square minus u square divided by 2. 2 and 2 will cancel. So we say this is v square minus u square is equal to kx square. So we'll write v square is equal, take it over there, u square plus. Here it is minus. If you take it from the other side, it becomes plus. So then it is kx square. Now match with the options. V square is equal to u square plus kx square. So option C is correct. So in this particular case, we say option C is correct. Option C is correct. Next, we have got this particular question. Guys, is this particular question clear? See, the acceleration of a particle is increasing linearly with time as bt. They are saying that acceleration is given as bt. There is a particle, its acceleration is bt. And this acceleration is variable. It is not constant. This acceleration is variable, it is not constant. Okay, this acceleration is variable, it is not constant. Okay, guys. Guys, hit the like button if you have not liked this session yet. I would want you guys to hit the like button as soon as possible. Now, we say acceleration is given as b into t. The particle starts from the origin with the initial velocity v naught. Like, it is saying that we have got a particle over here. This particle starts with the initial velocity v naught. And it is moving in this path, let's suppose. And its acceleration is given as b into t. The displacement traveled by the particle is, we are supposed to find the displacement traveled by the particle. It's a very good question. It's a very good question. Okay. Now, guys, sure. In this particular question, we can say acceleration is not constant. If acceleration is not constant, do you think that I can use this equation s is equal to ut plus 1 by 2 at square to find the displacement? No. No, sir. No. Why? Because acceleration is not constant. Acceleration is variable. So if acceleration is variable, I would want you guys to focus over here. We say as we say v is equal to, as we say a is equal to dv divided by dt. A is equal to dv divided by dt in this particular case. Okay. Now, guys, tell me one thing, or I'll write this particular equation directly over here. We say as acceleration is given as b into t. Can you write the value of acceleration as, we say, sir, this is dv divided by dt is equal to, we say, sir, b into t. Because we know acceleration is dv divided by dt. Now multiply this dt over here. So it will be dv is equal to, we say, bt, and then we write over here dt. Now integrate both the sides. If we do integration. Now put the limits. Sir, limits are from, initially its velocity is v naught. Finally, let's suppose its velocity is v. So we say it is v naught and it is v. Initially time is 0 and finally let's suppose time is t. Now, guys, tell me, what is the integration of dv? Sir, integration of dv is v and it is v naught to, we say, v is equal to. Now, what is the integration of bt? B is constant, take it out. So we can say t square by 2. So it is b, and integration of t will be, that is t square divided by 2. And limits are from, we say, sir, 0 to t. So it will be 0 to t only. Now, can I just write over here, this is v minus v naught is equal to bt square divided by 2. Now take it over there. So v is equal to v naught plus, here it is minus, over there it will become plus. Then it becomes b t square divided by 2. bt square divided by 2. Okay, this is the velocity. But what we are supposed to find out, sir, displacement. So can I write this as, can I write this velocity as? I can write this velocity as, this is ds divided by dt. And I'll write over here, see, this is v naught. So I'll write over here, this is v naught plus b t square divided by 2. Now multiply this dt over here. So I can say this is ds is equal to, we say v naught plus, then we say bt square divided by 2 multiplied by, we say, dt. Okay. Now integrate both the sides. Now integrate both sides. So we say this is integration of ds is equal to, we say integration of v naught plus, we say bt square divided by 2 into, we say, sir, dt, into, we say, sir, dt. Now can I write in this particular case, sir, what is the integration of ds? It will give us the total displacement, that is s. Okay. It is not hard. You guys focus over here. Just there are 3 to 4 bit more calculations. So we say this is s is equal to integration of v naught with respect to dt. Guys, see. If I say it is integration of v naught with respect to dt, what will you do? Take this v naught out, integration of dt. This and this will cancel, so it will be v naught into t. Just put over here. So it will be v naught into t. This is the integration. Then we say plus integration of bt square by 2. I'll write over here. Integration of bt square divided by 2 and dt. Now here b by 2 will come out because they are constants. It is distance, one and the same thing over here. If I'm finding displacement distance over here, it is a straight line. It's a straight line. So it's one and the same thing. So I can say this is b by 2 integration of t square and this is dt. Now guys, so this is b by 2. Integration of t square will be how much? That is t cube by 3. Now 3 into 2 is 6. So it will be bt cube divided by 6. So integration of this will be bt cube divided by 6. So this is basically the distance traveled over here by the car, bt cube divided by 6. bt cube v naught into t plus bt cube divided by 6. Guys, is this clear? Please tell me in the chats. Is this clear? And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Everyone means everyone. Is this crystalline clear? Is this crystalline clear? Yes. Next. An important topic now we need to discuss in this particular case. Ratio of total displacements in 1 second, 2 seconds, this. Guys, see. Let's suppose we have got a car. This is the car over here. Or this is an object. And it started from rest. Initial velocity is 0. Okay. And the car is moving something like this. Something like this. This is car is moving something like this. Okay. And car has finally reached this particular position. Okay. Can I say in this particular case, my dear friends, we say after 1 second the car is over here. We say after 2 seconds the car is here. I can say after 3 seconds the car is here. I can say after 4 seconds the car is here. And after 5 seconds the car is here. Yes. Now guys, tell me one thing. I would want you guys to give me the clear answer in this particular case. Crystal and clear answer in this particular case. Okay. Can I say, sir, this is the displacement traveled by the car in 1 second? Yes, sir. Can I say, sir, this is the displacement traveled by the car in 2 seconds? Yes. Can I say, this is the displacement traveled by the car in 3 seconds? Yes. Can I say, this is the displacement traveled by the car in 4 seconds? Yes. Can I say, this is the displacement traveled by the car in 5 seconds. Yes. Okay. So this much is the displacement traveled by the car in 1 second. This is in 2 seconds. This is in 3 seconds. This much in 4 seconds. And this much in, we say, sir, 5 seconds. Okay. Guys, understand very carefully. Understand very carefully. I would want you guys to understand over here. Can you tell me how much is this displacement if the acceleration is a? We say, sir, this displacement will be s is equal to ut, initial velocity is 0, plus 1 by 2 a t square. Guys, see, s is equal to, initial velocity is 0, so it will be 0, 1 by 2, acceleration. And time here is how much? 1 second, so it will be 1 square. So it will be simply, that is a by 2. Let's call it x. Let's call it x. Now, can you tell me how much is the displacement in 2 seconds? So you'll say s is equal to ut plus 1 by 2 at square. Initial velocity is 0. Acceleration is constant. So 1 by 2 a t square. T is, we say, sir, 2 square. So can I say that will be 2 square is 4. That is 4a divided by 2. Guys, see, what is a by 2? A by 2 is x. So I can say this is 4x. So I am saying that if this displacement is x, so this will be 4x. Let's find this displacement in 3 seconds. You say, sir, s is equal to 1 by 2 a t square. T is 3 square. 3 square is 9. So it will be 9a divided by 2. So we say a by 2 is x, that is 9x. So can I not say in this particular case this is 9x? Absolutely, yes, I can say this is 9x. I can say this is 9x. Okay. And similarly, my dear friends, in this particular case, if this is 9x, how much is this? This is 16x. And this is 25x. Okay, because 4 square is 16, 5 square is 25. Then next one will be 36x and so on. So remember, my dear friends, in this particular case, I can say, guys, see, a car started from rest and acceleration is constant. This is also the condition. We say in 1 second it covers as displacement, in 2 seconds 4x, in 3 seconds 9x, in 4 seconds 16x, in 5 seconds it will cover 25x and so on. Can I say? We say ratio of displacements. I said displacement in 1 seconds is to, we have to find the ratio, is to displacement in 2 seconds is to displacement in 3 seconds is to displacement in 4 seconds is to displacement in 5 seconds. Can I say this ratio will be, it will be x is to 4x is to 9x is to 16x is to 25x. This will be the ratio in this particular case. Yes, 110%. Now, my dear friends, can I say, sir, we can say this is 1 is to 4 is to 9 is to 16 is to 25 and so on. This is basically the ratio that we have in this particular case. That's what we call the ratio of total displacements in 1 second, 2 seconds, 3 seconds, so on. X is to 4x, 9x, 16, 24. Next we have ratio of displacements in first second, ratio of displacement in first second, second second, third second, fourth second. Guys, see, let's suppose the car started from this point. Let's suppose the car started from this point. Okay. And we say its initial velocity is 0. Initial velocity is 0. And the car is moving something like this. Car is moving something like this. Okay. Car is moving something like this. And finally, the car has reached this particular position. Guys, let's suppose in this particular case, After 1 second, the car is over here. We say after 2 seconds, the car is here. After 3 seconds, the car is here. After 4 seconds, the car is here. And 5 seconds, the car is here. Tell me one thing. Guys, can I say, sir, this is the displacement of the car in first second. Can I say, this is the displacement of the car in second. Car has covered this much of displacement. Can I say, this is the displacement of the car in third second? Yes. Can I say, this is the displacement of the car in fourth second? Can I say, this is the displacement of the car in fifth second? Yes. Guys, displacement in first second, displacement in second, displacement in third second, displacement in fourth second, displacement in fifth second. And what is this one? Displacement in 1 second, 2 seconds, 3 seconds. This is basically the complete displacement. And this much is displacement in 1 second, 2 second, second, third second, fourth second, fifth second, and so on. Guys, see. Can you tell me what is the displacement in first second? That is x. Can you tell me what is the displacement in second? That is this much displacement. You say, sir, total is 4x minus this x. 4x minus x, you will be getting this as 3x. Similarly, displacement in this third second. Total is 9x minus 4x, this will be 5x. So I can directly write over here, if this is x, we say this is 3x. We say this is 5x. We say this is 7x. And we say this is 9x and so on. So we say, guys, displacement, we say, I'll write over here, displacement in first second. Then we say is to displacement in second. Then we say is to displacement in third second. Is to, we say displacement in fourth second. Okay. Then we say is to displacement in fifth second. It will be, that is x is to 3x is to 5x is to 7x is to, we say, sir, 9x. So this is the ratio that we have exactly over here. X is to 3x is to 5x is to 7x is to 9x. I can write it 1 is to 3 is to 5 is to 7 is to 9. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. And most importantly, guys, hit the like button, everybody of you. If you have not liked this session yet. Now, let's take a look exactly at this particular question. This was the question which was asked in NEET 2017. What will be the ratio of distances moved by a freely falling body from rest in fourth and fifth second? Guys, see, if there is an object which is freely falling over here, always remember, whenever we release an object, its initial velocity is 0 and its acceleration is constant. Always remember, I'll teach you this also. But as of now, you remember, it's, we say, initial velocity is 0, acceleration is constant. So means the condition is will satisfy. This condition will only satisfy if acceleration in this case is constant and initial velocity is 0. Now ratio, we say in the first second is x, ratio in the second is 3x, ratio in the third second is 5x, 7x, 9x and so on. Okay. Now guys, tell me in the chats over here, what is the answer of this particular question? We say, guys, in fourth and fifth second it is asking. We say, sir, displacement in first second is to displacement in second is to, we say displacement in third second is to displacement in fourth second is to displacement in fifth second. So it will be simply that is x is to 3x is to 5x is to 7x, okay, and is to 9x. Now in fourth and fifth they are asking. In fourth second it has covered 7x, in fifth second it has covered 9x. So we say s fourth upon s fifth will be 7x divided by 9x, x and x will cancel, so it is 7 by 9. It is 7 by 9. It is 7 by 9. Okay, that is 7 by 9. Which option is correct? This option is correct. Next we have got in the same category, a body starts from rest. What is the ratio of distance traveled by the body during fourth and third second? During fourth and third second. Sir, in the fourth second it will cover 7x. In the third second it will cover, we say 5x. So we say s fourth divided by s third will be 7x divided by 5x. Okay, this and this will cancel, so it will be 7 by 5. Option A. Option A. Option A. Okay. Next we have got this question. Next we have got this question. Next we have got this question. A stone falls freely under gravity. It covers the distance h1, h2 and h3 in the first 5 seconds, next 5 seconds and next 5 seconds. We have released a stone over here. Okay. So let's suppose the stone falls something like this. Stone falls something like this. Stone falls something like this. Okay. My dear friends, let's suppose in the first 5 seconds, listen to me very carefully. In the first 5 seconds, it has reached over here. And in the next 5 seconds, we say, sir, that is means this is 10 seconds over here. It has reached over here. And in the next 5 seconds means 15 seconds, it has reached over here. And it says that in the first 5 seconds, the height is h1. Then it is covered h2 and then it has covered, we say h3. Okay, initial velocity is 0 over here. Now in this particular case, I am showing, if it is not visible, I am showing over here. A stone falls, we say in the first 5 seconds it has covered h1 height. In the second 5 seconds means at the 10th second it has covered h2. In the 15th second it has covered h3. Now guys, see. In this particular case, you guys are supposed to tell me what is the ratio, the relation between h1, h2 and h3. Guys, see, it is exactly like the case ratio of displacement in first second. Here, instead of first second, you have given first 5 seconds. I'll write it something like this. Ratio of displacement in first second is to ratio of displacement in second is to ratio of displacement in third second. It is x is to 3x is to, we say, sir, 5x. Now, instead of first second, here you have given first 5 seconds. We can also write it something like this. First 5 seconds is to, we say displacement in second 5 seconds. Sir, what does that mean? That means first 5 seconds means this interval. Second 5 seconds means this interval. Third 5 seconds means this interval. Okay. So we say I say displacement in, we say third 5 second. So it is given as, we say h1, we say is to, we say this is given as, I'll write over here, this is x is to 3x is to 5x, so on. But this is given as h1 is to, we say h2 is to, we say, sir, h3. The ratio is given something like this. In first 5 seconds, it covers h1. Either you say in first second or first 5 seconds, even first 10 seconds, then the next interval should be also for first next 10 seconds, next 10 seconds. So it is given as we say x is to 3x is to 5x. Now here, can I say in this particular case, h1 divided by h2 will be simply, that is x by 3x. This and this will cancel. Take it over there. So h1 will come out to be h2 divided by 3. Call this as equation first. Call this as equation first. Now, from this ratio also, can I say h1 by h3? What is the value of h1 by h3? h1 divided by h3 will be simply that is x by 5x, x by 5x. This and this will cancel. Take it over there. h1 will come out to be h3 by 5. h3 by 5. Now this is the second equation. Guys, see. First equation, h1 is equal to h2 by 3. In the second equation, h1 is equal to h3 by 5. Now, don't you think we can compare this? So I can write from first and second equation, h1 is equal to h2 by 3, which is equal to h3 by 5. Which is equal to h3 by 5. So now let me show you which option is correct over here. h1 is equal to h2 by 3 is equal to h3 by 5. That is option 3. That is option 2. Okay. Now this is the question which I'll give you as homework. Guys, I would want you guys to put up the answer of this particular question in the chats. I would want all of you to put the answer of this particular question in the chats. And if you have not liked the session yet, I would want you guys to like the session as soon as possible, because liking this session is extremely mandatory, guys. Now.
Okay, guys, now let's talk about the motion under gravity. Understand one thing very carefully. See, what is this motion under gravity all about? Let's suppose I have an object that I am placing exactly over here. This is a ball, this is an object, okay? And I am releasing this object from certain height. I am releasing this object from certain height. So basically, I am releasing this object from certain height. Okay, yes. Now what is going to happen? We say, sir, it will come down and it will fall on the surface. It will fall on the surface. Guys, see, let's suppose mass of this is m. Mass of this is m. Could you please tell me, sir, if this is the object, I'm releasing this object, it will fall on the surface of the earth. So this motion in which an object is released and it falls under gravity, gravity is pulling it. So we say this is what we call motion under gravity. Or you can also call it the vertical motion, in which an object falls under the gravity because of the gravity. Now see, we say, what is the force which is acting on this object in the downward direction? That is mg. Okay. If mg is the force which is acting on this in the downward direction, guys, tell me. We say, sir, acceleration of the block. You say acceleration of the block, acceleration is equal to F divided by m, because we say force is equal to mass into acceleration. So acceleration will be force upon mass. Now tell me one thing. Sir, what is the force acting on this one? Force is acting over here, that is m into g. Okay. And what is the mass of this block? That is m. This and this will cancel. So acceleration will come out to be equal to g. So this is what we call the acceleration due to gravity. So acceleration of this block, which is because of the gravitational force. Okay. What is this motion called? This motion is motion under gravity. When something falls because of the gravity, that's what we call motion under gravity. Okay. And we say this is g is equal to 9.8 meter per second square. Sometimes we take it approximately equal to 10 meter per second square. Okay. Yes. Now, my dear friends, so from now onwards, we'll remember that if an object is released from certain height, it falls with what acceleration? That is acceleration due to gravity. So mention it. This is what we call the acceleration due to gravity. This is what we call acceleration due to gravity. Okay. Now guys, in this acceleration due to, in this motion under gravity, what we are supposed to study is that is time of flight. We say it is the time taken. It is the time taken by an object. It is the time taken by an object. It is the time taken by an object from some height to the surface of Earth. Like, my dear friends, I'm saying you have this object over here which you are releasing from certain height, okay? And we say this object is going to fall on the Earth's surface. This is the Earth's surface, okay? Now, my dear friends, let's suppose I'm saying this is at the height h. This object is at height h. You are supposed to tell me, if we release it, how much time it is going to take till the surface of Earth. And whenever we release something, we consider its initial velocity as 0. If you are releasing it, you are not giving it any initial velocity. So initial velocity is 0. But if you throw it, in that case, initial velocity will be something. And what is the acceleration of this ball? That will be g. Acceleration is g and initial velocity is 0. Now, my dear friends, let me just tell you, when it comes to the when it comes to basically the time of flight in this particular case, we simply say use s is equal to ut plus 1 by 2 at square. Okay. Guys, s means how much height, how much displacement it has covered. So that is, we say, sir, h is equal. Initial velocity over here, initial velocity in this case is 0. So this term will become 0. So 1 by 2 at square. And instead of acceleration, I would use, sir, that is g, and we say t square. Now take this 2 over here. So this will be 2h divided by, we say, g will be equal to, sir, t. And this t will come out to be under root of 2h divided by g. So this is the time that an object is going to take from certain height to the surface of Earth. From certain height to the surface of Earth. That is under root of 2h divided by g. Under root of 2h divided by g. Okay. Now, my dear friends, another concept over here that we define is velocity of hit. What is this velocity of hit? We say it is the velocity. It is the velocity with which an object hits the ground. It is that velocity with which an object hits the ground. That is the velocity we are going to discuss. Now see, when it comes to this velocity, let's suppose I am saying this is the object which is released from certain height. This is the object which is released from certain height. And it is going to hit the surface of Earth. So we know, sir, it will fall, it will fall, it will fall, it will fall. So here, what is the velocity with which it is going to hit the surface of Earth? Now, my dear friends, in this particular case, what I'll say is that, let's suppose this height over here is h. It is falling from the height h. And we know that initial velocity in this case is 0. Acceleration we take as g. Initial velocity is 0. Acceleration we take as g. Now we say use v square minus u square is equal to 2as. V square minus u square is equal to 2as. Now guys, here in this particular case, initial velocity is 0. So this will be v square is equal to 2. Acceleration, how much over here? That is g. S is the displacement covered. That will be, sir, h. So this v will come out to be under root of 2g into h. So this is going to be the velocity with which an object will touch the ground, with which an object will hit the ground. Okay. Now, guys, there are some graphs which are important when it comes to the motion under gravity. The first one is over here, acceleration time graph. See, guys, when it comes to the motion under gravity, don't we say that acceleration is equal to g, and which is constant, okay? And value of this acceleration is 9.8 meter per second square. So acceleration is g, acceleration is constant, and 9.8 meter per second square. So how is going to be the acceleration time graph? Sir, it is constant. It is going to be the constant. See, I have made the constant. Now, guys, take a look over here. We will make the velocity versus time graph. Here on this axis, velocity, here on this axis, time. See, I'll use the formula. V is equal to U plus A into T. Okay. Guys, tell me one thing. If you drop an object, if you release an object, you have to tell me, sir, V is equal to final velocity, velocity after some time. Like here, initial velocity is 0. After some time, what is the velocity? That is V. Initial velocity, we know, sir, this will be 0. Okay. Plus acceleration, we say, sir, this is G, and we say this is T. Now tell me here, we say V is equal to G into T, and velocity is directly proportional to time. So graph is going to be the straight line. So velocity time graph is going to be the straight line. Now, guys, if we talk about the displacement time graph, use this equation. S is equal to ut plus 1 by 2 at square. Initial velocity is 0, guys. Okay. So S will be equal to 1 by 2 gt square. In this particular case, you can say S is proportional to t square because g is constant, 1 by 2 is constant. So graph is going to be something like this upward parabola. This is the graph of S is proportional to t square. So basically, these are the three graphs that we see in the motion under gravity, Okay, yes. Now guys, let me just tell you about the ground to ground case. What does ground to ground case actually mean? See, guys, let's suppose you are launching a projectile from the surface of Earth. This is the surface of Earth. Okay. This is the projectile which you are launching. This is the projectile which you are launching from this surface, okay? From this surface, okay? Now, my dear friends, in this particular case, this object will go up, okay? Yes. And then it will fall down. It will again fall down. It will reach the maximum height and it will fall down. Guys, if you throw an object in the upward direction, okay? So means it is launched from the ground. Then it goes up till the top. Then it falls back. We say it falls on the ground once again. That's why it is called the ground to ground case, in which an object is launched from the surface. It falls back onto the surface. That is ground to ground case. Okay. Guys. Here, let's suppose you are sending it with a velocity u. Or let's suppose you are giving it a 10 meter per second velocity. Okay. Guys, when it falls back onto the surface, okay, it will hit the ground with the same velocity but in opposite direction. So here it will be minus 10 meter per second. What does minus represent? Minus means over here, if you take upward velocity positive, downward is negative. Like, let's suppose here, while the body was going up, here velocity is, let's suppose, 5 meter per second. Okay. While coming down at the same point, velocity in opposite direction will be same. That is minus 5 meter per second. And when it comes to the topmost point, velocity is, we say, 0. Because then only the object will stop and it will start coming back and falling down, if the velocity at the topmost point is 0. Okay. This is called the ground to ground case, in which an object is released from the ground. It falls back onto the ground. Okay. Yes. Now, guys, I would request you to remember one thing over here. Whenever you see the case, either in projectile motion, either in, we say, this motion, always remember, take this acceleration as negative. Take acceleration as minus g. Why? Because we say acceleration is towards the ground, okay, towards the center, I would say. So acceleration is always downwards, so we will take always negative. Sir, I have seen some books taking positive. No problem in that also. We'll take this as sign convention. We'll take this as sign convention. Okay. Okay. Now, guys, we take always acceleration as negative. Always accelerate. And one more thing. If object is going up, take the displacement as positive. Okay. If object is falling down, take displacement as negative. Remember these two sign conventions, because we are going to use these sign conventions only to basically derive the things over here in this particular case. Okay. Now, guys, when it comes to the ground to ground case, the very first thing that we need to discuss over here is time of flight. Time of flight means how much time an object takes while going up. Let's suppose this is the surface. Okay. From the surface, you are launching an object. It is going up and then it falls back. How much time it is going to take in this particular journey? That is what we call the time of flight. How much time it is going to take in this particular journey? That's called the time of flight. See, guys, we say use S is equal to ut plus 1 by 2 at square. Use this equation. Guys, let's suppose you have launched an object. It goes up, then it falls back. How much will be the displacement? I guess displacement is 0. Because it is launched from the ground, it falls back onto the same ground. So I would say displacement is 0. Okay. And let's suppose initial velocity you are giving as u over here. Right now it is not 0. You are throwing it with some velocity. So it is u into, we say t. Then, guys, we say plus 1 by 2. Acceleration is how much? I told you acceleration take minus g always in any case. And we say, sir, this is time, that is t square. Sir, why cannot you take the acceleration over here minus g? Take, no problem. If you take acceleration over here minus g, h also you have to take minus. Why? Because ball is falling down. In that case, we take height as negative. So negative into negative will become positive. Once again, we'll get the same result. Okay. Now, guys, take a look over here. So in this particular case, this is minus 1 by 2 gt square. So this will be, guys, take this minus 1 by 2 gt square over here. It will become positive 1 by 2 gt square is equal to u into t from this side. This and this will cancel. Square and t will cancel. We are supposed to find the value of t. T will be equals to, this is 2u divided by g. 2u divided by g. This 2u will go over here divided by g. Now, guys. So the time of flight in this particular case is, if an object goes up, okay, let's suppose you have thrown an object, it will go up and then it will fall down. Guys, how much is the total time taken by the object? That is 2u by g. Basically, while going up, we said time t1 is equal to u by g. So how much time it is going to take while going up? U by g. While coming back or falling down, we say time t2 is going to be again u by g. Now, when it comes to the total time, that is t1 plus t2, that is 2u divided by g. Total time will be 2u by g. Okay. I hope this is clear. Now we have the maximum height. how much will be the height attained by an object? How much will be the height attained by an object? Like. Let's suppose I'm saying we are launching an object from the surface. This is the object which I am throwing from the surface. Okay. And this surface will go till height, let's suppose h. Okay. It will attain the maximum height. I'm saying, sir, you throw an object in the upward direction, what can be the maximum height it can achieve? And then I know it will fall down. Then I know it will fall down. Then I know it will fall down. Okay. It will fall back. Guys, see. We are supposed to find this maximum height. What is the velocity at the topmost point? That is 0. Initial velocity with which you are launching it, that is u. Now tell me, guys, in order to find the maximum height, we say use v square minus u square is equal to 2as. Guys, tell me one thing. If you are using the equation from bottom to top, tell me, final velocity in this case is 0, because at topmost point velocity is 0. Initial velocity is u, that is u square, is equal to, I told you acceleration, take this acceleration always as minus g, okay? And s is the displacement covered from the bottom till the top. How much that will be? That will be plus h, because while the object goes up, we take the height as plus h. So this will be plus h. Now this negative will cancel. I can say height will be, in this particular case, that is u square divided by 2g. This is the maximum height attained by an object if you launch it from the ground with a velocity u. Okay, that is u square by 2g. When it comes to the time of flight, that is 2u divided by g. Now guys, there is an important concept over here that we need to discuss. What is that important concept? Take a look over here. Let's suppose if you are releasing an object from certain height, we know that release means initial velocity is 0. And in this particular case, acceleration is g, and which is constant. In this case, acceleration will be g, and this g will be constant. Whenever acceleration is constant, initial velocity is 0. I have told you, guys, let's suppose object after 1 second is over here, okay? And I say object after 2 seconds is here. Object 3 will reach after 3 seconds here, 4 seconds, 5 seconds. How many times I told you that? Sir, displacement covered in 1 second. Understand this very carefully. Sir, this will be x. We consider this displacement as x. Don't say, I'll erase this 5 over here. Okay, I'll erase this 5 over here as of now. This 20 as of now. Guys, in this particular case, I am saying displacement in 1 second, it will be x. Let's suppose if it is x. What will be the displacement in 2 seconds? Sir, we say it is 4x. Displacement in 3 seconds, we say, sir, it is 9x. Then displacement is 4 in 4 seconds, that is 16x. Then we say 25x. Okay. And similarly, if you remember, I recently told you, sir, is that ratio applied over here also? Yes, it is applied here also. We say displacement in first second, displacement in second, displacement in third second, displacement in fourth second, displacement in fifth second. So I would say this displacement over here will be x, this will be x, this displacement will be x, this will be 3x, this will be 5x, this will be 7x, this will be 9x. Same thing I am supposed to use over here also. Now, if you want to find out the exact value, you can use the equation also. Then it will come out to be g by 2. If you take g as 10, the first one will come out to be 5 meters.
If this is 5, like s is equal to ut plus 1 by 2 at square, find this distance. Initial velocity is 0, so 1 by 2. Acceleration into t square. T is 1, time is 1 square. So it will come out to be a is g, so g by 2. If you take g as 10, so this will be 5. If this is 5, how much will be this? 5 into 4 is 20. How much will be this? 9 into 5 is 45. Similarly, you can find this one. Okay. I hope this is crystal and clear. On the same concept, I am basically asking you the question. A water droplet is falling in a regular intervals. When the first droplet is released, the fourth droplet is about, when the first droplet reaches the ground, the fourth is about. Okay. Guys, let's suppose we have a tap over here. This is a tap. Okay. This tap is sending water droplets are coming out of this tap. Okay. Now, guys, this is the first droplet. It says that when first droplet touches the ground, fourth droplet is about to come. So means third would be around over here. Second would be around over here. See, water droplets coming out of the tap. It says that when first drop reached the ground, then fourth drop is about to release. The fourth drop is about to release. Fourth drop will come out. Okay. Now, guys, we are supposed to find the distance between second and third droplet. It is extremely easy. Guys, tell me one thing. In this particular case, and let's suppose I'll give you this as 9 meters. This height I'm giving you as 9 meters. See, guys, can I say in this particular case, initial velocity is 0 and acceleration is g, constant. We can use the ratio. Guys, how much will be the distance covered in first second? Sir, this will be x. How much will be this distance? This will be 3x. How much will be this distance? This will be 5x. Easy. Or displacement in 1 second, x. Displacement in 2 seconds, 4x. Displacements in, we say, 3 seconds, that will be 9x. Now tell me, this is x, 3x, 5x. So total is how much? Can I say in this particular case here, x plus 3x plus 5x, it will be equals to 9 meters. Yes. Now tell me, how much is this? This will be 9x is equal to 9. So x will come out to be 1 meter. So if x is 1 meter, you have to tell me the distance between second and third droplet. This is second droplet, this is third droplet. You have to tell me distance between second and third. I guess that is mentioned over here, guys, 3x. So you can say distance between second and third droplet. What will you say? That is 3x, so that is 3 meters because x is 1 meter. Simple, it becomes very easy with this logic. Now, on the same concept, I have made another problem over here, another question. Water drops falling from a tap of 5 meter, okay, on a regular floor 5 meter below at a regular intervals of time. This I am giving you as homework. You would be able to solve this very easily. Okay, same concept is exactly similar like previous question. Great. Now, guys, let's move on to the position time graph. Let's move on to the position time graph. We'll move on to the graphs. See, guys, what does position time graph actually mean? See, let's suppose I have a car over here. Okay. This car started moving from this point. After t is equal to 1 seconds, the car reached over here. After t is equal to 1 seconds, car is at x is equal to 1 meters. This is the position of the car. After t is equal to 2 seconds, car is at x is equal to 2 meters. After t is equal to 3 seconds, car is at x is equal to 3. Similarly, I can say at t is equal to 4 seconds, car is at x is equal to 4 meters.
I'm asking you the simple question. I say plot this situation graphically. I want you guys to plot this situation graphically over here. Plot its position time graph. See guys, how we are supposed to plot this situation graphically. Okay, how we are supposed to plot this situation graphically. Take a look. I'll make over here, this is X and this is T. This is position versus time graph. Guys, see, when time is 1, displacement position is 1. When time is 2, position is 2. So means first point will be around over here. When time is 1, position is 1. So it comes out to be basically the straight line. Okay? Because when time is 1, position is 1. Time is 2, position is 2. So that's why I make its position time graph something like this. So this was the real life situation. Then we plotted the same situation graphically and we plotted its position time graph. That's why this is the meaning definition of position time graph. Now guys, take a look what we are going to study over here. See, in case of the position time graph, listen to me very carefully. Let's suppose this is theta over here. If somebody asks you, what is the value of slope in this particular case? You say, sir, this is X and this is T. Clearly, you can say in this particular case, slope will be tan theta. And tan theta is perpendicular by base. Perpendicular is X, base is T. So that is, you can say dx divided by dt or delta X divided by delta T. Okay, yes. Now guys, we say call this as equation first. We say as we know, velocity is equal to dx divided by dt. So call this as equation second. So can I say from equation first and equation second, we say slope is equal to velocity in case of xt graph. So from now onwards, my dear friends, if you are given the position time graph and if they ask you to find the velocity, what will you find? You will find slope. What will you find? You will find slope. So when you basically find the slope, just a second, yeah. When you basically find the slope, means you are finding what? You are finding the velocity, okay? Slope of position time graph gives the velocity, okay? Now guys, take a look exactly over here. Find the ratio of displacement of the particle of A and B. Guys, see. In this particular case, you have to tell me which of the two particles have got more displacement. Also compare the velocity of the two particles. Guys, see, when it comes to the velocity in case of xt graph, you say slope. Sir, this is theta 1 and this is theta 2. Clearly, you can say, sir, this A line has got greater slope than B line. I can say, sure, theta 1 is greater than theta 2. What does that mean? That means slope of first is greater than, this is A, slope of A is greater than slope of B. I can clearly say in that particular case, slope of A is greater than slope of B. Okay. Now tell me one thing. If slope of A is greater than slope of B, we recently saw that slope in case of position time graph gives velocity. So I can say velocity of A is greater than velocity of B. Done. Next, guys, when it comes to displacement, this is the final position of this. Final position will be, let's suppose, 10 meters. Similarly, car B has the same final position. Initial position same, final position same. So we can say displacement of A is equal to displacement of B. Both have got the same displacement. Now this car moves faster, this car moves slowly. That's why we say displacement is same and velocity is different. Tell me, which of the following graphs is wrong or incorrect in among these? This is distance time graph. Guys, this is not displacement or position time graph. This is distance time graph. And we have always seen when it comes to distance, distance is always positive. We consider distance always positive. Now tell me one thing. From the upper side, distance is positive, okay? From the lower side, you consider distance as negative. So we say distance can never be negative. So A is wrong. So this is wrong. Why? Mention it. Sir, distance can never be negative. Sir, B. Is B correct or incorrect? Guys, see. Initially, it says that distance is increasing, okay? When you go up, distance is increasing. Then it says distance is decreasing. Distance can never decrease. So B is also wrong. Why? Distance can never decrease. Please do write it down on your own. Why? Here also this is incorrect. Okay. Here also this is incorrect. Why is this incorrect? Because here also distance is decreasing. In this case, why is this incorrect? See, we say at one time, guys, look at this. At, let's suppose t is equal to 10 seconds. Distance of this is this, let's suppose 2 meters. But you say 10 seconds, there is one more distance. Is it possible for an object to have the two distances at one time? No. So that's why we say this is also wrong. Logic of this is distance can never be negative. Logic of this is distance cannot decrease. Logic of this is distance cannot decrease. Logic of this is, the reason of this is, at one time there cannot be two distances for a particular particle. Next, let's talk about position time graph. From position we get displacement. Guys, tell me, can the position be negative? Yes. If this is origin, we say, sir, x is equal to plus 10. So this displacement or position is plus 10. Here, position will be x is equal to minus 10 from left side of the origin. So A is correct. We say this is correct. Okay. Sir, what about B? Is B correct or incorrect? Guys, see. In this case, a particle has got two positions at a particular time. This is the position of the particle. This is the position of the particle. Okay, so it is incorrect. Means it says that particle is present at the two different locations at one particular time, which is wrong. Here, is this correct or incorrect? This is correct. Why? Because position displacement can decrease. Okay, if you are going away from your initial point, then you come back towards your initial point. We say position displacement can decrease. Correct. And we consider here this is also incorrect because this sharp turns are not allowed. It has to be something, it should have been something like this. Then it was correct. Okay, so we consider this as incorrect. Why? Because sharp turn is not allowed. Okay, this is the sharp turn. Otherwise, it is correct. Next, the displacement time graph of two particles A and B are as follows. Find the ratio of VA by VB. Guys, see. We are supposed to find the velocity of A divided by velocity of B. Guys, this angle is given as 45, okay? And this angle is given as 15. How much will be this angle? 45 minus 15, so this angle would be 30. Done. Now, this angle is given as 45. This is 15. So how much will be this total angle? This will be 60. So B line is making 60 degrees. A line is making 30 degrees. Now tell me, if you want to find the velocity of A divided by velocity of B, you'll simply find slope of A divided by slope of B. Because from position time graph, if you want to find the velocity, you'll find slope. Now, what is slope? Slope is tan theta. So A is making 30 degrees. So tan of 30 divided by tan of 60. Okay. Put the values, it will come out to be 1 by 3. Please do check it from your end. Okay. Tan 30, tan 60. Next, which of the graph represent the uniform motion? Uniform motion means constant velocity. Whenever we say uniform motion, it means constant velocity. Okay. Okay. When we talk about the uniform motion, it is what we call constant velocity. Now tell me, guys, this is displacement time graph. In this particular case, we can say, sir, slope is constant. Why? Because it's a straight line. In case of a straight line, slope is constant. If slope is constant, means velocity is constant. So means this is uniform motion. Here, guys, this is a curve. We say here at topmost point, slope is 0. Slope is 0. Okay, here slope is something positive. Slope is negative. So in this case, slope is variable. So velocity is not constant. Because whenever you have the curve, in that case, we say slope is not constant, slope is variable in case of straight line. And here we say slope is 0. Slope is 0. Why? Because this line is parallel to x-axis. So means velocity is 0, body at rest. So this body is at rest. Okay. In this particular case, you can say, sir, velocity over here is constant and here velocity is positive. Okay. Then slope of this graph, we say slope of this graph is negative. Slope of this graph is positive. Why? Theta is less than 90. I have told you in the basic mathematics, if the angle between the line and x-axis, this theta, is less than 90, then slope is positive. Then slope is positive. If this theta is greater than 90 and this theta is less than 180, then slope is negative. So velocity is negative. So velocity should remain constant direction wise also. Positive velocity means body is moving towards right. Negative velocity means body is moving towards left. So here body is not in the uniform motion. Okay, because direction of velocity is changing. Velocity is a vector quantity. If you want the uniform motion, then direction also should be uniform, constant. Okay, this one. Figure shows the position of a particle moving along x-axis as a function of time. Okay. Which of the following is correct? Guys, see. If you take a look over here, you draw a tangent. You can say this tangent is parallel to x-axis. Slope at this point will be 0. Slope at this point is also 0. Okay. Slope at this point is also 0. Slope at this point is also 0. Because I have told you, if there is a curve, if you want to find the slope at a point, draw a tangent at that point. If this tangent is parallel to x-axis, if theta is 0, means slope is 0. And if slope is 0 in case of xt graph, means velocity is 0. So here also velocity is 0. M is 0. Here also we can say M is 0. Now tell me, if slope is 0 in case of position time graph on these points, so can I say on these points velocity is 0? Because we say when it comes to the slope, if slope is 0, means velocity is 0. So option 1 says the particle has come to rest 6 times. Yes, this is correct. Because slope is 0 at 6 positions. 1, 2, 3, 4, 5, 6. So that's why we say particle at this. Okay. Is that clear? Is that clear? Is that clear? The maximum speed is at t is equal to 6 seconds. At t is equal to 6 seconds, speed is 0. Slope is 0 means speed is 0. So incorrect, incorrect, incorrect. Okay. The velocity remains positive from t is equal to 0 to t is equal to 6. Guys, see, here velocity is positive. When graph is coming down, velocity is negative. Positive, negative, positive. So this is wrong. Okay. Okay. Now, guys, let's move on to the next one. Even if you find the average velocity in the total time period, that will not come out to be negative. This is also wrong. Check it. Average velocity is total displacement upon total time taken. Okay, let's take a look. Nature of acceleration from the position time graph. Guys, see. Let's suppose I give you the graph something like this. This is xt graph. This is xt graph. Understand this very carefully. I'm saying in this xt graph, could you please tell me, sir, what is slope? You say, sir, slope in this case will be constant. Why? Because it's a straight line. If slope is constant, means velocity is constant. Yes. And if velocity is constant, means acceleration is 0. Because when velocity does not change, acceleration remains 0. So in this graph, straight line, acceleration is 0. But sir, could you please give us a graph in which acceleration is not 0? That is this one. See, guys, we say here at this particular point, we say slope is less because this theta is less. Here slope is more. Here slope is more. Okay. Okay. So we say in this case here, slope is increasing. Here slope is increasing. In this graph, you say slope is increasing. Yes, sir. Now, my dear friends, if the slope is increasing in the graph, I would want you to understand one thing. If the slope is increasing in this particular graph over here, the slope is increasing, I want you to understand, means velocity is increasing. Okay. Yes. If velocity is increasing, we say acceleration is there. Acceleration is not equal to 0. And more specifically, guys, in this case, we say equation of this graph is x is equal to t square. Whenever you say upward parabola, here if this is x, this is t, x is equal to t square. Now see, if we say x is equal to t square, if we find the velocity, velocity will be simply that is dx divided by dt, differentiation of this. So that will be 2t. Differentiation of t square will be 2t. Now, if you find acceleration, acceleration will be dv divided by dt. Differentiation of velocity, that will come out to be 2. And in this case, acceleration is there. And this acceleration is positive and it is constant. Okay, it is positive and constant. So this is that graph in which acceleration is present. Similarly, if you check over here, guys, see, initially slope is there. Initially slope is there. And at the topmost point, this is the graph something like this. We say slope here is 0. Okay. Can I say in this particular case here, slope is decreasing? Why? Because slope is becoming 0 at the topmost point. So means here velocity is decreasing. And you tell me, I have told you previously, decrease in velocity, slowing down means retardation. So I say this is the case of retardation. This is the case of retardation because it is slowing down. It is slowing down. Okay. Now, guys, answer this question. Answer this question. Find the average speed and average velocity in 4 seconds. So this is 4 over here. You have to tell me from 0 to 4 seconds how much will be the average speed and average velocity. Guys, see, when it comes to the average speed, sir, average speed will be total distance traveled upon total time taken. Now tell me, from 0 to 4, guys, see. So we say here distance is 10 meters, then constant. So from 0 to 3 seconds, how much is the distance traveled? 20 meters.
Then we say again distance, this is decreasing. So we say from here to here. Again, guys, it has come down. I say at t is equal to 0, how much is the distance? 0. At t is equal to 3 seconds, how much is the distance? 20. At t is equal to 4 seconds, again 0. It is like the car has started from here. It is taking t is equal to 3 seconds, okay? And it has covered a displacement distance of 20 meters. Then car comes back to its original position. So once again, I said distance is how much? That is 20 meters. So 20 plus 20 is how much? 40. So here it is 3 seconds, and then from here to here it is only 1 second. Distance covered is 20, 40. 20 plus 20 is 40. But displacement is 0. So this is 40 divided by 4. Total is time is 4 seconds. So that is 10 meter per second. Average speed. But when it comes to the average velocity, guys, how much is the total displacement traveled? Car comes here 20 meters, then comes back original position 0. So this will be total displacement traveled upon total time taken. So this will be 0 by 4, that is 0. Average velocity in this case is 0. Okay, this you can do from your end. This is your homework. This is a simple question. Next, you have this one. In which graph acceleration and velocity are in the opposite direction? You are supposed to tell me in which graph acceleration and velocity are in the opposite direction. Okay, let me just tell you in this particular case, guys. Okay. In which graph you have to tell me acceleration and velocity are in the opposite direction. Guys, see. Take a look exactly over here. How do we read this particular graph? See, when it comes to this point, and when it comes to the topmost point, tell me, can I say slope at the topmost point is 0 and slope at this point is positive? Okay, slope has some value. At topmost point it is 0. So in case of xt graph, we say slope is decreasing. Guys, see in this graph, we say slope is decreasing. If slope is decreasing means velocity is decreasing. Okay. Guys, if velocity is decreasing and you can clearly see in this particular case, velocity is decreasing, but velocity is decreasing and is positive because slope is positive at this point. Sir, how do you find slope is positive or negative? If this is the graph, if theta is less than 90, slope is positive. So velocity is positive and velocity is decreasing. If something decreases, if velocity is decreasing, guys, this is the car over here. Okay. This car is moving with 20 meters per second. After some time, velocity of the car becomes 0. It is decreasing. Can you tell me acceleration? Time is 1 second. Acceleration is change in velocity. Final minus initial. 0 minus 20 divided by time is 1. So this will come out to be minus 20. So in this case, if you find the acceleration will be negative. So here, velocity is positive, acceleration is negative. So here, velocity and acceleration are opposite. Let's take a look at this graph. Guys, see. In this case, if you take a look at slope, sir, slope here is 0. Slope is 0 and slope is not equal to 0 here. Slope is not equal. So slope is increasing. And we say here, when it comes to the slope is increasing. Okay. If slope is increasing, my dear friends, and one more thing, when it comes to the slope, it is positive. Okay. So means velocity is increasing and is positive. Well, how do you check? Draw a tangent. If that makes less than 90 degrees, slope is positive. That is positive. Okay. Now, guys, slope is positive means velocity is increasing. If velocity is increasing, velocity is positive, acceleration in this particular case is positive.
So acceleration and velocity are in the same direction. This is positive, so this is not the option. Let's check in this one. Let's check in this one. Guys, see, in this particular case, we say slope initially is 0. Here slope is 0. Here slope in this particular case is not equal to 0. Okay. Slope in this particular case is not equal to 0. Okay. See guys, here we say slope in this particular case. Understand this very carefully. Slope in this particular case. Tell me one thing, guys. See, slope in this particular case is what? It is decreasing or increasing? It is increasing. Okay. Slope in this particular case is increasing. If slope in this particular case is increasing, I would want you guys to understand one thing. Guys, see, slope in this case is increasing and this slope is negative. This slope is negative. Why? Because here slope is 0. At this point, slope is negative. Why? Because if you check with the x-axis, theta is greater than 90, less than 180. And magnitude of slope is, we say, increasing. Here there is no slope, flat surface. Here there is slope. In order to understand this question, I would recommend you guys to watch my basic mathematics one shot. Then this will be crystal and clear. Okay, and we say velocity in this case will be increasing, but in negative. Sir, what is this velocity increasing in negative? Means car is moving in the reverse direction and faster. It is increasing its speed in the opposite direction. It is like, guys, tell me, let's suppose car is moving in the backward direction. Here velocity of the car is minus 10 meter per second. If the car moves in the negative direction, we take its velocity as negative. Here, when the car reaches at this particular point, we say velocity of the car becomes minus 20. Okay. Tell me the acceleration. Acceleration is final velocity minus initial velocity. Minus 20 minus 10 divided by 1. So this will be plus 20 minus 10. So this will be minus 10 meter per second square. So in this particular case, guys, you can say what is the acceleration that is coming out to be negative. So you say here acceleration is negative. So velocity is also negative, acceleration is also negative. So this is not the option. Both are in the same direction. I hope this is crystal and clear. Then the last one, guys, tell me, in this particular case, here slope is something, here slope is 0. Okay, here slope is not equal to 0. Can I say here in this particular case, slope is decreasing? Slope in this particular case is decreasing. Means velocity is decreasing. And if you check, slope is negative. This is negative. Slope is negative. Velocity is negative. Okay. If velocity is negative and is decreasing, guys, see, here velocity is increasing and is negative. Here velocity is decreasing and is negative. Could you please tell me acceleration will be what? Acceleration will be positive. So this is the option. Here velocity is negative, acceleration is positive. This is one of the important questions, very important question. Okay, please repeat it. If you are not able to understand, then there is a fault in your graphs, in your slope. That is the only thing that I can recommend you. Watch my one shot of the slope. Even if you want to read, if you want to learn only the slope portion in that, so you can go and check that out. Now guys, let's move on to the velocity time graph, VT graph. Let's suppose there is a car over here which started moving. At t is equal to 1 second, its velocity is 1 meter per second. At t is equal to 2 seconds, its velocity is 2 meter per second. At t is equal to 3 seconds, its velocity is 3 meter per second. Now guys, I say plot its VT graph, velocity time graph. We have to plot this situation graphically. So I would say in this particular case, sir, its velocity time graph will be the straight line. This is V and this is T. It will be straight line. Okay, so the situation is plotted graphically, and graphically it is coming out to be equal to, it is coming out to be the straight line. Now guys, this is, let's suppose, theta. In this particular case, what I want you guys to understand is, that is, let's suppose if I ask you, what is the slope over here? You say, sir, slope is tan theta. Tan theta is perpendicular by base. That is delta V divided by delta T. Call this as equation first. Now, we say, as we know, guys, how many of you know that acceleration is delta V by delta T or dV by dt? It's one and the same thing. Now, this is first and this is second. First and second. So, can I say from first and second? From first and second equation. So, I would say from equation first and equation second. I can say slope is equal to acceleration in case of VT graph. So from now onwards, if they give you the velocity time graph and if they ask you to find the acceleration, what will you find out? You'll find out slope. Okay? Yes. One more important thing. Let's suppose I have a velocity time graph something like this. This is V and this is T. This is the velocity time. Guys, I am asking you to tell me area under this graph, area under this curve, this area. When it comes to the area under the curve, you say area is simply, guys, whenever you have to find the area under the curve, you'll say integration of V dt. Like if you have yx graph, y versus x graph, I say find this area, you say integration of y dx. Here, integration of v dt. Call this as equation first. Now we say, as we know, we have studied previously. Guys, we have studied previously. What we have studied? We have studied, sir, displacement is equal to integration of v dt. Okay? If velocity is given, you are supposed to find displacement, you do integration. Now from first and second, we say area is equal to displacement in case of VT graph. So from velocity time graph, if you want to find out the area, if you want to find out the displacement, you find out the area. That's it. So slope of velocity time graph gives acceleration. Area of velocity time graph gives you the displacement. Okay, cool. Before this, okay. Yes. Now see guys. Let's understand this. Analyze the following graph. This is the velocity time graph. Guys, from the upper side, you consider the positive area. From the lower side, you consider the negative area. If somebody asks you, find the displacement from this graph, how much? This is the velocity time graph of a car. You have to find out displacement. You say, sir, displacement will be the area. Now, guys, displacement is positive also, negative also. So you will say A1 minus, you say A2. Lower area will be taking negative. Keep that thing in your mind. But if they ask you to find the distance in this graph, then distance in that case, you say A1 plus A2, because distance is always positive. This negative also will be taking positive. Keep that thing in your mind. Okay, yes. Now the first question we have, find the average acceleration from 0 to 5 seconds. Find the average acceleration from where to where. Okay, find the average acceleration from, I would say, 0 to 8 seconds. Okay, and acceleration at t is equal to 5 seconds. Guys, see, whenever they give you the velocity time graph, they ask you to find the acceleration, you'll find slope. Okay. Now, guys, tell me one thing, or directly you say, sir, when it comes to the acceleration means delta v divided by delta t. Okay, that is final velocity minus initial velocity, 0 to 8 seconds. Guys, at t is equal to 0, could you please tell me what is the velocity? That is 20. So you say initial velocity is 20 minus sorry, final velocity we are supposed to write first. At t is equal to 8 seconds, what is the velocity? 20. That is also 20. Minus. At t is equal to 0 seconds, how much is the velocity, sir? That is also 20. So 20 minus 20. Delta V means final velocity minus initial velocity. Divided by time, time is 8 seconds. So acceleration comes out to be 0, average. Now, let's find the acceleration at t is equal to 5. Guys, see. How many times I told you slope in case of a straight line is same at every point? Yes, I say. Acceleration is equal to slope from 4 to 8 seconds. Find the slope from 4 to 8 seconds. See, guys. So you can clearly say, sir, this acceleration will be delta V by delta T. That is V final minus V initial divided by T final minus T initial. Final is 8 seconds. Initial is 4 seconds. Sir, final velocity at 8 seconds is 20. Minus. At t is equal to 4 seconds, velocity is 0. Minus. Final time. Sir, final time is 8, initial time is 4. So 8 minus 4 is 4. So this will be 20 by 4. That is 5 meter per second square. Now this is the acceleration from 4 to 8. Guys, since the slope is constant, this is constant. So means if this is the acceleration from 4 to 8, same will be the acceleration at 5, 6, 7 at every point because it is constant. I hope this is clear. Next, this you will do by your own, okay? Find the distance, displacement, find the average speed in the 6 seconds, okay? This I'll keep that as homework. It is a simple question, not difficult. When it comes to the distance, guys, let's keep this as A1, this is A2, this is A3. When it comes to the distance, you say simply, velocity time graph is given, they are asking find the distance, A1 plus A2 plus A3. A1 plus A2 plus A3. This area plus this, how to find this area? Length into breadth. So 2 into 10 is 20, 1 by 2 base into altitude, length into breadth. When it comes to displacement, displacement will be A1 plus A2 minus A3. This area you will be taking negative, minus. That's it. And find the average speed in the 6 seconds. Average speed is how much? Average speed. Sir, you say when it comes to the average speed, that is delta V. This is VT graph in this particular case. Okay. See, when it comes to the average speed, guys, how to find average speed? Total displacement traveled upon total time taken. Whatever you get the displacement over here, put it over here. Total time is, sir, 6 seconds. So divided by 6, you will get the answer. I have told you the approach. This is your homework. In which of the following graphs motion is uniform? Uniform motion means constant velocity. Okay. So guys, here velocity is increasing because this is velocity time graph. So velocity is not constant. Velocity is not constant. Why? Because this is velocity time graph. Here velocity is 20, 30, 40, 50. Here velocity is constant. Guys, it depends. It depends which graph you are talking about. It is VT graph. So velocity is constant in this particular case. See? If it was XT graph, guys, X versus T, then in that case, velocity was 0. In XT graph, constant means this. Okay. In which graph average velocity is maximum? Guys, see. When it comes to the average velocity, you say it is total displacement traveled upon total time taken. Now, from velocity time graph, how do you find the displacement? You find displacement, that is area. Area under VT graph. area under VT graph divided by time. Now, is this area more, or this area more? Sir, clearly this area is more. If this area is more, then displacement is more. So in this case, we say here area is more. So displacement is more. If displacement is more, so velocity is more. Simply option A. Done. Done. At which point velocity is maximum? If this is VT graph, at C point velocity is maximum. At which point acceleration is maximum? At point C, V is maximum. Maximum velocity, topmost point. At which point acceleration is maximum? Guys, acceleration means slope. Tell me, at C point there is less slope. At point B there is more slope. So if slope is more at point B, slope is large at point B. So acceleration is large at point B. Done. This I'll give you as homework. A ball is thrown vertically upwards, and in this particular case, this is the correct option. Do check it from your end. Why is this correct? Okay. A ball is thrown upwards. Ball goes up. What is the acceleration of the ball? That is constant. Check it from your end. I'll not show you this. Let's talk about acceleration time graph. See, guys. When it comes to the acceleration time graph, see, let's suppose a car started from here. At t is equal to 1 second, its acceleration is 1. T is equal to 2 seconds, its acceleration is 2. T is equal to 3 seconds, its acceleration is 3. Okay. Now, my dear friends, I am saying that plot its AT graph. Guys, see, when you plot its AT graph, so this will be acceleration versus time. That will be the straight line. So this situation is plotted graphically something like this. Now, like we discussed the slope in case of VT graph, in case of XT graph, we do not discuss the slope here. Slope of AT graph gives us the jerk. We do not discuss that. That is not in our syllabus. But what we discuss is area under AT graph. What we discuss is area under AT graph. See, guys, we say area under AT graph. Let's suppose this is acceleration, this is time. Okay, this is the curve over here. I am asking you to find this area. I am asking you to find this area. Guys, how do you find the area under the graph? Area is integration of whatever is on this axis A, whatever is on this axis, that is dt. Okay. Now, how many of you remember, as we know, guys, we say acceleration is equal to, or we say delta V is equal to integration of A dt. Whenever acceleration is given, you are supposed to find the change in velocity. Use this equation. Now tell me, from first and second, can I say area? This area is equal to delta V, which is change in velocity. Okay. So I can say, so area of AT graph gives change in velocity. It does not give velocity, it gives change in velocity. Area of AT graph gives change in velocity. Let's take a look exactly at this question. If initial velocity is given as minus 10 meter per second, then find the velocity at t is equal to 4. Guys, see. acceleration versus time graph is given. We are supposed to find the velocity. Guys, see? We say when it comes to the change in velocity, that is delta V, that is area of acceleration time graph. Now, could you please tell me how much is this area? So you say, sir, this change in velocity will be, area is 1 by 2 base into altitude. Base is 4, altitude is 10. 2 ones are 2 twos are 4. So change in velocity in this case is 20. Now guys, look at this over here. Look at this over here. Change in velocity means final velocity minus initial velocity is equal to 20. Final velocity we have to find out. V final minus initial velocity is how much? Sir, that is minus 10 is equal to 20. Minus into minus is plus. It will go over here again minus. So V final will be 20 minus 10. That will be 10 meter per second. So this is the velocity at t is equal to 4 seconds. Okay. Cool. Cool, 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 cool. Yes, 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 yes. Now, okay. Let's suppose we have a question on this graph conversion. Take a look. I will show you this graph conversion question. And we are done with this particular concept. We are done with this particular concept. Okay. Yes. Now guys, see. From the motion of a particle of acceleration, from the motion of a particle, acceleration time graph is given as in the figure. The velocity time curve, we are supposed to find its velocity time graph. Okay. We are supposed to find its velocity time graph. See guys. If we have to draw its VT graph, AT graph is given. This is acceleration time. Guys, tell me one thing. Tell me one thing. Don't you think that from 0 to 2 seconds, your acceleration is constant? Yes. And acceleration is positive? Yes. From 2 to 3 seconds, see, acceleration is again constant, but acceleration is negative. Now, VT graph should be in such a way so that acceleration should be positive. Guys, I'll make the graph something like this. Tell me, in case of velocity time graph, it is a straight line. So we say acceleration here is constant. Why? Because slope is constant. Slope of straight line is constant. So slope of VT graph is acceleration and this acceleration is positive. Why? Because slope is positive. Theta is less than 90. Then you have to make constant acceleration but negative. That would be this. So here acceleration is negative. Why? Because m means slope. Slope is negative. Why? Because this theta is greater than 90, less than 180. Okay. And acceleration is again constant. I hope this is clear. This one, acceleration time graph of a body is shown. Okay. Then find its corresponding velocity time graph. Guys, this is velocity and this is time. Tell me, can I say in this particular case here, I can say acceleration is positive, acceleration is constant. I can say on this one, acceleration is 0 because it's at origin. Here acceleration is again positive, acceleration is constant. Guys, look at the graph. Look at the graph. Initially, this will be the graph. Okay. Here acceleration is positive, acceleration is constant. Why? Because slope is positive, slope is constant. Then acceleration has to be 0. 0 acceleration, I can make it something like this. Because slope of this graph will be what? 0. So acceleration is 0 because slope of this is 0. Then we say acceleration is again positive. Again positive. Okay. Acceleration is again positive and acceleration is again constant. Because slope of this is 0, so this will be 0. Okay. Okay, this I have given you the homework. Okay. Let me show you this question here only. Previously, a body is projected vertically upwards from the surface of Earth. Its velocity time graph will be. Guys, if you throw the body in the vertical upward direction, always remember, we say whenever you throw the ball upward or it falls back, its acceleration is g, which is constant. Okay, done. Now, if the body goes up, we take its velocity as positive. When the body reaches the top, then it falls back. So while going up, velocity is positive. While coming down, velocity is negative. Now, initially, from the upper side, velocity is positive. From the lower side, velocity is negative. Positive, negative. Initially, velocity has some value. You are throwing it with a large velocity. So initially, velocity is positive. Then, as the ball goes up, 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 velocity decreases, 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 decreases. Okay, see, velocity is decreasing, 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 and we say at the topmost point, velocity becomes zero. See, at the topmost point, velocity is zero. And why did I make the straight line? The straight line in this particular case is because acceleration is constant. Slope of this should be constant. Here, slope should be constant. Means acceleration should be constant. Slope of VT graph gives acceleration. Then, when body falls down, its velocity becomes negative. It starts increasing. It starts increasing, increasing, increasing. Okay. So, this will be the graph. This will be the graph. I hope this is clear. I hope this is crystal and clear. Okay. This one. Okay. Now, guys, let's move on to, let's have a look. Okay. Let's have a look on one-dimensional motion. This I have already explained before, but let me just tell you, I just want to explain it once more. Okay. And then we have got the two-dimensional motion. Guys, understand very carefully. Let's suppose I have got a car over here, or let's suppose this is a block over here. Okay. And this car is moving in this x direction, something like this. The car is moving along x axis, something like this. So it is the motion in a straight line. It is not the motion in a curve. It is the motion in a straight line. Now, if I say, sir, let's suppose I make the coordinate system over here. This is y-axis and this is x-axis. And if I say this car is, let's suppose, moving something like this, we say here its value is, it has reached x is equal to 1. We say here it has reached x is equal to 2, and so on. But its y coordinate here is not changing. Y coordinate is not changing. It is only moving in one direction. That is which one? X direction over here. So we say this is what we call the one-dimensional motion, in which particle is moving only in one dimensions, either x or y or z. Okay, like let's suppose you have got a ball over here. Okay, you have an object. You are dropping this object from certain height. Guys, understand very carefully. You're dropping this object from certain height. It will fall. We say, sir, it will go down, 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 down. Okay. Sir, is it one-dimensional motion or two-dimensional motion? It is a one-dimensional motion. Why? Because here only y coordinate is changing. Its vertical distance is only changing. And here, we say x coordinate is changing. So this is also one-dimensional motion. Okay. I believe till over here, everything is crystalline clear. I believe till over here, everything is crystalline clear. Okay. And guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Okay. Now guys, see, let's talk about the two-dimensional motion. Sir, what is two-dimensional motion? We say when particle is changing two of its coordinates. We say here, only one coordinate is changing. One coordinate is changing. And when we talk about the two-dimensional motion, we say
here, two of the coordinates are changing. Two of the coordinates of a body are changing. Guys, understand very, very, very carefully. Let's suppose I'll give you the example over here. Let's suppose you are throwing an object something like this. We say, sir, it will follow this particular path over here. Now, guys, if you make the x-axis and y-axis over here, this is y-axis and this is x-axis. This is x and this is y. My dear friends, I would want you guys to understand one thing. Let's suppose when the particle was exactly over here, we say how much distance it has covered in x. You say, sir, this much of distance it has covered in x. Okay. This is the x distance at that point of time. And when the particle is here, how much distance or displacement it has covered in y? You say, sir, this much of distance it has covered in y. This much of distance, displacement it has covered in y. Okay. So, my dear friends, here, two of the coordinates are changing. Means particle is moving in x as well as y. So, we say two-dimensional motion. Okay, it's a curved linear motion. Body is moving in a curve over here. Okay. So, my dear friends, when the particle is moving along this path, means it's one-dimensional motion plus one-dimensional motion. Means two-dimensional motion is the combination of, we say x, motion in x direction plus motion in y direction. This is the motion in x, this is the motion in y. So, when you combine these two, we say it forms the two-dimensional motion. Okay. So, we say two-dimensional motion is the combination of x and y. Now, guys, let's move on to the projectile motion. Sir, is the projectile motion one-dimensional motion or two-dimensional motion? It's a two-dimensional motion, obviously. Okay. We say, let's suppose you have got a ball over here. Okay. You are throwing a ball from this point and it will follow this particular path. Now, guys, when the ball is here, how much distance it has covered in x? We say, sir, this much of distance it has covered in x. How much distance it has covered in y? This much of displacement it has covered in y. So, this is what we call the motion in 2D. Okay. We say it is a, I'll write over here. We say it is a two-dimensional motion. It is a two-dimensional motion. One more point I just want to add over here. Can I say it is the combination of horizontal. This is the horizontal motion. Ball is moving horizontally as well as it is moving vertically. So it is the combination of horizontal as well as vertical motion. So I'll write over here, it is the combination. It is the combination of horizontal and vertical motion. Okay. When you combine horizontal as well as vertical motion, it forms the projectile motion. Next, my dear friends. Okay, what are the different examples? You are throwing a stone in air. It will follow this parabolic path. That is a projectile motion. Okay. Even if you are, let's suppose, firing the gunshot, that is also the projectile motion. Now, guys, let's basically take a look at the first case of projectile motion that is in our syllabus, and that is what we call the ground-to-ground projectile. Okay. Is it clear till over here? I just need to know in the live chats if this is crystalline clear from every single, let me know in the chats, everybody out there. Is this crystalline clear, guys? Is this crystalline clear? Now see. Let me just tell you in this particular case, the first one that we need to talk about is, we say, Ground to ground case. What is ground to ground case? Let me give you the example over here. Let's suppose you are launching an object over here. You are launching an object over here. Okay. You are throwing an object something like this. You are throwing an object something like this. And it will follow this particular path over here. It will follow this particular path over here. Guys, understand very carefully. Understand very carefully. Understand very carefully. Here, you are throwing an object from the ground and it falls onto the ground. When you throw a projectile from the ground and it will again fall onto the ground, that is what we call the ground to ground case. Okay? We say here, projectile is launched from the ground, and it falls onto the ground. Okay, so when the projectile is launched from the ground and it falls onto the ground, that's what we call the ground to ground case. Now see, let's suppose, my dear friends, this is y direction, this is x direction. Let's suppose you are launching it with an initial velocity u. If you are throwing a projectile, obviously you will give some velocity to it. What is the velocity that you are giving? That is u. Sir, at what angle? Let's suppose this angle, at what angle you are throwing it? Let's suppose that is theta. Okay, you are throwing it with u at an angle of theta. Now guys, I would want you guys to do one thing over here. Sir, what is that? What is that? See. Can I just basically, I'll just do one thing. I'll just do one thing. What is that? I'll divide this projectile motion in horizontal as well as in vertical motion. Guys, see, if you are throwing a projectile something like this, we say it is covering the horizontal distance also, it is covering the vertical distance also, it is going up as well as it is going forward. So means here I say this is the combination of horizontal and vertical motion. This is the combination of horizontal and vertical motion. Now, I'll first write over here, this is horizontal motion. Okay. And I'll write over here, vertical motion. Guys, understand very carefully whatever I am trying to say in this particular case. Okay. Horizontal and vertical motion. Guys, see, if I say you have launched this projectile over here with a velocity u and angle is theta. Guys, understand very carefully. This is the initial velocity. Can I say, sir, this u will have two components. This will be first one and this is what we call the horizontal component. If there is a vector, okay, at an angle theta, we can resolve the vector in two components, x component, y component. Remember this. We can resolve this vector in two components, x component, and this over here will be, that is uy. Okay. Now guys, if this is theta, we say this ux will be, that is u cos of theta. Guys, if this is a, then I would have said a cos theta. And this would be, that is u sine of theta. U sine of theta. One component is what we call the cos component. Another component is what we call the sine component. This is cos and this is sine. And this is the original velocity u. This is the original velocity u. Now tell me one thing, my dear friends. If I have resolved this in, we say two parts over here. If I have resolved this in two parts over here, that is horizontal motion and vertical motion. Horizontal means this, vertical means this. What if I ask you to tell me what is the initial velocity in horizontal direction? Sir, initial velocity in horizontal direction is ux, that is u cos of theta. So I'll write over here, initial velocity in x direction is, that is u cos of theta. And if somebody asks you, what is the initial velocity in y direction? That is vertical direction. So that is uy and that is u sine of theta. U sine of theta and u cos of theta. Now guys, sir, could you please tell me the answer of one question? What is that? Is there any force acting in the x direction? Guys, if you throw a body something like this, it follows the parabolic path, this projectile path. Is there any force acting in the x direction? Let's suppose when the ball is over here, is there any force acting on this ball in the horizontal direction? We say no, no force. We ignore the we ignore this air friction and all, air resistance and all. So we say force in x direction is 0. Remember this directly. There is no force acting in the horizontal direction in case of projectile motion. And when it comes to the y direction, guys, everybody knows, sir, there is a force which is acting in the downward direction. That is mg, gravitational force. And I can write over here, force in y direction is what? That is m into g. M into g. Okay. Now, guys, tell me one thing. Can I say over here, if there is a force, I have taught you guys Newton's laws of motion. If there is a force, we say there will be acceleration. As you might have studied, we say acceleration is force upon mass. Acceleration is force upon mass. And if force in x direction is 0, okay, divided by m, so it will come out to be, we say, sir, 0. So I say acceleration in x direction will be 0. There is no acceleration in the x direction in case of the projectile motion. What about the acceleration in y? This is acceleration in x. Sir, acceleration in y will be force upon mass. What is the force in y direction? That is mass into acceleration due to gravity. So that is m into g divided by, I say m over here. This and this will cancel, so it will come out to be g. So I say acceleration in y direction is simply g. And remember one thing, we always take this as minus g. Okay, maybe some books will say, some teachers will say, take the upward as upward motion, in that case take as plus g, downward as minus g. I am telling you guys, take minus g always. Okay, take minus g always. We'll get the correct answer. These are the different sign conventions different books follow. So I follow take minus g always. Is that clear? Why should we take minus g? Because force mg is always downwards. If mg is force is downwards, we say acceleration is always downwards. So I say take it always negative. Now guys, one more thing I just want to add over here. What is that? Guys, see. So this is acceleration in x, this is acceleration in y. Let's suppose when the particle has reached over here, at this point of time it has got the velocity v. Initially, it was having the velocity u. At this point of time, this is not the topmost point, guys. At this point, we say, let's suppose its velocity is v. Guys, tell me one thing. Can I say this is v? This will be its horizontal component over here, that is vx. And this will be the vertical component, that is vy. Let's try to find out this vx and vy. Guys, we say final velocity in x direction. I would want you guys to use this equation. V is equal to u plus a into t. You might have studied this equation. If you have to find the final velocity, you can use u is equal to u plus at. Now, since you are finding the horizontal velocity in x direction, then you have to use this equation in x direction only. Guys, remember one thing. You should know in which direction you are using the equation of motion. Y or x. You have to clarify this. Now I say final velocity in x direction is equal. Initial velocity in x direction is u cos of theta. This is u cos of theta. Okay. Then plus acceleration in x direction is how much? That is 0 into, we say, sir, time. So we say Vx will be also, that is u cos of theta, and that is ux. Means, whatever is the initial velocity in x direction, same will be the final velocity in x direction. So can I say, sir, the horizontal velocity in the projectile motion always remains same. It is constant. It does not change. Horizontal velocity always remains constant because whatever is initially same is finally. Now let's talk about over here. Can I say in this particular case, velocity, final velocity in y direction is equal to, we say u plus a into t. Use this equation in y direction, So I can say over here, this is Vy is equal to, initial velocity in y direction is how much? That is u sine theta. U sine of theta. Now acceleration in y direction is how much? Acceleration in y direction is how much? That is minus g. So I'll write over here minus g into t. Guys, see, this gives us the indication that velocity in y direction decreases. Why, sir? Because as the body goes up, we say its vertical component keeps on decreasing. Sir, horizontal component will remain same. Yes, horizontal component remains same. But when it comes to the vertical component, it keeps on decreasing. Because it is u sine theta minus gt. U sine theta is the initial value. And if you subtract something from that, so it will decrease. Do you all agree? Please tell me in the chats, everybody out there. Please tell me in the chats, everybody out there. Is this clear? Guys, give me the signal in the chats. Everybody. And one more thing. Do like the session. I would want everybody of you to hit the like button. Everyone means everyone, okay? Marking the attendance is mandatory. Hit the like button as soon as possible. Now, next. Okay. Let's discuss one more term exactly over here. Let's discuss one more term exactly over here. Let's suppose, my dear friends, if somebody asks you, when the particle is here, how much displacement it has covered in the horizontal direction, you say, and I'll mention over here, we say displacement in x direction. Guys, in order to find the displacement in x direction, we use one formula. What is that? We say S is equal to ut plus 1 by 2 at square. Okay. Now, since we have to find how much horizontally it has displaced, so we'll use this equation in x direction. So ux ax. So displacement in x direction, let that be x, okay, or let that be sx, not a problem. And we can say initial velocity in x direction, that is u cos of theta, time is t plus 1 by 2. Acceleration in x direction is, we say, sir, 0 into t square. So this term will become 0. We say value of x will come out to be u cos of theta into t. So this is how do we find the displacement in x direction. And let's suppose if I ask you to tell me what is the displacement in y direction. What is the displacement in y direction? So in order to find the displacement in y direction, I'll use the equation S is equal to ut plus 1 by 2 at square. But remember, we'll have to use this equation in y direction over here. Why? Because we are finding the displacement in y direction. It is something like this. Let's suppose when the object is over here, how much is the displacement in x? Sir, this much. Okay, let's call this as x. How much is the displacement in y? Sir, this much. Let's call this as y. X and y we are finding. So this displacement in y is y. Initial velocity in y direction, sir, that is u sine of theta. That is u sine of theta. So this is u sine of theta into t. And then we say plus 1 by 2. Instead of acceleration in y direction, we say that is minus g and this is t square. So I'll write y is equal to u sine of theta minus 1 by 2 gt square. This is how you can find the displacement in x direction and displacement in y direction over here. I hope this is crystalline clear. Guys, give me the signal in the chats if everything is sorted, if everything is crystalline clear. If everything is crystalline clear. Okay. Now, let's move on to a topic that is what we call the time of flight. This is the first topic that we need to understand over here. That is time of flight. Let's suppose, my dear friends, you have an object. You are launching this object with a velocity u. Okay, at what angle? At an angle of theta. And we know that it will follow the projectile path. Okay, it will follow the projectile path. And we say this is y-axis and this is x-axis. What if I tell you to tell me how much is the time it has covered? How much is the time it has covered? Okay. What if I ask you to tell me how much time it has covered in this entire journey? So from initial point to final point, how much time it is taking in the journey, that is what we call the time of flight. So I say it is the time taken by a projectile It is the time taken by a projectile to cover the entire journey. I hope this color is visible. If not, please let me know in the chats. Okay. And how can we find this time of flight? Guys, we say use S is equal to ut plus 1 by 2 at square. Use this equation. Sir, in x or y, we say in y direction. In y direction. Okay. So use this equation in y direction and. From which point to which point? We say from initial to final point. Sir, why would I use this equation from initial to final? Because I have to find the time taken by the projectile from initial to final point. That's the reason I'm using it. Okay. Now guys, tell me one thing. Tell me one thing in this particular case. Now guys, see. If I use this equation in y direction, understand one thing very carefully. If particle is launched from this position and it has reached this position, could you please tell me in this particular case, how much is the displacement in y direction? Don't you think it is 0? Don't you think it is 0? Why? Because initially it was on the ground. Finally it is on the ground. So we said displacement in y is 0, but displacement in x is something. So if the particle was here, then I would have said yes, displacement in y direction is maximum. But finally also it is 0. So I said displacement in y direction finally is 0, is equal to. Okay, because what is displacement, guys? Displacement is, we say, difference between initial point and final point. Initially, along y-axis I am saying, it was on the ground. Finally also it is on the ground. Is equal to initial velocity, this is y. Initial velocity in y direction, that is u sine of theta. And then I say this is time is t. And then plus 1 by 2. Instead of acceleration, I write minus g into t square. I can say it something like this. Now take it from this side. So it will be minus u sine of theta into t is equal to, here this minus will come out. So minus 1 by 2 gt square. This square and t will cancel, negative and negative will cancel. Take it over here. So time will come out to be 2u sine theta. And you have got g divided over here. This will be the time of flight, that is 2u sine theta by g. So time of flight is 2u sine theta by g. This is the time of flight. This is the time of flight. And guys, is this u sine theta vertical velocity or horizontal velocity? Obviously vertical velocity. You can also write it something like this. This is 2uy divided by g. Either you say 2uy divided by g or you say 2u sine theta divided by g. It is one and the same thing. It is one and the same thing. Okay. I hope this is clear till over here. Next is what we call the maximum height. Next is what we call the maximum height. What is maximum height? Guys, see. Let's suppose you are launching a projectile over here. You are throwing a projectile, something like this. We say it will follow this path. How much high it can go? What can be the maximum possible height? That is what we call the maximum height. How high it can go? How high it can go, that is what we call the maximum height attained by the projectile. Now guys, tell me one thing. In order to find the maximum height, I would want you guys to use the equation once again in y direction. Why, sir? Because you are finding the displacement in y direction kind of. Okay. So guys, I say use v square minus u square is equal to 2as in y direction. In y direction. Now from which point to which point? We say from initial point to the topmost point. We say from initial to the topmost point. From initial to the topmost point. Guys, tell me one thing. If I use this equation in y direction, v square minus u square is equal to as. See. When it comes to the topmost point, I would want you guys to listen to me very, very, very carefully. At topmost point, we say this will have one velocity in x direction, another velocity in y direction. This is, we say, sir, Vx, and this is, we say, sir, Vy. Always remember that at the highest point, at the topmost point, this vertical velocity of a projectile is 0. This vertical velocity of a projectile is 0. Why, sir? Let me just tell you why. See. When this vertical velocity becomes 0, vertical velocity is that velocity which takes the projectile in the vertical direction, which takes it up. Horizontal velocity takes it forward. So if here velocity becomes 0, then only it will start falling back. If it is not 0, it will keep on going up. It will keep on going up. So if it becomes 0, then only it will start falling back. So at topmost point, we say, sir, Vy is 0. I'll write over here. At top, we say velocity in y direction is 0. And what about this velocity in x direction? That will be u cos of theta only. Because horizontal velocity in a projectile motion always remains constant. That remains constant. So I can say in this particular case, use it over here. Final velocity at topmost point, it is, sir, Vy square minus uy square is equal to ay into sy, displacement in y direction over here. So I can say this will become 0 minus initial velocity in y direction. I have told you what is the initial velocity in y direction. That is u sine theta. In case of a projectile motion, initial velocity in y direction is u sine theta. So it will be u square sine square of theta is equal to. Now 2ay. So I'll write over here 2. Acceleration in y direction, how much? sir, minus g. And displacement, sir, displacement in y direction. When it is at topmost point, how much displacement is in y direction? That is h. So I can say this is h. Okay, so you can write it u square sine square of theta is equal, take this minus out, minus 2gh. Minus minus will get cancelled. So it will become, h will come out to be, that is u square sine square of theta divided by 2g. This is the equation. This is the formula which you guys need to keep in your mind. And one more thing, guys, one more thing. What is u sine theta? U sine theta, guys, if this is u, we say this is u cos of theta. And which component is this? This is u sine of theta. And this is vertical component, that's uy. So I can say, you can also write it, that is, this is uy square divided by 2g. Because u sine theta is uy, initial velocity in y direction. Is this clear? Please tell me in the chats. Everybody out there, is this clear? Is this clear? Guys, hit the like button. Everybody out there. HSP sir in the chats. Huh? What's up, HSP sir? How is everything going? Now, let's move on to the next topic. The next topic we have over here, that is what we call the horizontal range. Guys, see, let's suppose in this particular case, you are throwing a projectile. Okay, let's suppose you are throwing a projectile over here. This is the projectile you are launching with a velocity, let's suppose u. Okay, and we know that, sir, it will go something like this. It will fall over here. We say how far it can go from initial point. How far it can go from initial point means this distance. This is what we call the horizontal range. Okay, how far it can go from the initial point in x direction. That's what we call the horizontal range. We say it is how far it can go in x direction. That is what we call the range of a projectile. That's what we call the range of a projectile. How far it can go in the x direction is what we call the range of a projectile. Guys, in this particular case, if you have to find the range of a projectile, I would want you guys to understand one thing. We say use S is equal to ut plus 1 by 2 at square. In we say x direction. We say in x direction. I would want you guys to use this in x direction. Why, sir? Because we have to find a range in x direction, horizontal range in x direction. Now, guys, tell me, I write over here Sx, Ux, Ax. So instead of this Sx, I'll write the range R is equal to initial velocity in x direction. So that is, we say, sir, u cos of theta. Okay. Into time is, we say, sir, t. Then we say plus 1 by 2. Acceleration in x direction is 0, time is t square. So this whole term will become 0. So this range will come out to be, that is u cos of theta into, we say, sir, t. Now the question is, what is this t? T is the time period. So what is the formula of time period? 2u sine theta by g. So I'll put it over here. We say we say time is equal to 2u sine of theta divided by g. Okay. And if we put the same formula in the above equation, so we say, so range will come out to be that is u cos of theta, instead of divided by g, instead of this, instead of t, I can write 2u sine of theta, 2u sine of theta divided by this g over here. Okay, this is g. 2u sine theta by g, 2u sine theta by g, and u cos theta is as it is. Now guys, tell me one thing in this particular case. Can I just say, sir, take this 2 out. I can write over here r is equal to, that is 2. And it will be u cos of theta, it will be u sine of theta, and we can say whole divided by g. Guys, what is this u cos theta? U cos theta is the initial velocity in x direction. What is u sine theta? U sine theta is the initial velocity in y direction. So I would want you guys to keep this also in your box, and one more equation. I can write this ranges. That is 2, and this will be, sir, ux, u sine theta will be uy, and divided by g. I would want you guys also to put up this also in the chat, in the box. Okay, because we will be basically using all of these formulas later. Okay, now. Let's take this equation and further simplify it. Let's call this as equation number 1. So I'll write over here as we say from equation 1. If we take this equation, what is that? That is r is equal to u sine theta, u cos theta divided by g. Guys, u into u I can write also over here, that is u square. So it will be u square. And then I can write twice sine theta cos theta divided by g. Guys, there is a trigonometric identity which I would want you guys to understand. What is that? We say sine of 2 theta is equal to, that is 2 sine of theta cos of theta. 2 sine of theta cos of theta is equal to sine of 2 theta. So I'll write over here, this range will come out to be u square. Instead of this, I'll write sine of 2 theta. So this is sine of 2 theta and divided by g. So put this also in your box, because this is also the important equation which will help us to solve the questions in the upcoming time. Tell me in the chats, is this crystal and clear to each and every single student? Everyone means everyone. Is this crystal and clear? I need the signal from every single student. Guys, smash the like button, mark the attendance if you have not liked the session yet. Okay. Now let's solve some questions. Okay. Cool. This was a question which was asked in IIT 2014, but this is an easy question. That's the reason I have put up over here. Okay. If object is projected with a velocity, this is the velocity, and the velocity is given in the vector form. This is the velocity in vector form over here. Alpha I cap plus beta j cap. Then find height, maximum height, time of flight, and range. These are the 3 things that you guys are supposed to find out over here. Guys, see, it says that we have launched an object. It says that we have launched an object, let's suppose, with a velocity u is equal to alpha I cap plus beta j cap. This is the velocity, initial velocity, with which we have launched the particle. Guys, the basic thing you might have studied, I have told you this in the vectors also. If I say there is a vector velocity v is equal to, we say 2I cap plus we say 3j cap. What is this I cap? We say this is that component of velocity which is along x direction. Why? Because I cap tells you the vector is along x axis. This is that component of velocity which is along y direction, because j cap tells you the vector is along y direction. So can I say in this particular case, we say Vx is 2, x direction velocity is 2, and we say Vy here is 3. Why? Because y direction velocity is 3. Same is the case over here. If u is equal to alpha I cap plus beta j cap, can I say over here, so I can say initial velocity in x direction is alpha. Okay. Can I say over here, sir, initial velocity in y direction is, we say, sir, beta. Okay. These are the two clues that we got over here. Now, if we have to find the height, or let's suppose time of flight, let's find out the formula of time of flight. What is the formula for time of flight? T is equal to 2u divided by g, 2uy divided by g. Now, I say, sir, time of flight is, that is 2uy divided by g. So can I say this is T is equal to 2? What is the value of uy? That is beta divided by g. Done. Done. Sir, what is the value of g? Always remember, we take value of g as 9.8 meter per second square, or we take it approximately 10 meter per second square. Okay. Okay. Now let's find out the maximum height. When it comes to the maximum height, guys, could you please tell me what can be the maximum height in this particular case? Sir, what is the formula for maximum height? Come over here. Maximum height is uy square divided by 2g. So same I'll use over here, that is uy square divided by 2g. So h is equal to, what is the value of uy? That is beta. So I'll write over here, that is beta square divided by 2g. Done. If you take g is equal to 10, so beta square by 20. And I would want you guys to put up this in the box. I would want you guys to put this up in a box over here. And next one we have got over here, that is range. When it comes to the range, we say range is 2ux uy divided by g. This is one formula of range that I recently calculated. 2ux uy divided by g. Now put up over here, what is the value of ux? Alpha and uy is beta. So it will be, that is 2 alpha beta divided by g. I hope this is clear. Next, guys, we have got this question. I hope this is visible to each and every single student. Yes. Now see, at topmost point of a trajectory, its velocity and acceleration are at an angle of, okay. We are supposed to find at the topmost point of the trajectory, how much angle velocity and acceleration is making. Okay, acceleration is making. You guys are supposed to tell me that. Now guys, see. Let's suppose if I launch a projectile over here. Understand this question. Let's suppose if I launch a projectile over here. This is the projectile that you have thrown. Let's suppose initial velocity u. I see. Can I say this is the topmost point? Yes. At topmost point, you have got two velocities. Sir, one is vertical velocity, that is Vy, and we know that is 0. And another one is, we say, sir, Vx, and that will be u cos of theta. Because velocity in x direction is we say constant. And when it comes to the acceleration, I told you acceleration is always downwards. Because gravitational force is downwards, that's why acceleration is downwards. Okay. Now, if you are finding, this is the velocity at final point. Sir, this is 0, we don't consider this. How much velocity this is making with the x-axis? Okay, its velocity and acceleration are at angle. Now, This is the velocity, this is the acceleration. How much is the angle between these two? That is 90 degrees. So which option is correct? Option 90 is correct. So because you don't consider this because this is 0. So at topmost point, it has got only one velocity. That is the horizontal velocity. So that is u cos theta forward, and acceleration due to gravity is downward. So it is 90 degrees. Next. A cricket ball of mass m. We have got a cricket ball of mass m is hit at an angle 45 degrees. Okay, with the horizontal. You have got a cricket ball over here. Okay, and you have thrown this cricket ball at an angle of we say 45 degree with the horizontal, with a velocity v. Its kinetic energy at topmost point is, we have to find the kinetic energy at the topmost point. This is a good question actually. Guys, see. Guys, see. Guys, see. When it comes to the kinetic energy as topmost point, we say as kinetic energy is equal to 1 by 2 mv square. Here, mass of this cricket ball is given as m. It is given as m. And initial velocity is given as v. It is not given as u. It is given as v. Okay. Now at topmost point, guys, what is the mass? Mass is m. Now we have to find the velocity at topmost point. See, at topmost point it will have vy, that is 0. And at topmost point it will have this x component, that is v cos of theta. Sir, why v cos of theta? Guys, see, if this is v, can I say horizontal component will be v cos of theta? Yes. And we know horizontal velocity in projectile motion remains constant. So here is v cos theta, here is v cos theta, even here also it will be v cos theta. So here, can I say, so I say at topmost point, I say when it comes to the topmost point, so can I write this kinetic energy will come out to be 1 by 2, mass is m, and what is the velocity at topmost point? That is v cos of theta, v cos of, and how much is theta? That is 45. Okay, at topmost point velocity is v cos of 45 only. Now tell me cos 45 and it is square. Why? Because it is v square. So I'll write kinetic energy simply, that is 1 by 2, and then I'll write m, and this is v square cos square of 45 degrees. So it will be 1 by 2 m v square cos square 45 is 1 by root 2 its whole square, because cos 45 is 1 by root 2, and if you do the square it will become 1 by 2. It will become something like, see, this is 1 by 2. 2 into 2 becomes 4. So it will be mv square divided by 4. So mv square by 4 is the correct answer. Is that clear? Is that clear? Guys, tell me in the chats, is this clear? And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Okay? Everyone means everyone. Hit the like button as soon as possible. Liking the session is extremely mandatory. Next, speed at any point. Guys, what is this? What is this? Let me make you understand this topic. What is this? See, let's suppose you are launching a projectile, something like this. Okay? Yes, sir. and initially you have launched it with a velocity u. You have launched it with a velocity u. And this angle over here is theta. Can I say this component of velocity will be u cos of theta, and this component of velocity will be u sine of theta? Okay, yes. Now guys, tell me one thing. Let's suppose when the particle reaches over here, this is not the topmost point, this is any general point I'm taking. We say at this particular point, let's suppose its velocity is v. Okay. Can I say this will be its horizontal component, this will be its vertical component? This is Vy and this is Vx. If you remember, we have already calculated the value of Vx and Vy. Value of Vx is u cos theta, value of Vy is u sin theta minus gt. I'll copy it as it is because I'll not explain once again. So we say, I'll write over here, we say as when it comes to the Vx, that will be u cos of theta, because velocity in x direction remains constant. And when it comes to Vy, that is u sine of theta, v cos theta, u sine of theta. Just a second. Okay. Now, guys, we got the value of Vx and we got the value of Vy. Now we have to find this velocity. And let's suppose this angle over here is alpha. Okay. Guys, see. Can I say in this particular case, sir, if we join this, if we find the resultant of Vx and Vy, that will be, sir, V. Or you can understand it something like this also. If you resolve V in two components, it will be Vx and Vy. Okay? Or you say, if you combine this and this, it will form V. So can I say, so I'll write, sir, this velocity V, it will be simply this velocity plus this velocity, that is Vx, and plus we say, sir, Vy. Now, Vx is in the x direction, so I'll write I cap. Vy is in the j direction, y direction, that's why I write over here j cap. Okay. Okay, yes. So this is basically the velocity over here. That is Vy into j cap. Now guys, tell me one thing. I would want you guys to understand one thing. Can I say in this particular case, we can write this velocity V is equal. What is the value of Vx? Sir, that is u cos of theta into I cap. And then we say plus value of Vy is, and this is u sin theta minus gt. Sorry, I forgot. U sin theta minus gt. So that is u sin of theta minus gt. Okay. And you write over here j cap, because this is the velocity, final velocity in y direction. It is not initial that we are talking about. So this is I cap, this is j cap. And this you can put up over here. This you can remember over here in this particular case. Now guys, if you have to find the magnitude of this velocity, sir, how do we find the magnitude of this velocity? That will be under root of this vector square plus this vector square. That is Vx square plus Vy square. So that is u cos of theta its whole square plus we say u sine of theta minus gt whole square. This will be the magnitude of the velocity in this particular case. This will be the magnitude of the velocity in this particular case. Okay. This is the velocity vector and this is the magnitude. And even if somebody asks you to find this alpha also, find alpha also. Guys, see, how do we find the alpha? I say we have got velocity V over here. This is V. And this velocity over here is, that is Vx, and this velocity over here is, that is Vy. This angle is alpha. Now, can I take this vector from here to here, sir? Is it possible? Yes, we can do it. It is what we call the parallel shifting of vectors. This is Vy. Now, tell me from this triangle, what is the value of tan alpha? Sir, tan alpha is Vy, that is perpendicular by base. So can I say here tan of alpha, that is perpendicular by base, that is Vy divided by, we say, Vx. And I can write it, that is tan of alpha is equal. What is the value of Vy? That is u sine theta minus gt. U sine of theta minus gt. And what is the value of Vx? That is u cos of theta. Okay. Okay. Is this clear? Is this clear? Let's take a look over here. Guys, answer this question which is mentioned on the screen. I would want you guys to tell me the answer of this particular question which is mentioned on the screen. Come on. An object is projected with a velocity of 30 I cap plus 40 j cap at t is equal to 0. Initial velocity is given as this. Then find the angle of projection. You are supposed to find theta, maximum height, time of flight, and range. These are the 4 things that you guys are supposed to find out in this particular question. So I would want you guys to do it as soon as possible before I do it actually. Okay, guys, see. Let me first draw the figure over here. There is an object which is launched something like this. There is an object which is launched something like this. With what velocity? We say we have launched it with a velocity v is equal to, that is 30 I cap plus 40 j cap. This angle is, we say, sir, theta. You have to first find the value of theta. Can I say in this particular case, sir, initial velocity, this will be the value of, sir, ux will be, sir, in this case 30. Why? Because whatever is mentioned with the I cap, so that is the velocity in x direction. And whatever is mentioned with the j cap, that is the velocity in y direction. Okay. Now, guys, tell me one thing. Tell me one thing in this particular case. So, if this is theta, we say, sir, this will be its initial, let's call this as u. This will be, sir, ux, and this component of velocity, will be uy. Now, can you tell me what is the value of tan theta? You say, sir, tan of theta will be simply, that is perpendicular by base, that is uy divided by ux. So, how much is that? Uy is, we say, sir, 30 divided by, we say, sir, 40 by 30. That is 40 divided by 30. This and this will cancel. So, value of tan theta comes out to be 4 by 3. Value of tan theta comes out to be 4 by 3. Guys, see, if we make a triangle over here, okay? And if I say this side is 4, this side is 3, and this side is 5, then we say this angle is 53 degrees. This is what we call the 53-degree triangle. And if I, let's suppose, say I have got another triangle over here, we say this side is 3, this side is 4, and this side is 5. And then we say this is 37-degree triangle. Now, can you tell me in this triangle, what is the value of tan 53, perpendicular by base? So, tan 53 is 4 by 3. So, I can say instead of 4 by 3, I can write tan of, so this is tan of theta is equal to tan of 53 degrees. So, here I can write theta is equal to 53 degrees. I hope this is clear till over here. Yes, a lot of people are giving me the answer 53. Now, what is the value of, we say maximum height. What is the value of maximum height in this particular case? We say as, when it comes to the maximum height, h max. What is, how to find h max? Uy square divided by 2g. So, I'll write that is uy square divided by 2g. What is the value of uy? That is 40. So, it will be 40 square. 40 square divided by 2 into, we say, sir, 10. G is 10. So 40 square is 1600 divided by 20. This and this will cancel. So this will cancel. So it will come out to be 80 meters. So how high it can go? Maximum height is 80 meters. What is the value of time period in this particular case? Let's find the value of time period. When it comes to the time period, I say time period is 2uy divided by g. So time period is 2. What is the value of uy? Uy is 40. So I'll write over here 40 divided by, we say, 10. This and this will cancel. So t will come out to be 8 seconds. Now, last one, that is what we call the range. So can I say range in this particular case is simply that is 2 times of ux uy divided by g, because we recently studied this formula. So can I say, sir, this will be 2 into, what is the value of ux, sir? That is 30. What is the value of uy? That is 40 divided by, we say, sir, 10. This and this will cancel. So 60 and this will come out to be 240 meters. So range is 240 meters. I hope this is crystal and clear to each and every single student. Is this clear? Is this clear, guys? Now see, two objects are thrown up at an angle of 45 degree and 60 degree respectively with the horizontal. If both attain the same vertical height, then the ratio of magnitude of velocities are. Guys, see, the question says that in this particular case, they have thrown the two objects. This is the first object and this is the second object. Okay. They have thrown the two objects. It is saying that let's suppose first one is attaining the height h1. Second one is attaining the height h2. They are saying that both are attaining the height h1 is equal to, we say, sir, h2. Two objects are thrown at an angle of 45 and 60. So we say this is at 45 degree, another one is at 60 degrees. Okay. So first one is attaining the height h1, second one is attaining the height h2, but both are attaining the same vertical height. Or let's suppose in some case this happens. The ratio of the velocities, let's suppose we have launched this with a velocity u1, we have launched this velocity u2. So we are supposed to find the value of u1 divided by u2 in this particular case. What is given in the question is that height is same for both. Height is same for both. Guys, see, can I just write over here, we say as. If maximum height of first one is equal to height of second one. How to find the height? Sir, value of height we can write u1 square sine square of theta 1, because height is u square sine square theta divided by 2g. So for first projectile I am writing u1 theta 1 because theta is 45 and is equal to, how to write the height of the second one? We say, sir, that will be u2 square and then I write sine square of theta 2 divided by, we say, 2g. Now can I say over here, guys, can I say over here, this 2g and 2g will cancel. So I'll write this u1 divided by u2, this square is equal to, and here I'll write sine square of theta 2 divided by sine square of theta 1, something like this. Now, this square. So I can write it u1 divided by u2 is equal to, that is sine of theta 2 divided by, I'll write sine of theta 1 over here. Okay, yes. Now guys, tell me one thing, u1 by u2, I'll write, sir, u1 divided by u2 will come out to be sine of theta 2. What is the value of theta 2? That is 60 degrees. So I'll write sine of 60 degrees divided by sine of 45 degrees. So I'll write u1 divided by u2 over here. What is the value of sine 60? That is root 3 by 2. What is the value of sine 45? 1 by root 2. Now, if you take this in the numerator, it will be root 3 by 2 into root 2 by 1. I can further write it something like this. This is u1 divided by u2 is equal to root 3 by 2 into root 2 by 1. Now rationalize, multiply with root 2 and divide with root 2. This root 2 into root 2 becomes 2. That 2 will cancel with this 2. So what will remain? Root 3 by root 2. So u1 divided by u2 will be root 3 divided by root 2. This is the answer to this particular question. Okay. Let's take a look over here. It says that relation between horizontal range and maximum height. This is the topic that we need to exactly discuss right now over here. That is the relation between range and maximum height over here. Guys, if I say, let's suppose you have launched a projectile. Let's suppose you have launched a projectile over here. And this projectile falls something like this, okay? What is the range of a projectile? What is the range of a projectile? We say when it comes to the range of a projectile, that means this. How far it can go from its initial position. And what is the height of the projectile? How height means how high it can go in this particular case, okay? Now, could you please tell me, I have told you before, what is the relation for range and maximum height? What is the relation for range and maximum height? Guys, see, when it comes to the horizontal range of a projectile, okay, and when it comes to the maximum height, when it comes to the maximum height attained by the projectile, how high it can go, that is, I have told you before, that is nothing but we say uy square divided by 2g, or this is also called the u square sine square theta divided by 2g, okay? And when it comes to, my dear friends, when it comes to the horizontal range, horizontal range, guys, we have to find that formula in which range is present and in which maximum height is present. Guys, horizontal range formula, it has 2 times of ux uy divided by g. This is what we call the horizontal range and this is what we call the maximum height. And I would want you guys to divide this particular equation with this particular equation. Divide both the equations. We say, can I write over here, that will be h divided by this r, and this will be equals to, guys, I can say, what is this? This is uy square. So over here, this is uy square divided by 2g, okay? Uy square divided by 2g. And instead of this r, I would want you guys to write over here, that is 2 times of ux uy divided by g over here. Now tell me one thing, sir, this u square and this 1 uy will cancel over here. This g and this g will cancel over here. Don't you think that what remains over here, that is uy divided by 2, and over here 2 times of ux, that will be 4 times of ux. Okay, guys, in this particular case, can I say, sir, this range horizontal, this maximum height and range will come out to be, that is uy divided by 4 times of ux. Now, I have told you in the last class, if you remember, let's suppose if you are launching a projectile with velocity u. Can I say that, sir, if this is theta, we say, sir, this is its which component, sir? This is ux component. And this one is, we say, sir, uy component. Now, Could you please tell me what is the value of this tan theta over here? Sir, tan theta here is perpendicular divided by base. And what is perpendicular? That is uy. And what is base? That is ux. Okay, this divided by this. Now, can I say the same thing over here? Sir, I can say h divided by r will be, instead of uy by ux, can I write over here tan of theta? So this is tan of theta divided by 4. Now take it over there. So I can say this maximum height is coming out to be, that is r tan of theta divided by 4. So I would want you guys to put up this particular equation in the box. Why? Because this is the relation between, we say maximum height and horizontal range. This is the relation between maximum height and horizontal range. So if in a question you are given, we say horizontal range, you can find, if horizontal range is given, you can find the maximum height. Okay. So by this particular equation. Now, we will have to basically solve the questions on this particular equation that I'll be showing you over here. Is this clear? Before everything, let me know in the chats. Is this clear? Guys, tell me in the chats if it is clear to each and every single student. If this is crystalline clear to each and every single student, let me know in the chats. And if you have not liked the session yet, I would want you guys to hit the like button as soon as possible. Guys, hit the like button as soon as possible. Is this clear? Is this crystalline clear? Great. Now guys, listen to me very carefully. Let's basically take a look at this particular question over here. Let's solve this question first. Yes. The horizontal range and a maximum height of a projectile, are equal. Okay. In this particular question, we say range is given as maximum height. Both are equal. The angle of projection of the projectile is, we are supposed to find the value of theta, angle of projection. Okay. Guys, see, we have to find, we say theta. At what angle we have launched the projectile? We have to find this theta. Guys, could you please tell me in this particular case, I'll just write this equation over here. We say, as we know, we recently saw one equation. What is that? Sir, that is, we say this maximum height, this is equal to, that is r tan of theta divided by 4. Because when only range is given and you are supposed to find the height, you can basically use this equation. Now instead of r, you can put over here h. So I can say this is equal to, h is equal to, instead of r, you'll put over here, this will be h. This will be over here, that is h, and this is tan of theta divided by 4. Okay. Now, can you tell me in this particular case, this h and h will cancel, so this will go over here. So tan of theta will be equal to 4 in this particular case. Guys, can you tell me in this particular case, okay, tan of theta is equal to 4. Now, what will be the value of theta? Theta, I can simply say in this particular case, that is tan inverse of, we say 4. Tan inverse of, we say 4. Okay. This is basically the answer in this particular case. Now, let's take a look at the next question over here. In this question, what does it say? The horizontal range of a projectile is 4 root times of its maximum height. We say range here is given as 4 root 3 times its maximum height. Okay. Its angle of projection is, here also we have to find theta. Guys, what is the relation? As we say, as maximum height is equal to r, I'll write tan of theta divided by 4. Can I write it something like this? Yes, sir. Now guys, tell me one thing. Instead of this range, I can put, so this is h is equal to. Instead of this r, I'll put 4 root 3 into, we say, sir, h, and then I'll write tan of theta divided by, we say, 4. Now this 4 and this 4 cancel, h and h will cancel. So tan of theta will come out to be 1 by root 3. Now could you please tell me at what angle the tan has, at what angle the value of tan is root 3? At what angle the value of tan is root 3? It is 30 degrees. So I can say over here tan of theta is equal to tan of 30 degrees. Why, sir? Because we know tan 30 is 1 by root 3. Either you write 1 by root 3 or you write tan 30. It's one and the same thing. So I can say theta in this particular case will come out to be 30 degrees. Is that clear? Is that clear, boys and girls? I hope everything is sorted. I hope everything is sorted. Now, let's take a look at this particular question. This is an important question. I would want you guys to basically keep this in your mind. This is an important question that we have over here. The speed at the maximum height of a projectile is root 3 by 2 times of its... Okay. The questioner says that the speed at the maximum height of a projectile is this. Its range is. Okay. It says that the speed of a projectile at its maximum height is root 3 by 2 times of its initial speed. Okay. And we are supposed to find in this particular case, what is the range of a projectile? What is the range of a projectile in this particular case? Okay. Now guys, this is the question that we are given over here. I would want you guys to try this out and let me know what is the answer of this particular question. Before this, I just want to show you this question. For an object with a ground speed u, horizontal range is 2 times its maximum height. The range, yes, this question, because this is related to r tan theta. Okay, that's the reason. Okay. So in this question, it is saying that in this question, before that, I would want you guys to see this. We say for an object projected from the ground with speed u, an object is projected from the ground with speed u. We have an object over here. It is projected from the ground with speed u. Its horizontal range is 2 times its maximum height. So it will basically follow this path. And it says that its range is 2 times the maximum height. What is the range of the projectile? We are supposed to find what is the exact value of the range. What is the exact value of the range? What is the exact value of the range? This one. Guys, tell me one thing. If a range is given in terms of height, we are supposed to find range. Guys, see. First and the foremost thing is, I would want you guys to use this particular equation. We say, sir, maximum height is equal to, we say, r tan of theta divided by, we say, 4. Maximum height is equal to r tan theta divided by 4. Now, see. Can I say in case of this, I'll write, instead of this r, I'll write 2h. So this is h is equal to, here I'll write 2h, and this is tan of theta divided by 4. Now, this is 2 1s, 2 2s. This and this will cancel. So now this will come over here. So we say tan of theta in this particular case came out to be 2. Tan of theta in this particular case came out to be 2. Guys, see. If tan theta is 2, can I say, sir, tan theta means it is perpendicular by base. So it is 2 divided by 1. Guys, I'll show you the approach over here. If tan theta is 2 means perpendicular by base, let's make the triangle over here. So in this triangle, if I say, sir, this is theta. So this is perpendicular, it is 2, base is 1. Now, could you please tell me what will be the value of hypotenuse over here? Sir, hypotenuse is root of 2 square. How do we find the hypotenuse? 2 square plus 1 square. So that is 4 plus 1, that is root 5. So this is root 5. Okay. Now, guys, first I use this particular equation we have to find the range. Now, what is the actual formula of range? Guys, the formula of range is R is equal to, we say u square, 2u square, sine of theta, cos of theta divided by g. This is the formula of range. Guys, see. We know what is the value of u. It is saying that we have launched the projectile with speed u. So u we know. Sir, g we also know. But what is the value of sine theta and cos theta? That we didn't know. So we will calculate that with the help of this relation that I have shown you over here. Now, can I say from this triangle? So what is the value of sine of theta? Sir, sine theta is perpendicular upon hypotenuse. That is 2 by root 5. What is the value of cos of theta? I say cos theta is base by hypotenuse. That is 1 upon root 5. That is 1 upon root 5 and 2 upon root 5. Now put it over here. So I can say when it comes to the range. So I'll write over here that is 2u square. What is the value of sine theta? That is 2 by root 5. So 2 divided by root 5. And what is the value of cos theta? That is 1 by root 5. 1 by root 5. And divided by, I say g over here. Now guys, can I say in this particular case, this r will come out to be? Now guys, what is this? This is 2 into 2 is, we say sir 4. Root 5 into root 5 is, we say 5. So this is 4u square divided by, 4u square divided by, we say 5g is exactly the answer in this particular case. Okay. Is this clear? Is this clear? Please tell me in the chats, everybody out there. Everybody out there. Guys, tell me in the chats. Everyone means everyone. I hope this is crystalline clear. I hope this is, guys, if you have not liked this session yet, I would want you guys to hit the like button. Hit the like button as soon as possible. Okay, liking the session, marking the attendance is extremely mandatory. Okay. Yes, great. Okay, now guys, take a look over here. Let's have a look on this question now. Okay, let's have a look on this question now. In this particular question, what does it say? What does it say? It says that the speed at the maximum height of a projectile is root 3 by 2 times of its initial speed. Let's suppose we have launched a projectile from this particular point. So it will follow this particular path over here. And it says that at the topmost point, its velocity is given as a root 3 by 2. Guys. From the concept itself, if you remember, I have told you what is the velocity at the topmost point of the projectile. Guys, at topmost point, we say this vertical component of velocity is 0. But horizontal component remains same, that is u cos of theta. Initially, it is u cos theta and it will remain same throughout the entire journey, that is u cos of theta. So we say this horizontal velocity remains same. So we say at topmost point, topmost point, I say velocity is u cos of theta. At topmost point, velocity is u cos of theta. Now guys, according to the question, they are saying that, sir, it has got a velocity of root 3 by 2 times of u. Okay. Now, according to the question, we say at topmost point, we say velocity is given as, that is root 3 by 2 times of u. This is according to the question. This is according to the concept. Don't you think that, sir, we can equate both the two equations? So I'll write over here. So I can say in this particular case, that is u cos of theta will be equals to, that is root 3 by 2 times of u. Now this u and u will cancel. Cos theta is root 3 by 2 When is the value of cos theta as root 3 by 2? I'll say, sir, cos theta is equal to, we say, cos of 30 degrees over here. Why? Because root cos 30 is root 3 by 2. So I can say over here in this particular case, theta will come out to be 30 degrees. Now, guys, we got the value of theta. What we are supposed to find? Let's find out the range now. Now find range. Now let's find the range. Now let's find the range. So I can say, sir, range is equal to, that is u square sine of 2 theta divided by g. This is the formula of range that we have studied. Now I can say this range will be simply u square, u is the initial velocity, that is u square, sine of 2 theta, sine of 2 into, what is the value of theta? Theta is 30 degrees over here, and divided by, we say, g. So r will be equal to sine of 2 into 30 is 60, sine 60 is root 3 by 2. So u square divided by g, and this is a root 3 by 2. This is the answer to this particular question. This is the answer to this particular question. That is u square divided by g, root 3 by 2 multiplied by root 3 by 2. I hope this is crystalline clear. Guys, let me know in the chats. Everyone means everyone. Okay? Is this crystalline clear? Is this crystalline clear? Is this crystalline clear? Please tell me in the chats. Ladies and gentlemen, boys and girls. Is this crystalline clear? Then we will move on to the next topic. That is conditions of maximum horizontal range. Conditions of maximum horizontal range. Okay? Yes. See guys. Let's suppose I say you are launching a projectile over here. I say you are launching a projectile over here. Okay? Sir, if you are launching a projectile, if you are throwing a projectile, sir, how can I get the maximum range? This range should be maximum. It should go very far. Okay? What is the condition for that? What is the condition for getting the maximum horizontal range over here? Okay? Guys, see. We say, as we know, maximum range is what? Sir, how should you throw a projectile so that the range comes out to be the maximum, so that the range, it should go very far. So we know what is the formula for range. R is equal to, we say u square sine of 2 theta divided by g. This is the general formula for the horizontal range. Okay? Yes. Now guys, you want this range to be maximum. See, this g is constant. Let's suppose you are throwing two projectiles, one projectile, another projectile, and you are throwing them with the same speed. So can I say in that particular case, for those two projectiles, u is also constant? Why, sir? Because you are throwing the two projectiles with the same speed. If you are throwing this and this, both these projectiles with u and u, so means u will become constant for these two. G is constant, u is constant. So I can say this range depends, we say upon, we say sine of theta, or I can simply say sine of 2 theta. Okay? This range depends upon sine of 2 theta. This range depends upon sine of theta. Okay? Yes. This range depends upon sine of theta. Now guys, I would want you guys to focus over here. This r depends upon the sine of theta. So if you want range to be maximum, then the value of sine theta should be maximum. So if sine of theta is maximum, then range will be maximum. As simple as that. If sine of 2 theta is maximum, we say range is maximum. And guys, you might have heard one thing. When is the value of sine theta as maximum? Sir, maximum value of sine theta is 1. We say as maximum value of sine is 1. Sir, maximum value of sine is 1. So I can say in this particular case, so here sine of 2 theta, because here it is given sine of 2 theta, it should be equal to 1. If sine of 2 theta becomes equal to 1, then I can say in that particular case the range will come out to be maximum, because this is the maximum value of sine theta. Now can I say when is the value of sine theta as 1? Sine 90. So I'll write sine of 2 theta is equal to, I'll write over here sine of 90. So I'll write, sir, sine will go. So this 2 theta is equal to 90. 2 ones are 2 45s are. Theta will come out to be 45 degrees. So what I'm trying to say in this particular case is, if you throw a projectile at an angle of 45 degrees, we say range will come out to be maximum. Why? Because at 45 degrees, sine of 2 theta will be 1. Because 2 into 45 is 90. Sine 90 is 1. So if maximum value of sine is 1, so you'll put the maximum value of sine over here. You'll get the maximum range. I hope this is clear. Or simply remember, sir, if the value of theta is 45 degrees, the range will come out to be the maximum. So we say, so if theta is equal to 45 degrees, then range of a projectile is maximum, then range of a projectile is maximum. Okay, now guys, see. Sir, how much is that maximum range? Could you please tell us what is the maximum range? Now, guys, see, I can say, sir, R max I'll write over here. That is u square sine of 2 theta. So I'll write over here, that is u square sine of 2 into, what is the value of theta? Put the value of theta as 45 over here, because at 45 range is maximum. And divided by, I say g over here. 2 into 45 is 90. Sine 90 is 1. So maximum range, R maximum, will come out to be u square divided by g. So this is the value of maximum range. Please tell me in the chats, everything is crystalline clear. Please, I need the signal from every single student. Everyone means everyone, guys. Let me know in the chats if everything is crystalline clear. Everyone. And do like this particular session. Now, if R is the maximum horizontal range of a projectile, then the greatest height attained by it is, we are supposed to find the greatest height, maximum height. See guys. It says that if R is the maximum horizontal range, we say if R is the maximum horizontal range, if R is the maximum horizontal range, now we say then we can say theta is equal to 45 degrees, because maximum range is only possible when theta is equal to 45 degrees. Okay, now we are supposed to find what is the greatest height. Guys, see, as we know, as I can say height is equal to R, we can say tan of theta divided by 4. So what is the value of theta over here? That is 45. So I can say H is equal to R. I'll write over here tan of 45 degrees divided by 4. Tan 45 is 1. So in this particular case, H will come out to be R divided by 4. So this will be the greatest height attained by the projectile. At maximum range, this is the greatest height attained by the projectile. Now take a look over here. Now take a look over here. Now take a look over here. See guys, range for two different angles is same. A range for two different angles is same. Range for two different angles is same. See guys, what does this actually mean? What does this actually mean? Let's suppose I am throwing the two projectiles over here. Let's suppose I am throwing the two projectiles over here. Okay. Let me show you. This is the first projectile and this is the second projectile. This is the second projectile. Okay. Guys, see. This first projectile is launched at some angle. This is launched at some angle. And this second projectile is launched at another angle. Or let me show you over here. Let me show you over here. So we say, yes. Guys, see, this projectile is launched at some angle. This projectile is launched at some angle. Okay. And in this particular case, my dear friends, if I am saying, let's suppose this is launched at an angle of theta. And if this is 90 minus theta over here, guys, we say, if this is having the range R1 is equal to R, this will be also having the range R2 is equal to R. Means, sir, range for two different projectiles is same. Yes. If you are throwing this projectile at an angle theta, another projectile you send or you throw at 90 minus theta, both will have the same range. Both will have the same range. Let me show you. Let me show you. Guys, let me show you. We say for this, let's talk about R1. Well, how to find the range of a projectile? Sir, range of a projectile is simply, that is u square sine of 2 theta divided by g. This is the formula? Yes. Let's find this, range of this. So I'll write R2 is equal to. So that is, and let's call this as R. Sir, this is equation of this. Let's suppose we are throwing this with u, we are throwing this with u. So this is u square sine of 2 into. What is the angle over here? 90 minus theta. Instead of theta, I'll write 90 minus theta divided by, we say, g. So I'll write this R2 in this particular case, that is u square sine of 2 into 90 is 180 minus 2 theta divided by g. Guys, sine of 180 minus theta is how much? I say sine of theta. And sine of 180 minus 2 theta is how much? We say sine of 2 theta. So I'll write over here, this R2 will be u square sine of 2 theta divided by g. Even if you keep the angle, if you put the angle as 90 minus theta, then also the range is coming out to be, we say, sir, R. Because here you see range is exactly same. So means at theta and 90 minus theta, range is same. So I'll say over here, so at theta and we say 90 minus theta, I'll say range is same. Range is same. And at theta and 90 minus theta, we say range is same. Now guys, if I say, let's suppose theta is equal to 30 degrees. At what angle range will be same? We say, sir, another will be 90 minus 30. How much is that? That is 60 degree. Means 30 degree and 60 degree range will be same. If I say theta is equal to, we say 10 degrees. So at what angle range will be same? 90 minus 10, that is how much? We say, sir, 80 degrees. So I say 80 degrees. At 10 and 80 range is same. Okay. If I say this theta is equal to, let's suppose, 20 degrees. At what angle range will be same? 90 minus 20, that is 70 degrees. So at 70 and 20 range is same. At 80 and 10 range is same. At 60 and 30 range is same. Accordingly, you can see further different combinations over here. Okay. Now, this is the important question. This is the important question, which I would want you guys to focus over here and solve this particular question. See, guys, what is given over here? A projectile is fired at an angle of 45 degrees with the horizontal. You have got a projectile over here. You have fired a projectile over here at an angle of 45 degrees. Okay. Let me show you over here. You have fired a projectile at an angle of 45 degrees. So this angle is given as 45 degrees. Elevation angle of the projectile at the highest point will be, guys, let me show you what is this elevation point. This is the topmost point. This is this point, launching point. I want you guys to join these two. Okay. Now, angle between this line and this horizontal axis, this is what we call the angle of elevation. That is alpha. You are supposed to tell me what is the value of this alpha. Guys, see, if we draw a line over here, don't you think that, sir, this is the maximum height? And from this point to this point, this is range. Don't you think that this is r divided by 2? This is half of the range. From this triangle, you can see over here. In this particular case, theta is given as 45 degrees. We are supposed to find the value of alpha. Okay. How can we find the value of alpha? So I say over here, sir, this tan of alpha, I can simply say, that is this perpendicular by base in this triangle I am saying. What is this perpendicular? That is h. And what is base over here? That is r by 2. So this will be simply, that is 2h divided by r. So this came out to be tan of alpha. Cool? Absolutely cool. 100%. Now guys, this h, I need to change over here because I don't require this h over here. See guys, we say as we know. Is there any formula between h and r? Yes, sir. This h is equal to r tan of theta divided by 4. I know this formula. I would want you guys to put up this in this particular equation. Let's call this as equation first. I say, put in the equation first. I would want you guys to put up this in the equation first. If you put this in the equation first, I can say tan of alpha will be, here it is 2 divided by r. Instead of h, I would want you guys to put up this over here. That is r tan of theta divided by, we say, 4. Now 2 1s are 2 2s are 4. Now this r and this r will cancel over here. So I'll say, sir, tan of alpha is equal to tan of theta divided by 2. Now what is the value of theta? Theta is given as 45 degrees. So I can say in this particular case, tan of alpha is equal to tan of 45. Tan of 45 divided by 2. What is the value of tan 45? We know value of tan 45 is 1. So I'll put up over here. So tan of alpha will come out to be 1 divided by 2. So can I say alpha will be tan inverse of 1 by 2. Alpha is tan inverse of 1 by 2. Is this clear? Is this clear? Is this clear? I hope this question is also sorted. Yes. The speed of a projectile at its maximum height is half of the initial speed. At its maximum height is half of the initial speed. The angle of projection is, you guys are supposed to tell me what is the angle of projection in this particular case. Come on guys, give it a shot. Let me know the answer of this particular question. Okay, what is the answer? Let me know in the chats, everybody. At topmost point, at maximum height, it is saying its speed is half of the initial speed, that is u by 2. See, let's suppose you have launched a projectile over here. It says that at topmost point, how much is the speed? We say, sir, at topmost point, it is saying u by 2, because if you are launching it with velocity u. And also we know at topmost point, what is the speed? That is u cos of theta. This is according to the concept. This is according to the question. So can I say in this particular case, u cos of theta will be equal to u by 2. This and this will cancel. So cos of theta will be 1 by 2. When is the value of cos theta as 1 by 2? Okay. So when it is 60 degrees, so cos of theta will be equal to cos of 60. So I can say theta will be equal to 60 degrees. Okay. Great, 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 great. Next. Let's take a look at this. That is horizontal projectile. That is horizontal projectile. Okay. Now guys, take a look over here. Horizontal projectile. What does this horizontal projectile actually mean? What does this horizontal projectile actually mean? I would want you guys to focus over here. See guys, when it comes to the horizontal projectile, it means you are launching a projectile from certain height. You are launching a projectile from certain height. You are throwing a projectile from certain height over here. Okay, this is what we call the horizontal projectile. So it will follow this particular path. We say when a projectile is launched, from certain height, when a projectile is launched from certain height horizontally, it is what we call the horizontal projectile. Okay. Now guys, you know this projectile motion is the combination of horizontal and vertical motion. So I'll write this as horizontal motion over here. I'll write this as vertical motion over here. Guys, see. We say initially, let's suppose you are throwing it with the velocity u. I would want you guys to focus over here. Can you tell me what is the initial velocity in x direction over here? Sir, this velocity is completely in x direction. No doubt, sir, when you throw it, sir, because of the gravity attracts it. So it will follow this particular path. It wanted to go straight, but because of the gravity, it will follow this particular path. So initial velocity in x direction is completely u over here. This is the initial velocity in x direction. And could you please tell me initially what is the velocity in y direction? Sir, initial velocity in y direction is 0. Why? Because there is no velocity in y direction. Complete velocity is in the x direction. The whole velocity is in the x direction. Could you please tell me, is there any force in x direction? We say force in x direction is 0. So means acceleration in x direction is 0. Because no force is acting in the x direction, okay, in case of a projectile motion. But when it comes to y direction, force is in y direction is gravity. Okay, and I'll write that is m into g. And what is the acceleration in y direction? That is g. We have already discussed it. That is g. Okay, and we take it minus g always. Now guys, tell me, listen to me very carefully. Let's suppose when the particle reached this particular point over here. Okay, okay. I say at this particular point, let's suppose it has velocity v. This velocity will have horizontal component, that is vx. This velocity will have vertical component, that is vy. And let's suppose this angle over here is alpha. It is making the alpha angle with the horizontal, this velocity. Now, can you tell me what is the velocity in x direction finally? Guys, see, we say Vx is equal to u plus a into t. Use this in x direction, use this in x direction. Can I say velocity in x direction finally? This velocity I am saying. Initial velocity in x direction is u. What is the acceleration in x direction? That is 0. So this term will become 0. So it is u. So it is ux. So means here also, velocity in x direction remains constant. But when it comes to the y direction, so I say Vy is equal to Uy plus Ay into t. Let's use this. So we say, sir, velocity in y direction finally. So I say initial velocity in y direction is 0. So acceleration is minus and acceleration is minus g into we say, sir, t. So this velocity is minus gt, this velocity is ux. Okay. Okay. I hope this is clear. Also, you can find the value of this tan alpha. Also, guys, see. This is over here velocity v. This is the horizontal component, that is vx. This is the vertical component, that is vy. And this is alpha. Don't you think that we can write this tan alpha is perpendicular by base? So I can say tan of alpha is, that is we say vy divided by vx. Perpendicular by base. Now, how much is Vy? Vy in this particular case is, I'll write minus gt divided by, how much is ux? That is u. Minus gt divided by u. Guys, is this clear till over here? Is this clear till over here? Okay. Okay. Even you can find this velocity also. Okay. Okay. I'll find this velocity also. Also, guys, we can say this velocity will be simply, that is Vx into I cap plus Vy into J cap. This is how we can find it. So this velocity will be, what is the value of Vx? What is the value of Vx? Vx is Ux only, that is U only. So this is Ui cap and Vy is minus GT into J cap. Okay. You can write it something like this. This is the velocity. And you can find the magnitude of this velocity also. That is under root of U square plus we say minus GT whole square. This is the velocity in this particular case. Let's now find the time of flight. Guys, what is this time of flight? Let me show you over here. Let's suppose this is the building that we have got over here. Okay. And in this particular building, you are throwing a projectile over here. Okay. From this building, you are throwing a projectile. So we say it follows this path. How much time it will take to complete its journey? Okay, so that is what we call the time of flight. How much time it will take from this point to this point? I would recommend you to use one equation. We say I would say S is equal to ut plus 1 by 2 at square. And use this equation in y direction and y direction. Okay. Let's suppose the height of this tower is, let's suppose h. The height of the tower is, let's suppose h. Okay. Okay. Now. So I say, guys, you are supposed to use this equation from this point to this point. Okay. Use this equation from top to bottom. from top to bottom. Okay, yes. Now, how much is the displacement in y direction, guys? So I say that is h. What is the initial velocity in y direction? Sir, we have launched it with a velocity u horizontally. Initial velocity in y direction is 0. So this is 0 into, we say, sir, t plus 1 by 2. What is the acceleration? Acceleration is minus g. So I'll write that minus over here. 1 by 2 g t square. Okay. Now, guys, see. I have told you so many times, if the ball comes down, take the height negative. If it goes up, take it positive. So I'll write minus h over here. Now I can say this minus h is equal to minus 1 by 2 gt square. Minus and minus goes. Okay. Now this goes over here. This is 2h divided by g will be t square. So from this you can say, this t will be under root of 2h divided by g. So this is basically the time of flight, how much time this projectile will take from this point to this point. Now let's move on to this one. A range of a horizontal projectile. Range of a horizontal projectile. Guys, see. Let's suppose you are throwing this projectile from this building. Okay, you are throwing this projectile from this building. It will follow this path. How far it can go? That is what we call the range. Okay. And I would recommend you to use S is equal to ut plus 1 by 2 at square in x direction. Okay. Use this equation in x direction. Now, how far it can go, that is what we call the range. That is the horizontal displacement is equal to. Now, guys, see. Initial velocity in x direction. Guys, here this x direction has u initial velocity. Complete velocity is in the x direction only. So that is u into time is, we say, sir, t. It is taking time t from here. Then we say plus 1 by 2. Acceleration in x direction is how much? That is 0 into t square. So this whole term will become 0. Can I say in this particular case, this range will come out to be u and. What is this? This is u into t. Now, guys, what is the time period that we recently got? That is under root of 2h by g. So you can write this also, that is u, and then we say under root of 2h divided by g. This is the formula for the range that we have. Okay, this is the formula for the range. Now this is the question, that is alpha. How to find this alpha? That I recently told you. Tan of alpha is simply, that is perpendicular divided by base, that is gt divided by u. Simply gt divided by u. Now, guys, ball is projected with 30 meters per second in horizontal direction from some height. Find time when it is making 45 degrees from the horizontal. Guys, it is saying that we have launched a projectile from certain height. From this height, we have launched this projectile. Okay. Now this projectile will, let's suppose, follow this particular path over here. This projectile will, let's suppose, follow this particular path over here. And it is saying that ball is projected with 30 meters per second. So this velocity is given as 30 meters per second in horizontal direction. Find the time when it is making 45 degrees. Guys, let's suppose here, this ball is making, let's suppose, 45 degrees with the horizontal. Okay. We are supposed to find what is the time at this particular point. Easy question. Okay, guys, see, if this is v, can I say this is vx and can I say this is vy? And what is the value of vx? That is u. What is the value of vy? That is g and t. Tell me, guys. Can you tell me the value of tan of 45? Guys, tan of 45, or we say this is tan alpha. That is this gt divided by u. So I can say that is gt divided by u. What is tan 45? That is 1. Okay.
So this is 1 is equal to G is how much? That is 10. And this is T. And what is U? U is 30. U is given as 30. Okay, this and this will go. So T will come out to be, that is 3 seconds. So we say after T is equal to 3 seconds, the ball will be making 45 degrees with the horizontal. Ball will be making 45 degrees with the horizontal. Okay. One more question you have got over here. A plane is moving with 500 meter per second. There is a plane, okay? This plane is moving with 500 meter per second. 500 meter per second. This is its velocity. This is the value of u. At a height of 2000 meters. So this height over here is given as, h is given as 2000. At what distance should I drop the bomb so that it hits the target? Let's suppose it is dropping the bomb over here. Okay, this is the bomb. Okay. Now, here is the target. Here is the target. It has to hit the target. Do you think that when the plane is over here, then it has to launch this particular bomb? No. It has to drop this particular bomb over here? No. Because if you drop it over here, it will fall and it will hit over here. So it has to basically leave it before. So it has to leave it somewhere around over here. Then only this bomb will follow this projectile path and it will hit the target. So we are supposed to find at what distance it should basically leave this bomb. So kind of we are supposed to find the range over here. What is the range of this projectile? Okay. So how to find the range of the projectile, sir? When it comes to the range, we say u under root of 2h divided by g. Everything is given. Everything is given in this particular case. So I say over here r is equal to, what is the value of u over here? That is 500 under root of, then we say 2. How much is the height? Height is 2000. 2000 divided by, we say g in this particular case is 10. Okay. And if you solve it, it will come out to be 10,000 meters. 10,000 meters, that is 10 kilometers. So means you have to initially leave it before 10 kilometers, then only it is gonna hit the target. It will hit the target. Okay, this one. Let's suppose we have got this over here. A particle starts its motion from the origin, moves in the xy plane with a constant acceleration alpha and y. Its equation is its velocity component. This is your homework. Okay, I'll give you some questions as homework. I would want you guys to solve these questions, okay, from your end. And then another question says that a body is thrown horizontally with a velocity root 2gh from the top of the tower of height h. It strikes the level ground through the foot of the tower at distance x. Find the value of x. You are supposed to find the range over here. This is also homework in this particular case. Easy questions. Okay, here you have to find the range. Here you have to find the range. And last one, yes, this is a good question over here. This is a good question over here. Now, guys, I'll give you the idea of this question. I would want you guys to focus over here. See. A ball is projected upwards from the top of a tower. अब देखो. Now guys see. It says that a ball is projected from the top of a tower. This is a tower. This ball is projected upwards from the top of a tower. Okay. With a velocity of 50 meter per second. This velocity is given as 50 meter per second. Making an angle of 30 degrees. So it is making an angle of 30 degrees with the horizontal. The height of the tower is 70 meters. Height is given as 70 meters. After how many seconds from the instant of throwing, the ball will reach the ground? We are supposed to find the time. Now see how can we find the time over here.
If this ball we are throwing with a velocity of 50, guys, which component of velocity this will be, sir? This will be 50 cos of 30. Why? Because if this is u, this will be u cos 30. Because theta is from this side, so u cos 30. 50 cos 30. And can I say this is 50? What is the value of cos 30? That is root 3 by 2. 2 ones are 225s are. So this will come out to be 25 root 3. So this is what we call the ux. And if I talk about the velocity uy, so can I say uy in this case will be, that is 50 sine of 30, because this will be the sine component? Yes, sir. Now tell me, sine 30 is 1 by 2. So this will come out to be 25 meter per second. So uy is 25, ux is 25 root 3. Now it will basically follow this particular path. It will follow the path something like this, and it will hit the ground. Okay. Now guys, how much time it will take in this entire journey? That is what we are supposed to calculate over here. See, I say use S is equal to ut plus 1 by 2 at square in x direction, in y direction, okay. I would want you guys to use this equation in y direction, okay. Guys, see, so means you have to use it from top to bottom. So we say from top to bottom. Now, if we use this particular equation over here, guys, if we use this particular equation over here, if we use this particular equation in this particular case, see, I say this sy, what is the value of sy over here? Sy means, sir, how much is the displacement in y direction? If you are throwing the particle over here, so whatever the distance it will cover, we don't have to focus on that. We have to see how much displacement it will do in y direction. That is only 70 meters. So displacement in y direction is only 70, because it is between the initial point and final point. Final point is ground. Initial point is this. So it is equal to initial velocity in y direction. Guys, how much is the initial velocity in y direction? That is 25. So I'll write over here 25t. Okay. Yes. Now tell me one thing in this particular case, my dear friends. So this will be, sir, 1 by 2, and I'll write minus 1 by 2 because acceleration is negative, minus 10. So 1 by 2, we'll take acceleration as minus 10 meter per second square, 10, and this is t square. 2 ones are 2 5s are, okay. And this ball is coming down over here. So we'll take this as minus, we'll take this as negative. Okay. This height will take as negative. Now tell me in this particular case, how are we supposed to write it? Guys, this will be minus 5t square. Okay. So do one thing, take it over there. So this will be 5t square. If you take it over here, it will become plus. Okay. Now if you take it over there, it will be minus 25t. Because it is plus over here, it will become minus. And already from that side, this is 70 is equal to 0. Now take this 5 common. So I'll write, sir, this is t square minus 5 into 5 is 25. So 5t minus 14 is equal to 0. So this will be the equation, quadratic equation. And if you solve this quadratic equation, value of time will come out to be 7 seconds. Oh, okay. So we say it will take 7 seconds from this point to this point. Okay. Great. Now guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible, and do let me do tell me in the comments later on how was the session. Okay.